will be a Starfreelancer. Learn new skills. Set your goals, increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Hi, welcome back. I am Kalyan Reddy Daida and I will be your instructor in this EKS Kubernetes Masterclass course. So let's see the course outline on a high level. So this outline is also going to be very detailed because the course is also a very longer course which hits close to 20 hours, and outline also we need to understand in detail before going in. So we'll see what all concepts we are going to cover as part of this course. So we have divided the topics into 4 major sections. So which is Kubernetes concepts, AWS services integration with EKS, means like what all AWS services we can use in relation with Elastic Kubernetes service of AWS, and DevOps concepts, and then microservices concepts. So let's see what all covered under Kubernetes concepts. So close to 30 Kubernetes concepts are covered as part of this entire course, and whenever we are writing these concepts related YAML declarative files, we are going to do a live template writing sections wherever it is required. So in addition to that, covering all these Kubernetes concepts, we also cover integration with close to 18 or 19 AWS services in relation with EKS, which is Elastic Kubernetes Service. For example, you can see here, so this is EKS, and then we'll have Fargate, we'll have Certificate Manager, we'll have Route 53, we'll have Elastic Block Store, and RDS database, and then Elastic Load Balancing with Classic Load Balancer, Network Load Balancer, and Application Load Balancer with Ingress Service. So like this, all whatever the possibility is there which are in integration with EKS, we have tried to get them under this course. And next thing is DevOps, right? So from DevOps perspective, using AWS code services, we have implemented a DevOps pipeline to understand it better for both the applications and also the Kubernetes manifest. So which means like if you make any change to your Kubernetes manifest and then check in that code, that will get deployed to your Kubernetes cluster. If you make any changes to your application and then check in your application code, so it will build a new Docker image and then deploy to the Kubernetes cluster. So both ways the pipeline is built for you. And next is microservices. So from microservices perspective, the core concepts in relation with Kubernetes will be service discovery, distributed tracing, and then canary deployments. So those also we have looked into. Before moving on to bigger things in Kubernetes, so we are going to learn both Docker and then Kubernetes fundamentals in the fundamentals section. So there will be a dedicated Docker fundamentals section available for us. So where we build a simple Docker image, push it to Docker Hub, and then even pull from Docker Hub and then understand the Docker terminology like what is Docker registry, what is Docker Hub, what is Docker image, what is container. So we'll understand all those things in the Docker fundamentals section. And then we'll move on to Kubernetes fundamentals section, wherein we will primarily focus on implementing Kubernetes concepts using imperative way and then declarative way. So here we do lot of live template writing in the declarative way and then lot of Kubernetes kubectl commands in the imperative section, and then get a full idea about Kubernetes from pods, replica sets, deployments, and then services perspective. And from there we'll jump on to big course. So we will start with in this course with the EKS storage with EBS CSI driver, which is Elastic Block Store, and then we will implement and then learn. As part of that, we'll learn how to write a deployment, how to write a MySQL cluster IP service, or how to write a node port service, and environmental variables, how you are going to define, and volumes, volume mounts, everything, whatever is related to this respective section. You will do a live template writing here and then understand all these concepts and then provision these things from your Kubernetes manifest. So, and then you will understand about what are the drawbacks of using EBS CSI driver and what are the advantages you are going to get using RDS database. And then later, using external name service, you are going to implement it with RDS database. So now you have completed the database part. with the storage section of storage classes, persistent volume claim, config maps, all those things. So then you will move on to load balancers section, right? So before moving on to load balancers section, whatever you have implemented, its equivalent network diagram looks this way. So now anyway, we know that load balancers need to run on public subnets, and then our workloads need to run on private subnets. So to do so, what you are going to do, immediately you are going to delete this respective worker nodes here and then move your workloads to your private subnets. So you are going to do this and then ensure that you create a classic load balancer in your public subnet and then access it. So now you have implemented your classic load balancer related manifest also, in addition to your this whole manifest whatever you have built earlier. And then you will move on to also creating a network load balancer manifest and then testing it. So now you have used classic and then network load balancer. So now you will move on to the ingress service, which is super advanced and then with tons of features inside that. So with the ingress service, you are going to implement context path based routing using, means like with 3 applications you are going to deploy, and then you will implement the context path based routing with /app1 should go to app1, app2 should go to app2, and then anything other than that should go to user management microservice. In addition to that, in the same ingress service, you will implement SSL. So you will enable the SSL for your application here, okay? And then you will also implement HTTP to HTTPS redirection using SSL redirect. And finally, in ingress load balancer, ALB ingress load balancer, you are also going to implement external DNS. So external DNS, what it does is automatically from the Kubernetes manifest, you are going to register your domain name in the Route 53 service. So that also you are going to do. So all these things once completed, means like we have completed the database part, we have completed the deployments part, and we have completed the load balancer part. So then what comes next, right? So how to run these in Fargate serverless. So we'll move on to that section, okay? So in Fargate serverless, what we do is like we will run our workloads in a mixed mode in such a way that we will run few workloads on our regular managed node groups with EC2 instances, and then we will also run our Kubernetes pods on Fargate. So we are going to implement this with again 3 applications, app1, app2, and then UMS in a mixed mode deployment. So wherein app1 is running on the EKS managed node groups and UMS, and then app2 is running on EKS Fargate profiles. So this one also we are going to look into in detail. And then once we complete the Fargate, so we'll move on to understanding about Elastic Container Registry. So in relation with EKS, Elastic Kubernetes Service. So for that purpose, what we do is like we'll move on with creating a new Docker image and then push it to the Elastic Container Registry, and then use the Docker image in our Kubernetes cluster by deploying the workloads. So that one we are going to test, and as usual we'll continue with our ingress load balancer for all these sections also. Anyway, we have implemented earlier here, so in our application load balancer section. So we'll continue to use that ingress load balancer in all the upcoming demos for getting complete hands-on that respective section too. Then we'll move on to the DevOps section and understand the release processes, source, build, test, and then production. And we'll also understand about continuous integration, continuous delivery, continuous deployment, and then infrastructure as code concepts. And then move on to understand about how we are going to implement the DevOps concepts in AWS in relation with Elastic Kubernetes Service. So we'll understand about code commit, check in the sample code here, and we'll do the code build, means like we'll generate the artifacts and then we'll deploy them to our respective EKS cluster using kubectl and code build combination. And then we are going to monitor our applications using CloudWatch Container Insights. So we are also going to implement this DevOps use case, right? And then we'll move on to the microservices section with 2 independent microservices built exclusively for testing microservices service discovery and then microservices distributed tracing, and then microservices canary deployments. So we are going to use these two services, user management microservice and then notification microservice, and then implement the full use case. Okay, so whenever you as a developer, when you use Postman client and create a user, it will call the notification API and then send an email to end user. So these two microservices using service discovery, how you are going to deploy to AWS, EKS, and then this is the way we are going to deploy. So here we'll have UMS node port service, MySQL external name service, notification cluster IP service. So entire service discovery, how you are going to handle it in relation with EKS, you are going to implement end to end. And then you will move on to the next section of distributed tracing. So for distributed tracing, you need to deploy your daemon sets with X-ray pods. So using Kubernetes daemon sets concept, you are going to deploy the X-ray pods, and this user management microservice application and then notification microservice application, what we have done here is like, so we have implemented X-ray using X-ray SDK in those things. So when you deploy those applications, so how the X-ray is going to behave and then what happens. So using distributed tracing, we are going to see in detail. So whenever distributed tracing is enabled, you can see the service map such a way that the request from client comes to user management microservice and then calls the notification microservice. So everything you are going to see in detail. From there, you will move on to traces also. In X-ray traces, if you see here, so the request came to user management microservice, and inside that application, it went to get notification app info method, and from there it went to Kubernetes service notification cluster IP service, and from there again it called the V1 notification microservice, which in turn called the, means like inside that notification app version service method was called. So these traces also we are going to look into in detail as part of this section. And then finally for microservices, we are also going to do the canary deployments, right? So whenever we call the user management microservice, there will be two versions of notification service will be live, and the traffic will be distributed based on how much we configure, 50-50 or 75-25 like that. So it is going to do the traffic distribution to V1 notification and then V2 notification microservices. And using Kubernetes out of the box features, whatever is available with the pod number changing, we are going to implement this canary deployments. So from there, we will move on to horizontal pod autoscaler, vertical pod autoscaler, and also cluster autoscaler. So all the HPA, VPA, and then CA concepts we will implement in detail, and then we will move on to the container insights concepts, which is nothing but Kubernetes monitoring and then logging section. So we are going to use CloudWatch agent daemon set in our Kubernetes cluster to get the metrics of all our Kubernetes cluster and then applications deployed inside that. In addition to that, we are also going to deploy FluentD daemon set, which will get the application logs and then Kubernetes cluster logs for us inside the CloudWatch. So as a developer, you are going to see container map and then container resources, performance dashboards, log groups, log insights, and then alarms. So you are going to implement all these things in a detailed manner. You will implement alarms, you will understand about log insights, and then from log insights, you are going to create the dashboards. So all these things you are going to do as part of container insights. So this is a quick view about the container insights map. So in EKS demo cluster, you can see that in Amazon CloudWatch namespace, you can see FluentD and then CloudWatch agent pod is running. In Kube system namespace, you can see kubedns, AWS node, and then kubeproxy related pods are running. And in default namespace, whatever the application you have deployed, so those are running. Sample Nginx service, sample Nginx deployment related pod. So all those things are running. So all in all, we are going to do all these things as part of this course. So in our next lecture, we are going to see our GitHub repo and then understand how to move on with this course. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to look into 3 GitHub repositories available for this masterclass course. So we'll have AWS EKS Kubernetes Masterclass under Stack Simplify, and also 2 more repositories. You can see it here under the course modules for Docker Fundamentals, 1 repository, and Kubernetes Fundamentals, 1 more repository. So in detail, you will have everywhere, wherever you go, you will have a step-by-step documentation available for all the things. Okay, so everywhere you will find a detailed step-by-step instructions, including the kubectl commands you need to deploy and the Docker images you need to execute and everything. Okay, so all these 3 repositories, you can either fork it and then log into your GitHub repo and then fork it so that you have everything at your place, means like at your GitHub repo, or you can download them as a zip and then unzip and then use it from your local desktop. So anything is fine. Okay, so now if you see here, so all these things, right? So one more thing you need to understand here is in every of the sections, right? In any of the sections, you will find something called kube manifest folder. So inside that only you will find all your Kubernetes manifests for whatever the use case you are implementing, everything will be found there. Okay, so when you are progressing through the course, you are going to understand in detail, but I am just trying to explain you that the kube manifest folder is for mainly holding the Kubernetes manifests in entire course. This completes the introductory part of Kubernetes Masterclass on AWS. So we'll start with hands-on exercises from our next lecture. Primarily, we'll start with creating a EKS cluster using EKS-CTL in our next lecture. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about 3 types of CLIs required for our AWS EKS clusters. In simple terms, to manage our application workloads on EKS cluster, we need to install 3 types of CLIs, command line interfaces. So the 3 types are AWS CLI, kubectl, and then EKS-CTL. So AWS CLI, we can control multiple AWS services from the command line and automate them through the scripts. So this is a generic definition about AWS CLI, but why we need it for EKS cluster? So why we need it is, like, once we configure the AWS CLI and then provide the security credentials on our local desktop with AWS CLI, using kubectl and using EKS-CTL, we will be able to manage our cluster and our cluster objects and also our applications on Kubernetes clusters. So all those things are required. For that purpose, we need to primarily install the AWS CLI as the underlying base. Next is the kubectl. So kubectl, we can control Kubernetes clusters and objects using kubectl. So most of the time in our entire course, we are going to do everything with kubectl only. So we can see step by step in our upcoming lectures. So EKS-CTL. So this is very, very important and powerful tool for managing the Elastic Kubernetes Service clusters. So we even have the AWS Management Console, wherein we will be able to create the cluster and then create the node groups. You will understand about these objects in our upcoming lectures. What is this cluster and then what is control plane, all these things. But for now, need to understand here is like EKS-CTL is the better tool than the AWS Management Console as on today. So if using EKS-CTL, we will be able to create and then delete the clusters on our AWS EKS. In addition to that, we will be able to create, autoscale, and then delete the node groups. And we'll also be able to create the Fargate profiles using EKS-CTL. In short, it is a very, very, very powerful tool for managing EKS clusters on AWS. So let's go to our GitHub repo and then look into our steps what we are going to perform. And in 01, EKS create clusters using EKS-CTL. So as a first step, we are going to do the install CLIs now. So in our next lecture, we'll focus on installing the AWS CLI. I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to install the AWS CLI on our Mac. So we need to first download the AWS CLI binary, which is CLI v2 version. So we are going to use the latest version. These are the reference links for you to follow the documentation if you want directly from the AWS. So I just cut short and then used only whatever is required for me directly to install on Mac. So I'm just going to download the binary and then install it. So it's going to get downloaded, and once it is downloaded, so using sudo installer, I'm going to install the binary. So let's do that now. So let me provide my password. So it's installing now. So once installed, so let's verify the version, right? So we should be in the latest version, 2.0, right? 2.0.22 as on today, right? So now we will go to configuring the AWS command line. So if you want to install it on your Windows 10, so you can follow these steps. And in addition to that, you have the reference documentation link to install it using the link also. Means like you can go to that link and then follow the AWS steps provided for installing it on Windows. So let me close these things and then go to configuring. So we need to go ahead and then generate the security credentials for our IAM account and then configure them on our command line. So let's do that now. So in the AWS management console, so let's search for IAM and go to IAM and go to users, and I have the user Kalyan who is an admin user. So let me go to security credentials and then create the access key, right? And using this access key, we can copy it and then we can come here and then say AWS configure and paste the access key here and the secret access key, right? And your default region I'm going to select as US East 1 and my output is going to be JSON. So I configured it. So the next thing is to verify it, so whether it is successfully configured or not. So if I say AWS EC2 describe VPCs, I'm trying to execute some of the CLI command, means like one CLI command here and then see what happens here, right? And I got the default VPC whatever is present there. So which means like I am able to connect to my AWS account from my local command line using AWS CLI and then fetch the information. So we are good with this. So that's about the installation of AWS CLI. In our next lecture, we'll focus on installing the kubectl CLI. So I'll see you in the next lecture. Until then, bye bye. Thank you. Back. In this lecture, we are going to install the kubectl CLI. So AWS provides the EKS vended kubectl binary. So if we are using the EKS clusters, it is always recommended to use their own kubectl binary so that we really don't run into many issues. So we can even download that directly using this reference link. So one important thing here we need to follow is like based on the cluster version whatever you are using, here the binary will be available for 1.13, for 1.14, 1.15 and then 1.16. So we are going to use 1.16. So this link and in my documentation whatever you see, it is going to be same. But whenever you are going to execute using my video, please ensure that you go to this reference link and based on the latest cluster version you are going to use. So from there you take the download link. Rest all commands you can execute as is, but for the download the package link, always go to this documentation link. So now let's go ahead and then download this. So I'm just going to create a binary folder here and I'm going to go inside that and I'm going to download the package. So let's provide the execute permissions for the binary and set the path by copying it to the home directory. So we'll create a bin folder in our home directory and then we'll copy it there and then set the path. And once done, so let's verify the version. So we can see it here, v1.16.8-EKS means like Elastic Kubernetes Service of AWS. So this respective kubectl binary is EKS vended, AWS EKS vended binary, which we are going to use. In our next lecture, we'll focus on installing the EKS-CTL. Until then, bye-bye. Welcome back. In this lecture, we are going to install the EKS-CTL CLI. So on your MacBook, if already Homebrew is installed, then ignore this step. So let's go ahead and then tap the VWork tab here. So the next thing is install the VWorks Homebrew tab EKS-CTL binary. So it's already downloaded in my caches, so the installation is pretty quick. So let me verify the version. Yeah, good. So we have completed the EKS-CTL installation on our MacBook. So if you want to install on Windows, you can follow the respective documentation and then install it on that respective operating system. Either it is Linux or Windows. So in our next lecture, we'll focus on creating the EKS cluster. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about AWS EKS cluster. So how EKS cluster is going to work, what are the core objects involved in the EKS cluster, and more details about that core objects, what it can do and all those things. So we are going to see that in our introductory section of our EKS cluster. So EKS cluster primarily will have 4 core concepts: EKS control plane, worker nodes and node groups, target profiles, and VPC. So let's see one after the other in a very high level, and then we'll go in detail about those things in upcoming slides. So EKS control plane is nothing but the master node in our regular Kubernetes architecture. So which means it will host the etcd and then kube API server, kube controller, all those stuff will be present in this control plane. So now in regular Kubernetes, we need to maintain our master nodes too. But when we come to the cloud, here what happens is the entire control plane is managed by AWS. So we really don't need to worry about our high availability of our etcd or our kube API servers or controllers or whatever present in the master. All objects is managed by AWS EKS control plane. So we really don't need to worry. So that's a complete managed service by AWS. So our responsibility starts with provisioning the cluster, and after that provisioning the worker nodes, nothing but node groups. So node groups are nothing but group of EC2 instances where we run our application workloads. So we will provision the EC2 instances here, and then on those things we are going to deploy our Kubernetes applications, whatever we want to run. So the next comes the target profiles. So again the same serverless concept comes here. So which means like we really don't need to provision the hard model of EC2 instances with CPU, RAM, all those things. So we can directly deploy our Kubernetes applications, which means like our respective pods on the target profiles, and it is going to be like how much we need, that much we can allocate and then use in the serverless. Instead of, in simple terms, there is no wastage of resources when we use the serverless concepts using target profiles. So the next thing is VPC. So now why VPC? Why VPC is also a core object in EKS cluster. So if you refer the documentation, the core things they say it as control plane, worker nodes, and then target profiles. But when you see in a deeper view of your EKS, so you also need to understand one thing, like whenever you are deploying your production loads, your design and architecture plays the primary role. So when we are doing the design, then the core thing what we need to know is security. So security comes from how we design our virtual private cloud, which is nothing but the VPC, right? So that's the reason I added the concept of VPC also here, and stating that that also comes under the core objects. So now why this VPC? Why? Because you can deploy your application workloads directly on the public subnets in the EKS cluster, or you can create a node group in the private subnet and deploy there, or you can even deploy Fargate profiles. And another important thing here is Fargate profiles can be created only if your VPC is having minimum one private subnet, which means Fargate profiles only run on private subnets, which means we should be aware of VPC concepts, and also we should be aware of public and private subnets and equivalent security groups and how we are going to handle it. And when you deploy the things in the private subnets, what happens? Like if our cluster, if our application workloads are even the workloads whatever you have deployed, means like our worker nodes present in the private subnet need to be communication with the EKS control plane. So for that purpose also it need to deploy the VPC NAT gateways. So there are multiple concepts involved with VPC in addition to these three core objects. So that's the reason VPC also becomes one of the core feature for EKS cluster from design perspective. So now let's see how does this EKS work. So this image I directly took it from the AWS documentation. So what we are going to do, that is the core thing, right? So first we are going to provision our EKS cluster, and then which is nothing but our control plane. And once we provision our EKS cluster, we are going to create the node groups, nothing but deploying our worker nodes. So now our cluster, which is nothing but master, is ready and the worker nodes are ready. So what we are going to do is we are going to deploy our applications. So to deploy our application workloads, we need to connect to our cluster. So we are going to do that using our Kubernetes kubectl CLI. So kubectl CLI. So once we deploy, we can run our Kubernetes apps on the respective Kubernetes cluster. So that's about on a high level. Let's see each of our components, means like whatever we set the core objects in detail step by step. So EKS control plane. So it's a single tenant Kubernetes control plane for each cluster, and control plane infrastructure is not shared across clusters or AWS accounts. So it is going to be independent for us. And another important thing is this control plane consists of at least 2 API servers and 3 etcd nodes that run across 3 availability zones within a region. And as AWS is going to manage it, so EKS automatically detects and replaces unhealthy control plane instances, restarting them across the availability zones within the region as needed. So that's about the control plane on a high level. So the next thing is worker nodes and then node groups. So worker missions in Kubernetes are called nodes, and these are nothing but our regular EC2 instances only. But the AMI is specifically designed for Kubernetes from AWS. So another important thing here is EKS worker nodes run in our AWS account and connect to our cluster's control plane via cluster API server endpoint. So now here what we need to understand is this cluster server API endpoint should be exposed to the internet, or means like our worker node should be accessed internally to the VPC using this cluster API server endpoint, or our worker nodes need to go via internet and then access this API server endpoint. These are design strategies how we are going to design our EKS cluster. So all those things we can look into in our production design section. So and another important thing here is a node group is one or more EC2 instances that are deployed into a EC2 autoscaling group. So when we are doing the cluster autoscaler, we will understand the concepts of these autoscaling groups and then how we can automatically scale our worker nodes based on the CPU and memory resources available. So we'll see that in a dedicated manner in a separate specific section. One more important thing here is all instances in a node group must be of same instance type, be running the same AMI, and use the same EKS worker node IAM role. So all these are core things, okay? But do we need to worry about all these things here? No. So when we use the EKSCTL command line, most of the things are achieved directly out of the box. We don't need to worry about worker node IAM role or running the same AMI or running the same instance type. All these things are automatically taken care with EKSCTL. So the next thing is Fargate profiles. So AWS Fargate is a technology that provides on-demand right-sized compute capacity for containers. So with Fargate, we no longer have to provision, configure or scale groups of virtual machines to run with containers. So each pod running on Fargate has its own isolation boundary and does not share the underlying kernel, CPU resources, memory resources, or elastic network interface with another pod. So AWS specially built Fargate controllers, like how we have the kube controller and then cloud controller in Kubernetes master. Same way, they have something called Fargate controller, and that recognizes the pods belonging to Fargate and then schedules them on the Fargate profiles based on the selectors concept, which we are going to see specifically in our Fargate section. So we'll see more in our Fargate learning section, all these things. So another thing is VPC. So EKS uses AWS VPC network policies to restrict traffic between control plane components within a single cluster. We have discussed it a little bit also about this. So how we are going to access the cluster API server endpoints from our worker nodes is a decision of ours how we want to access it, inside the VPC or via internet edge, which means like your cluster API server endpoint should be how you want to expose it. So, and another important thing here is control plane components for a EKS cluster cannot view or receive communication from other EKS cluster present in same AWS account or in other AWS accounts, okay, unless we authorize the Kubernetes RBAC policies. So this confirms that our EKS cluster is highly secure and highly available configuration, makes us reliable and recommended for deploying our production workloads. So all in all, EKS is ready for deploying our production workloads. But the core thing here is each concept need to be drilled down in detail and then understood in detail. So how we are going to use it. So all these things we will do in a step by step. So what we are going to do is we'll see the Kubernetes concepts and EKS related AWS services or EKS attached AWS services hand in hand, and then we'll understand everything in detail. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture, we are going to create the EKS cluster now. So let's go into 0102, create EKS cluster and then node groups. So when we go to the step 01 here, step 00 we just now completed, which is nothing but understanding about EKS core objects, control plane, worker nodes, and then Fargate profiles, and then VPC in detail. So now we are going to go into step 01, which is nothing but create EKS cluster using EKS CTL. So one important thing here we need to understand is like it will take 15 to 20 minutes to create the cluster control plane. And what is this command? So using EKS CTL create cluster, we are going to create the cluster and its name is going to be EKS demo 1. And the region we are going to create this cluster is in US East 1. And my EKS cluster should be present in US East 1A and then 1B availability zones. So I am restricting my cluster at 1A and then 1B. So if we don't give these zones, then it is going to automatically select the zones. And if it selects 1D or some other zones, most of the time we get error about the availability of workloads present there. Means like availability of servers and all those things. So because of that, I specifically say 1A and then 1B here. In addition to that, so without node group, which means like if you don't give this additional parameter, with EKSCTL create cluster itself, it is going to automatically create the node group also for us with 2 nodes inside that with M4 large, and then it is going to apply directly the production grade cluster creation automatically without our involvement. So what happens at that point is like we are going to get a cluster without any knowledge of what it is creating. So that's the reason what I have done is like I have created a specific step for node group separately. So as we seen earlier how EKS works, so we are going to create cluster which is nothing but control plane separately and also the node groups separately. So instead of by using the default things and then using default, we customized it to see in a way how we need it. So that's the reason I said that without node group. So let's go ahead and then execute this command on our command line, right? So it is going to take close to 15-20 minutes to create this cluster. So I'm going to pause the video, and once it is created, so we can move on with the next steps. So if you see here in this, so it has selected the subnets for US East 1A public, and then one more, it is again another public subnet it has selected. and it is using the Kubernetes version 1.16. As on today, that is the latest as per EKS. So means like even though 1.18 is real latest as Kubernetes.io, so it will be 2 versions lesser than EKS is using 2 versions lesser than the live Kubernetes. So and another thing is it is creating the cluster in US East 1 with the name EKS demo 1. And the one more thing here is like you can see public access true for our API server endpoint and private access is false. So this is nothing but, if you remember, we discussed about how our API server endpoint should be accessible for the worker nodes. So it is going to means like our Kube API server endpoint is going to be publicly accessible for us. That's the reason it is saying public access true. So that's about it. So it is going to create a control plane now, and I'll pause the video until it is created and then ready. So our cluster got created now, and we can see it also updated the kubeconfig file in my .kube folder in my user home directory. So which is nothing but it also updated the cluster kubeconfig file. So which means like my kubectl context is directly pointed to this cluster. So we can even directly check kubectl get nodes and see if we have any nodes in this cluster. So without any node group we have created it. Ideally no node should be present here. So in our next upcoming step anyway we are going to create the node group separately. So no resources found in our default namespace. So now moving on. So let's go ahead and then list our clusters. So EKSCTL get clusters. So it will list the clusters created for us in our AWS account in US East 1 North Virginia region. So let's see how many clusters it has created. Ideally we have created only EKS demo 1. It need to list the EKS demo 1. So we can see it here, EKS demo 1 created in the US East 1 region. So I'll see you in the next lecture. In our next lecture we will focus on IAM OIDC provider. Until then, bye bye. Welcome back. In this step, we are going to create and associate the IAM OIDC provider for our EKS cluster. So for basics, ideally this is not required, but we are going to create everything in an orderly manner, so which will be helpful for when we are using the EKS related application load balancers or external DNS or many things we are going to execute as part of this course. So if we want to use everything effectively, so following it in an orderly manner helps us. So that's the reason we are going to also execute this step now. So to enable and use AWS IAM roles in relation with Kubernetes service accounts, so on our EKS cluster, we must create and associate OIDC identity provider. So we can do that using EKSCTL or AWS Management Console. So when you go via AWS Management Console, multiple steps and multiple things you need to do, and most of the time we might mess up something there. So but with EKSCTL, it is just one command saying that EKS utils associate IAM OIDC provider in that respective region for this respective cluster. That's all. So my cluster is in US East 1. And then my cluster name is EKS demo 1. So if I execute this command, immediately it will be associated. So let me do that now. So it's going to do it in a second. It will be quick. So we'll create IAM OpenID Connect provider for cluster EKS demo 1. So it has created and then associated. So the next step is to create the EC2 key pair. So why we need to create this EC2 key pair? So we need to create this key pair because so whenever we create the node group, it creates the worker nodes, which is nothing but the EC2 instances. So if we want the login, means like if we want the access to our worker nodes, so then definitely we need to create our key pair and then associate it. We can even do it manually with our custom key. But ideally it is always good to use AWS integrated services, and I prefer that and I recommend that. So we are going to create a key pair with kube demo and then download it and then put it in your desktop, the respective PEM file, and then this name, whatever the kube demo key pair name you are going to use in the node group. We are going to see that now. So let's go to the management console, go to EC2. and go to security groups in network and security, and go to key pairs. Sorry. So in key pairs, you can see I already have the kube demo. So if you want, you can create a key pair and then provide the name as kube demo. So based on your OS, you can use PEM or PPK, but if you have PEM, again you can convert into PPK for your Windows missions if you want, for when you are connecting via PuTTY. So whatever the option. So I always use PEM so that I'll be able to even create the PPK using for PuTTY using PuTTYgen. So that's the reason. So you can use kube-demo and then create key pair. So automatically it will download the file, PEM file for you, and then you can leverage that when connecting to the worker nodes. So with that said, I'm going to cancel it. I already have it, so I'm not going to recreate it one more. So this completes the creation of key pair and then creating and associating IAM OIDC provider. So the next thing is to create the node group with additional add-ons in the public subnet. So let's see what is this creation of node group. So everything, whatever you see here, EKS-CTL, create cluster and --help, and then you get all the options available for you, what all you want to use. In the same way, EKS-CTL, create --help with create what all you can create. You can create cluster, node group, IAM service account, IAM identity mapping, and then forget profile. So in the same way, when you're creating the node group, what all the options available for the node group, you can see here. Okay, so there are a lot of options available here. So primarily we need to look into these add-on flags for the first time. So ASG access is nothing but auto-scaling group access. It will enable the IAM policy for our cluster autoscaler in the worker node IAM role. I'll show you that. Okay, so and it will also enable for external DNS access. This is nothing but whenever you create your ingress controller and a load balancer, automatically your Route 53 DNS also need to be registered, and then we will see in our load balancer section, but that related IAM policy will get created. This is for Elastic Container Registry related IAM policy will create, means like IAM policy will be created with the worker node IAM role. So in the same way, app mesh access, ALB ingress access, install Neuron plugin. So all these things comes into the picture from add-on flags perspective, right? So we are using all these 1, 2, 3, 4, 5 these add-ons in our command. So excluding those things, which is nothing but ALB, app mesh, full ECR access, which is nothing but Elastic Container Registry access, external DNS access, and then auto-scaling groups access. So remaining things, let's see what are these. Okay, so EKS-CTL create node group, and the cluster I'm going to create is in EKS demo 1. I'm going to create this node group, and the region is US East 1, and the name of my node group is EKS demo 1 node group ng public 1. It is our comfort, whatever we want to give. And node type I'm going to use is T3 medium. For costing purposes, I am using T3, which means like it should not burn lot of money for us. So I am using T3 medium. And number of nodes we are going to use is 2 nodes, and minimum number of nodes is 2 and maximum is 4. This is desired number of nodes always. Okay, and the next is node volume size, which is nothing but on the EC2 instance as worker nodes, how much is your underlying storage. So I said 20 means 20 GB of size it is going to be. And now these two are nothing but whenever you say SSH access, it is nothing but SSH access is equal to true. And when SSH access is equal to true, what is the key you want to use? So the kube demo is the key we have created here. So use the same key here, so that whatever is present in our key pair will be associated to our worker nodes, and using this key you will be able to log into the worker nodes for any troubleshooting. And one final thing is managed. So recently Kubernetes EKS added a managed worker nodes. So earlier it used to be unmanaged worker nodes, but now it is managed worker nodes where AWS will take care of patching, auto upgrading, and all those stuff from AWS perspective. So we will definitely want to use that and then leverage that feature. So that's the reason managed, and in future it is going to be everything managed. So we are going to use this managed. So now let's go ahead and then create this now. So let's go to our command line, clear this and paste it, right? Click on enter. So it is creating. It will use the version 1.16 for new node groups based on control plane version. Okay, so it is getting created. It will take 3 to 5 minutes to create the node group. So let's wait for that now. our nodes got created and our node group got created. We can see it's a retryable error we have got. So sometimes usually when it posts EKSCTL posts to the CloudFormation API, so sometimes it will fail and then again it will retry and then go ahead and then create it. So it automatically again went and then recreated it. So what we can do here is like we can say kubectl get nodes. So whenever we type this command, if we have the nodes ready, so it is going to say they are ready. So we have our 2 nodes ready, and that is the thing. If you want to see in a wider way, which means like with public IPs of our EC2 instances, we can see this way with -o and then wide. So that's about the creation of node groups. So in our next step, we are going to focus on verifying the clusters and then nodes in a step-by-step manner. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to verify our cluster and then node groups and then nodes, all those things in different steps. Okay. So our first step is to verify our node group subnets, which means like whether this respective node group is created in public subnet or not. So let's go ahead and then verify that. So how we are going to verify is nothing but for the subnets associated for our node group, if we have the internet gateway route, which is nothing but it is present in the public subnet. So let's go to EC2 in the sense like our management console and then go to Elastic Kubernetes service. So we can see the cluster with the EKS demo got created. Inside that, if we go to compute tab, we can find our node group, right? So EKS demo 1 ng public 1. So it has desired size is 2 nodes. Okay. So let's open that, and if we see here, it has the subnet here. Okay. So we'll click on any one of the subnet. It will open our VPC subnet section here. And inside that, we are going to verify, we are going to go to respective route tables and then verify. Okay, so here is the route table, right? In subnets, in the route table tab, you can see that we have the internet route enabled with the internet gateway, which confirms that our respective node group is created in the public subnets. So that is our first step. We have verified. So now verify cluster node groups in EKS management console. That one also we have verified. So we went here and then we have seen our cluster configuration here. We can see the API server endpoint here for our respective cluster, which is nothing but Kube API server endpoint. And this is our OpenID Connect provider URL. So, and in addition to that, in compute, we have seen the node groups, and then inside node groups, we have seen the subnet and all those stuff. And it also created an auto scaling group for this. And why? Because we have enabled the ASG access, which is nothing but auto scaling group access and all those stuff. Automatically it will create anyway with EKS-CTL. We really don't need to worry about those things. So let me close it here. This is the auto scaling group it has created. So using the cluster autoscaler concepts based on the resources we are going to use, we can increase or decrease these things. So we'll see at that respective time. So let's close these things and then go back, and we can see the networking information for our cluster, and then logging information. By default it is disabled. If you want, we can even enable it. We can, as this is EKS CTL managed cluster, always it is recommended to use EKS CTL to enable logging, disable logging, whatever the modifications we want to do. Instead of this management console, if you do it via EKS CTL, that is a good option for us. Okay. And any updates, currently it is using latest. We really don't have any latest updates here. So that's about on a high level for verifying the cluster node group and then cluster. And now to list the clusters, we have already seen EKS-CTL get cluster or get clusters. Okay, so if you want to verify the node group, means like under this cluster, you can copy and then provide the cluster name here, and then you get the node groups present inside this. Okay, get node group and hyphen cluster. So I'll correct that. So this should be like this. Okay, and I'll correct that command. I have corrected it. So now list nodes, you have already seen that kubectl get nodes -o wide. So you can see this. And another thing is kubectl config view minify. Okay, so to see our config context. Okay, so our respective EKS demo 1's config context we can see here. The current context is kalyan@EKS demo 1 US East 1 EKSCTL.io. So this is the current context So to see the current context of your kubectl, you can use this command. So the next thing is worker nodes, IAM role, and list of policies. So if you remember in EKSCTL, right? In EKSCTL create node group --help, you know that you have added all these add-on flags, right? So which is nothing but we are going to provide respect to IAM policies for our worker node IAM role. So let's see that now. So let's go to EC2. These are core fundamentals, and then it might take close to 30, 40 or 45 minutes to create your cluster, but it's very important to know what is what before going and then deploying the workloads. So that's the reason we are taking a little bit of time. Instead of that, just executing 2 commands our cluster might have created, but we need to understand deeper. So if you see it here in our EC2 instances, 2 instances got created which are nothing but worker nodes, and inside that if we go here we should find the IAM role, right? So you can see that IAM role is EKSCTL and then cluster name -node group. Whatever you see with node group, it is nothing but the node group related node instance role. So if I click on that, so it will open the respective IAM console and then that respective role. So let's wait for it. Okay, so now if you see here, so by default worker node policy, container registry read only, if you see here you have additional stuff here. Okay, so policy for ALB ingress, policy for app mesh, policy for auto scaling, policy for DNS which is nothing but external DNS, and you have also policy for container registry read only, and then container registry power user which is nothing but ECR full access, elastic container registry full access. So all these policies got added for our worker node IA, means like worker nodes IAM role. So why this is required? This is nothing but whatever the pods, Kubernetes pods you are going to run in your cluster worker nodes, they need to access it. They need to access these resources, which is nothing but if we want to access the elastic container registry to download the container image, so then it needs access. And then you have 2 ways to do it. So one is create a Kubernetes service account and then create a IAM role and then associate them together and then provide that information for your respective pod, means like for your respective container, so that it can pick up and then use that. So other way is like directly give it in your respective worker node IAM role, so that these worker node, whatever the pods running on this worker node will have access to these resources. So the pods running on these worker nodes will have access to these resources to perform the action. For that purpose we can do this way. And we are also going to do the other way is like create a IAM role, create a policy, and then create a Kubernetes service account and then associate everything together. All those things we are going to do it separately for ALB ingress controller and for external DNS, and for multiple things we are going to anyway do it. So let's go there, and then we have seen the IAM role. Also see the security group associated to worker nodes. So let's go here, and before going to security groups, first we'll see the CloudFormation stack and then we'll go back to security groups. Okay, so we'll go to CloudFormation, right? So let me click on this, and why we are seeing here is like what is happening. I just executed that command and then what happened we need to know, right? So now if you see it here, you can see these 2 are the things which has been created today. So today is 14/6/2020, and then as part of this what it created is EKSCTL EKS demo 1 cluster. So whenever you have executed the create cluster command, it has created the cluster, and the associated events you can see here what all it has created, right? So it will be creating lots of stuff. It will create the NAT gateway, it will create route tables, and lots of stuff it will create underlying. Okay, and what are the outputs of that and all these things you can see. So this is your endpoint. Endpoint is nothing but your Kube API server endpoint, right? So this CloudFormation stack, whenever you say EKSCTL create cluster, automatically it will post the content to the CloudFormation API, and using that it creates, means like using CloudFormation only it has created. So now you also need to see one more thing here. Important thing is NAT gateway. So why? Because if you deploy your worker nodes, means like your workloads in the private subnet and your node group is in private subnet, it needs access to the EKS cluster, which is nothing but control plane. In addition to that, your pods also need to have access to Docker Hub or anything, right? So for that purposes, NAT gateway outbound is going to be helpful. So by default, it will create a single NAT gateway, and you have options to create high availability NAT gateway or even disable the NAT gateway, right? So these are important things which we need to know. So on a high level, I'm trying to explain, and whenever we go to those respective sections, we'll get in detail. So the next section is security groups, right? So before going to security groups, we'll also complete the worker node using key pair cube demo, right? So let's go to our EC2, right, and see what is the key pair associated to it. So ideally it should have cube demo, right? So let's go here, come down. See, the key pair name it is associated is cube demo. So let me go to my SSH and take the public IP of any of these nodes. I have took one, okay, and then I will say SSH -i, and I have my cube demo PEM file here, and then I'm going to say EC2 user @ and it should allow us to log in, right? Right, I have logged into the EC2 user with 192.168.42.229 is my private IP, right? And then I can even see my disk space, okay, on the server, right? So it has mounted 20 GB, whatever we said, right? So 20 GB it has mounted for us, okay? So this is about the login to our respective worker nodes, okay? So I'll add this command in the doc. Now let's go back to the security group step, okay? So any security group which has the remote in between it, that is nothing but the security group related to inbound access to our worker nodes, okay? So in this, if you see here, you have the cluster security group and you see something called remote access, okay? So this is the security group we are interested in, right? So let me open that security group here, and in the inbound rules, it is open only to 22 to the internet. So that's the reason just now whatever we have done, the terminal access is worked SSH -i, right? So now what we are going to do is we are going to add one more rule here. So that is nothing but all traffic we are going to allow from anywhere. So for our testing initial sections, we are going to use the node port service for the workloads we are going to deploy. So for those workloads, if you are going to use node port service, then node port generates different dynamic IPs. Dynamic ports. So our cluster public IP means like our worker nodes public IP : and the dynamic port whatever it generates. So using that we should be able to access our applications. So for that purpose this rule is required. So I'm adding this rule here, okay? So which means like I'm saying that adding an additional rule, all traffic from anywhere is allowed for my worker nodes. That's the step 6, okay? So this completes the creation of EKS cluster and then associating EKS cluster to IAM OIDC provider and creating the node groups and verifying everything step by step. So in our next lecture, we'll focus on other section. Until then, bye-bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. Will be a star freelancer.
Welcome back. In this lecture, we are going to understand about EKS cluster pricing from our learning perspective. So which is nothing but if we create the cluster and then if we leave it, then it is going to burn a lot of money for us. So very important thing about EKS pricing is like EKS is not free like many of the other AWS resources. Irrespective of if we have created our account in the and we are in the first year of our AWS account or it is an old AWS account. So in short, no free tier for EKS. So EKS cluster pricing. Cluster pricing is nothing but the control plane pricing. Okay. So we pay $0.10 per hour in US East 1 North Virginia region. All these are related to US East 1. Okay. And it might vary based on different regions. But if we get an idea about what is the costing, accordingly how we want to create it and then use it, we get a fair idea, right? So that's the reason. So per day, if we keep running this control plane continuously, then it is going to be $2.4. And if we run it for 30 days, then it is going to end up with $72. So which is like not good if we run continuously and then delay it and then leave it open, right? So that's the reason when we are learning as part of this course, then we need to quickly delete and then recreate whenever we are using it. So in our next section, we are going to do that, means like how you are going to delete your cluster and then how you are going to again recreate it. Again, you can follow the same steps of whatever in our previous section. But the whole idea is you need to, whenever you are working on it, create it, and then whenever you are not working on it, clear it. So that is the good option. So this is about the cluster pricing. And worker node pricing, if we take one T3 medium server itself, we will end up with $30 per month if we continuously run it. And these worker nodes are running in the Kubernetes, right? So there is something called they cannot be stopped. Only you can delete your node group and then your T3 medium servers will be terminated. But you cannot stop the instances like regular EC2 instances like stop and then start. So if we take 5 days to complete this course, and if you run one EKS cluster and 2 T3 medium servers, already you will end up with $25. If it is full day it is running, means like 5 days into 24 hours it runs, it is approximately around $25. So considering all these cases, we need to ensure that how we are going to plan, right? So if it is an organization related account and then you are working for some organization and their account you are using, that's fine. But whenever you are trying to use your own accounts, then you should be very careful about the pricing. Even if you are using the Fargate profile also, it has a dedicated pricing information here you can refer. So 2 important points here is, if you are using your personal account, then ensure you delete and recreate clusters and worker nodes as and when needed. In our next step we'll see that. And in important note 2 is, we cannot stop EC2 instances which are in Kubernetes cluster, unlike other EC2 instances. So we need to delete the worker nodes or node group if we are not using it during our learning process. Okay, so that's about it. So in our next lecture, we are going to see how we are going to delete the EKS cluster, right? Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to look into delete EKS cluster and then node groups section. Okay, so let's go into 0104 and we have the steps here. Before going into the steps, we need to understand one thing thoroughly. Okay, so one thing, that is nothing but you have created your cluster and then node groups using EKS-CTL, and whatever the objects it has created as part of EKS-CTL, if you are going to edit any of those things, then we need to ensure that we need to roll back. Example, just now we have added one rule here in the EC2 management console for this security group, which starts with the remote, means like which has the EKS-remote access, right? So for this, what we have done is like we have added the all traffic here, correct, right? Which means, so whenever you are planning to delete the cluster and then respective node group or whatever it is, right? So roll back this change, which is nothing but go here, edit inbound rules, and then remove these 2 rules related to all traffic and then leave it as the previous state. And then you can directly go and then delete the cluster, which will also delete the underlying node group. First it will delete node group and then all the node groups under that cluster, and finally it will also delete the cluster control plane too. So that is, within one command you can delete everything after rolling back your changes. So this is the note 1. And note 2 is, in our future sections, whenever we are doing the storage section or anything, we will also go and then update our worker nodes IAM policy, which is nothing but whatever we have seen here, right? So if you go to instances and if you click on this IAM role, right? So inside this, we are going to add the role related to, we are going to attach a role related to CSI driver, means like EBS CSI driver related policy we are going to associate. So if that is the case, if you go and then again directly delete the cluster after your work or anything, again it is going to be in trouble. So that's the reason, whatever manually you have edited the objects created by EKS-CTL, please ensure that you revert them back and then do the next step of deleting the cluster. If not, what is the problem, right? So if not, what is the problem, we'll see in a little bit. But for now, if you want to delete both node group and then cluster, you can use you can directly use EKS-CTL delete cluster and then cluster name, so that first node group will get deleted and after that it will also delete the cluster. And if you want to only delete the node group, so then you can have like this, EKS-CTL delete node group and the cluster name and the node group name, and then it will delete the node group first, and after that you can even go ahead and then delete your control plane, which is nothing but the cluster. So now one thing we are discussing is what happens if we don't revert back these things, right? Whatever we have edited the objects which was created by EKS-CTL. So what happens is some of the CloudFormation events will fail here during the deletion. So you need to cross check what it failed and then go and then manually delete them and then work on it, or again try to delete from CloudFormation stack and ensure that whenever you click on the delete, automatically it will say that exclude this item. So check that box and then exclude and then delete it, so that you will be able to delete. But very important thing here is, as part of this cluster, it creates one NAT gateway which is already getting priced, right? In addition to that, it also creates one network load balancer which is in the pricing state only. And it also created a lot of other stuff, which means like per day it is charging $2.5 for this cluster control plane. Considering all those things, we should know how to delete this stuff, which means like how to ensure that we have deleted our cluster thoroughly after our work is completed. So for considering all these things, I have ensured that. So this section is added for you with 2 important notes here. Let me come here. And so here, okay, so note 1 and then note 2, like this. Whatever you change, means like if you change something, if I change anything over the course, I'll add that here. But if you go and then change something, please ensure that you remove them and then after that delete, so that you don't run into issues. So that is the thing. So in our next lecture, we'll focus on other stuff. Until then, bye bye. Thank you. Welcome back. In this section, we are going to primarily focus on Docker fundamentals. So what are the topics involved in understanding the Docker fundamentals? Let's go ahead and then see that now. So we are in our github.com/stacksimplify git repository. So in that, there is one repository called Docker-fundamentals. So if you go inside, we have 5 sections involved in this understanding and then learning the Docker fundamentals. Okay, so we are going to first understand what is Docker, and then in traditional approach, what are the problems we are having, and then why with Docker, how we are going to solve it. And we are going to understand the Docker terminology or Docker architecture. So once all that is covered in first section, then we'll move on to the Docker installation. So in Docker installation, we'll focus on installations on Windows, Mac, and also troubleshooting Docker desktop issues on Mac. So from there on, we'll move on to 2 major flows which are more essential for understanding the Docker. So the primary flow is like pull a Docker image from Docker Hub and then run the Docker image as a container. So we have existing Docker images available for different applications, and then how we need to pull that and then run it on our local Docker machine, we are going to see it. In addition, the flow 2 is like build a new Docker image and then run it locally and then again push it back to the Docker Hub. So how we are going to do that? So if we understand basic these 2 flows, so we are very good with the Docker, in the sense like we got the fundamentals thoroughly. In addition, we'll also focus on essential Docker commands. So the Docker architecture, what we are seeing, already covered in Docker introduction. So we really don't need to worry about it, okay? But the core thing is we are also going to focus on essential Docker commands on day-to-day life, what we are going to use when we are using the Docker. So this is the core things we are going to perform now. So I'll see you in the next lecture with the Docker introduction. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to focus on 01 Docker introduction. So as part of Docker introduction, we are going to see what problems we have with the current traditional infrastructure and then how Docker is going to solve them. In addition, what are the advantages of using the Docker we are going to look into. So for presentation slides, you can click on this link and then view the presentation slides. So the slides, whatever we are showing in these lectures is also available here for you for download. So moving on. So if we go to the 01 Docker, so we have something called Docker architecture, right? So in addition to Docker introduction, we are also focusing on Docker architecture. So Docker architecture is like a series of terms in Docker introduced, which we need to be aware of to understand and then play with Docker effectively. So what is Docker daemon, and then what is Docker client, or what are Docker images, and then what are Docker containers, and what is Docker registry or Docker hub. So all these terms, whatever is introduced in Docker, so we are going to understand as part of the Docker architecture or Docker terminology section. So let's go back to our introductory slides and then move on with the stuff. Okay, so in Docker introduction, so first thing is what problems we have with the traditional infra. So let's see what are the problems we are having. So in the traditional infra, we have the hardware infrastructure. On top of that, usually we install our respective operating system like Ubuntu or SUSE Linux or Red Hat or CentOS, whatever it is. And then when we are planning to deploy our applications, its equivalent OS level libraries we install and also its equivalent dependencies we install. So let's consider we have web servers as Nginx and then app servers as some Spring Boot applications which are of Java type, and then we also have databases as MySQL. So for those things, what are the OS libraries required? We need to install them, and then also the dependencies. Example, if you want to run some JBoss or Tomcats, then you also install the JDK and all those things, right? So like this, what all dependencies of libraries and dependencies are required, we need to install and then handle them. So now if you see, installation and configuration will be a biggest problem in the traditional approach. Okay, so it is going to be time consuming and we need to perform all these library install, dependency install, and then these vendor product installs, all these things across our environments like dev, QA, staging, and then all the production environments. So multiple times we need to implement them. But when you consider Docker, so from Docker perspective, package it once and then leverage it or use it across all the environments. So one time work, and then after that everything is like packaged and then it can be leveraged across environments. Compatibility and dependency, right? So we need to keep resolving issues related to libraries and then dependencies continuously. So if we do the OS upgrade, then what happens? Again, the libraries, some libraries might break, and then we need to fix those libraries, or we need to fix the dependencies, or we need to upgrade the dependencies. So like that, we face multiple issues from compatibility and then dependency issues when we are on the traditional infra, and inconsistencies across environments. So if you have multiple 5 dev environments, 5 QA environments, 5 staging environments, and 2 production environments, it is very hard to track changes across these environments, and they end up with multiple inconsistencies. But when in Docker, if you package it once and leveraging it across all the environments, so then there is no chance of missing or having the inconsistencies in our Docker images. Operational support. So we need more resources to handle operational issues on a day-to-day basis, because of you are going to scale your hardware infrastructure heavily to support your operating system and the needs from your environment's perspective, right? So the server support, hardware, and then software installations, and then patching releases, all these things we need to spend a lot of money and then lot of resources to handle all those things. When it comes to Docker, all these things will be simplified. So in addition, developer environments. So when a new developer joins the team, the time it takes to provision his development environment in traditional approach is time taking, and even most of the time it will not be 100% right. But when we consider our developer environments are Dockerized, then it is going to be a minute or less than a minute to provision that respective developer's environment. So all these problems, whatever we are seeing in traditional infra, can be easily solved using Docker. Moving on, so let's see how a physical machine looks like when we install the application. So we have hardware infrastructure, operating system, libraries, dependencies installed on that operating system, and we have deployed the web servers, app servers, and then databases on that physical machines. So let's see from physical machine to virtual machines, what is the difference, right? So we have the hardware infrastructure, and in virtual machines we'll have the hypervisor, and on hypervisor we create the virtual machines. So we have the operating system for each virtual machine, and then we'll install the libraries and then dependencies for those virtual machines, and then we'll have the equivalent containers, equivalent vendor products installed on those virtual machines. Okay, so now if you see here, this is a little bit simplified version from the physical machines, but still the libraries and then dependencies and then all these incompatibility issues still going to be there across environments, and then you need to solve these things. But in virtual machines also there is a concept of creating a virtual machine image and then leverage it across environments. We have seen that, but still with IP address changing, DNS name changing, and then lot of other things we need to bring into the picture when we are even using the virtual machines OVA images or whatever is it. Okay, so moving on to Docker. So when it is installed on a physical machine with Docker, it is going to look like this. Okay, so we have a hardware infrastructure and we have the operating system. On that we are going to install the Docker, and then we are going to run the containers. So each container is a combination of its own libraries, dependencies. It will have its own operating system inside that, and then we'll be installing the Nginx or even the app servers and then databases, whatever it is, they'll have their own libraries and then dependencies, so that once and for all we are solving the libraries and dependencies, and then we are going to package and then use that Docker image across all environments. So if you see here, so on the operating system, we are going to install the Docker. In the same way, if you see virtual machines with the Docker, so we have the hardware infrastructure, we have the hypervisor, and on that we are going to have the operating system for that virtual machine, and then we are going to install the Docker, and then from there we are going to deploy our Docker images as containers on them. So we can run multiple Docker containers in a single virtual machine, right, based on the memory and then CPU limits, whatever we have. So like this, you can run 100 containers or 200 containers, all those things. So nothing, there is no dependency from our perspective from either hardware infrastructure or hypervisor perspective. Okay, so if this respective operating system is allocated with equivalent CPU and then RAM, and then if those are minor containers, then you can run any number of those things. Okay, so but with that said, the core thing here is like Docker is flexible for us. The way how we want to use it, we can use it in a better manner. Moving on, so what are the advantages of using Docker, right? So why containers? So they are flexible. So even the most complex applications can be containerized in our recent days. So they are very lightweight, and containers leverage and share the host kernel, making them much more efficient in terms of system resources than virtual machines. So they are very portable. So you can build locally, deploy to the cloud, and then run anywhere. So they are very loosely coupled. These Docker images or Docker containers are loosely coupled. Containers are highly self-sufficient and encapsulated, allowing us to replace or upgrade one without disrupting others. So they are very much scalable. You can increase and automatically distribute container replicas across a data center. So they are very much secure. Containers apply aggressive constraints and isolations to processes without any configuration required on the part of the user. So with that said, the Docker containers are flexible, lightweight, portable, loosely coupled, scalable, and then even secure. So now moving on, we'll be looking into the Docker architecture in our upcoming lecture. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's see the Docker architecture now. So, or even we can call it as Docker terminology. So we have a Docker host, and inside Docker host primarily we'll install the Docker daemon. So the Docker daemon, Dockerd, listens for the Docker API requests and manages Docker objects such as images, containers, networks, and then volumes. So the next is the Docker client. Okay, so Docker client is an optional thing in the Docker host. So we can either install on the Docker host or on our own desktop, and using the Docker client we will be able to communicate to the Docker daemon. So Docker client can be present on either Docker host or any other mission. So the Docker client, Docker is the primary way that many Docker users interact with the Docker. So when you use commands such as docker run, the client sends these commands to Dockerd, which is nothing but Docker daemon, which carries them out. So the Docker command uses the Docker API. So the Docker client can communicate with more than one respective daemon. Okay, so moving on, the next thing is the Docker images. You can see here the image 1 and then image 2. So an image is a read-only template with instructions for creating a Docker container. So often an image is based on another image with some additional customizations. So example, like we may build an image which is based on Ubuntu image. So we already have a Ubuntu image, and then consider that image we are taking and then building our own image using that Ubuntu image. So with that Ubuntu image we install additional application options of what we are planning to use, which is like Apache web servers or Java, JDK, and then additional Tomcats, whatever we want to install, and then deploy our application inside that, and then package it as our own application image. So the base image there we are using is the Ubuntu image. So that is called image is based on another image. So moving on from Docker images, the next thing is the Docker containers. So a container is a runnable instance of an image. So we can create, start, stop, move, or delete a container using the Docker API or CLI. So we can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. So when a container is removed, any changes to its states that are not stored in persistent storage disappear. So that's most important point from containers perspective. So moving on, so let's see, we have a Docker host, and on Docker host we have the Docker daemon. So if you want to pull the image and then run it as a container, so what's the process going to be? Let's go ahead and then see that now. So Docker client, it can be my desktop or even the Docker host. So what we do is like Docker client is nothing but the Docker command, DOCKER. Okay, so I'll say Docker pull nginx demos /hello. So one sample image. So what happens is it will go and then communicate to the Docker daemon, and then via Docker daemon it will go to the Docker registry, right? So from Docker registry I'll try to pull the nginx demo /hello and then download that image to my Docker host. So from my Docker host, so the image is present here. So now I'm going to run it, right? So to run it, I'm going to say Docker run and then some -port, local port, and then image port, whatever it is there, and then -d and then the complete image name. So whenever I do that, it is going to run it as a container in the Docker host. So what we have done, so first we have pulled the image from the Docker registry and then stored it as images here, and then we have run it, and then now the runnable instance of an image is called the container, which means like the container has started and then application started serving. So now in this overall thing you have seen client and then host, but you really don't know what is this registry or Docker hub, right? So let's see what is this. Okay, so a Docker registry stores the Docker images. So Docker hub is a public registry that anyone can use, and Docker is configured to look for images on Docker hub by default. So we can even run our own private registry in our cloud systems like Elastic Container Registry, or using Docker hub also you can even run it, means like the Docker provides the software to run it as a private registry in our local data centers. So when we use the Docker pull or Docker run commands, the required images are pulled from our configured respective registry, right? So when we use the Docker push command, our image is pushed back to the registry. So we are going to see two flows. By seeing what we have seen here, the complete thing we are going to distribute into two flows and then implement them in our upcoming lectures. So the flow one is to what we have seen here, like pull our container image here and then run it as a container, right? So the second flow is like build a image here, run it as a container locally, and then test it, and finally push it to the Docker hub. So we are going to see all those things now in a step-by-step manner. I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to look into Docker installation. Okay. So from Docker installations perspective, so let's click on the Docker install. And we can see here, so we can install the Docker engine, and then it is supported in different platforms. Okay. So CentOS, Debian, Fedora, and then Ubuntu, and with x86, AMD 64, ARM 64, IBM Power, and then IBM Z series. So this is more or less like a Docker engine directly installed on those respective operating systems. So in addition, we have something called Docker desktop. So we have the server version and also we have the desktop version. So from server versions perspective, all these operating systems are supported, and these models are supported. Okay, so x86 64 or AMD 64, ARM, all those things. So now from desktop's perspective, so we can install Docker desktop for Mac on Mac OS, and also Docker desktop for Windows on Microsoft Windows 10. So let's see, start with the Windows, right? So when we click on that Windows, so you can see here, get started with Docker for Windows. So we can directly install the Docker desktop on our Windows machine and then test these things using these steps. So let's click on install Docker desktop for Windows. So we have the system requirements here. Our system should have Windows 10 64-bit, Pro, Enterprise or Education versions, and we should have the Hyper-V and then Hyper-V and containers Windows feature must be enabled on our operating system, means like at the OS level. Okay, so now our mission should minimum have 4 GB of system RAM to operate or run this Docker desktop, right? So once those are ready, so we can download the Docker desktop installer.exe and then run it. Okay, so we can start the Docker desktop and then we can start using it. Okay, so you can see here, and then you can run the Microsoft PowerShell, and then from there you can run the Docker run hello world, right? And then you can test it. So in addition to that, from Docker desktop only, you can even log into your Docker Hub ID. Okay, so that's about the Windows installation. So this Docker desktop is going to be pretty easy from install perspective if you have the exact system requirements. So primarily, like if your system is of Windows 64-bit and then Windows 10 you are running and at least you have 4 GB system RAM, then it is good. Okay, but from my observation, what I am saying is usually 4 GB system RAM, if you install this Docker desktop, then your system will be at the disaster. This is the live experience whatever I am having. Okay, so ensure that your system has 8 GB RAM so that you can even leverage that for using other tasks other than Docker desktop things. Okay, so if it is only 4 GB system, then it only supports for Docker desktop, and then most of the things whatever you run, either your Spring Boot IDE or Eclipse IDE or whatever you are running there, it is going to be a hell lot of a system where it will be very slow. Okay, so 8 GB RAM is always recommended, even though it says 4 GB here, but in real world it's 8 GB is recommended. Okay, so that's about the Docker desktop on Windows. Okay, so moving on, so the next thing is Docker desktop on Mac, right? So if you see here, this is get started with Docker desktop for Mac, right? So install Docker desktop for Mac. So let's go there, and then so if you see here, so from system requirements perspective, if you are on the latest OS, it is already supported. So macOS must be version 10.13 or even newer. So this is the thing, and 4 GB of RAM, that's what they say as usual, and VirtualBox prior to version must not be installed. So all these things you can ignore. Okay, so for this VirtualBox and all those things. Okay, so directly download the Docker desktop and then move it to the application folder, and then once you have moved to the application folder, it will be available as a docker.app. Okay, so you can run that, and then once you run this docker.app, so it will start displaying here. You can see it here, right? So Docker desktop is running on my Docker desktop, so it will be available for us to run it, means like it will be available for us to open it from here on. Okay, so it's engine version, compose version, Kubernetes version, all these details are provided here. So once our Docker desktop is up and running on our Mac machines, so we can go here and then go to the preferences section and then ensure that this respective setting, okay, securely store Docker logins in macOS keychain. Okay, so this setting should be unchecked. Okay, so I already have a running version here, so I'm not looking into it, but ideally this setting should be unchecked. So let's see more about it. Okay, so Docker desktop on Mac has an issue with the macOS keychain. Okay, OS X keychain. Okay, so to fix it, we need to perform these two steps. So one is go to Docker desktop changes, open Docker desktop preferences, which is nothing but whatever we have seen here, right, in preferences, and uncheck the option named securely store Docker logins in macOS keychain. So that is first thing. Okay, and once that is done, go to the config.json file in .docker folder. So this will be there in your root folder. Okay, so if you go to your users and then kdaida, my home user is, my user's home is users kdaida, and inside that I'll have a folder called .docker. And then inside that you will have something called config.json. Okay, so currently I removed it earlier, so I am not finding it here, but you will find some line called cred store OSX keychain. Okay, so this line. Okay, so you just need to remove this and then restart the Docker. Okay, so restart the Docker daemon. So you can see here, you can say restart. Okay, somewhere it should be there here. Yeah, restart the Docker daemon. So when you do that, so this issue will be resolved. If you face any issues related to this OS X keychain, ensure that you are going to troubleshoot when it is on Mac using following things. Okay, so other than that, on Mac you are not going to face any other issues, only this issue you will face, and then you can fix it using these things. Okay, so in our next lecture we'll focus on our flow one, which is pull from Docker Hub and then run the Docker image. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to pull a Docker image from our Docker Hub and then run it as a Docker image. Okay, so let's go to our Docker Hub account. Okay, so hub.docker.com, and then I have a Docker Hub account here, and let's see the image which we are going to use. So I have an image called Docker Intro Spring Boot Hello World REST API. So I'm going to use it. So usually everyone will try to use Nginx. So but we are trying to use it little different. So to show different things here. So we'll see what are those things. Okay. So let's go to the Docker fundamentals and then pull from Docker Hub and run Docker images. So let's start with the step one. Verify Docker version and also log into our Docker Hub from our Docker client perspective, right? So let's go here and then clear, and I'll say Docker version. Right, so it has given my client Docker engine version, which is 19.03.05, and also my server Docker engine version also been provided here. Okay, so let me clear this, and then I'm going to say Docker login so that I'll be able to authenticate to my Docker Hub account. Okay, so already I have provided the credentials earlier, so that's the reason it is showing. So I can even say Docker logout. Okay, so now it has been logged out. So if we want, we can even log in one more time. So I can say stack simplify. Okay, so my login got succeeded. So if I want anything in config.json, we can cross check. Okay, so nothing related to Mac OS X keychain. Okay, so that means we are good for now. So let me clean this, clear, and go back here. Okay, so now pull an image from Docker Hub. So for that we are going to use just Docker pull, and the image you can see here, whatever is there, you can pull this image, or you can get the image name directly from our Docker Hub account here. Okay, so this is the one. So whatever we want, we can pull it, and here 1.0.0 - release. Okay, so I'll try to copy this complete command from here and then execute it for the convenience. Okay, so let me paste the command here. So now it is going to download. So that respective image is getting downloaded to our local repo. So let's wait for that to completely download. So now it is downloaded. So you have a command called Docker images. Okay, so you can see here only one image, whatever we have downloaded, is available. So there are no other images other than this. So using Docker images, we have checked the downloaded image. Okay, so let me clear this and then go back. Okay, so now run the downloaded Docker image and then access the application is our step 3. Okay, so you see there is a command called docker run to run our image as container on our local desktop, right? So let's see what are the options here, right? So the first thing is docker space run and then hyphen name, and then I'm saying app1. So nothing but this is an optional thing. So what I'm trying to give here is like my Docker container name, I'm going to give it as app1. If we don't give, it is going to auto generate some name for us. Okay, but always it is good to give a Docker container name what we are going to run. So we are trying to use the best practice here. Okay, and the next thing is -p and then 80:8080. So here you see, right, the first 80 whatever you are seeing is your local port. Okay, which is nothing but you are going to expose from your local desktop. Okay, and 8080 is nothing but the second one is nothing but your container port. So you are mapping your container port 8080 to your local desktop port 80. That's what you are doing here. So whenever you access localhost/hello, which is nothing but with port 80, your application is accessible, okay, with port 80, even though container port is 8080. So that's the thing. And -d and your container means like the image complete name including the tag value, right? So like this. So let's go and then copy this command now and then paste it and then run it. Okay, so we are going to run it now. So now we are going to see how it is running. Okay, so docker ps is the command to see the list running containers. Okay, so my container is running. Okay, it is created and its status and all those things we can see it here. Okay, so now the container name at the end you are seeing, right? It is nothing but app1 and its pointing is 80 to 8080. You can see all these things here. Okay, so now let's go to the browser and then say localhost / hello, right? So 2 L's. Okay, hello world v1, you can see, right? So now whatever we have run it, we are able to access our application. So let's go back here and then list the running containers. Okay, and we have other commands also. If any other containers which is stopped containers are there, we'll be able to see them with -a. In addition, we'll have something called q, which will give us only the container IDs. Okay, so if you want to stop the container, then you need just the container ID, right? So you can get that container ID and then stop it, or you can pass this command as input to another command. Okay, so for that purpose -q is used. Okay, docker ps -q is used for passing these container IDs to another commands for doing whatever we want. Okay, so when we are doing the advanced sections, usually we will know all those things. So moving on, so now we can even connect to that container terminal, which is nothing but whatever the docker container, whatever we have created is a Linux container. So we can directly connect to that and see what's going on. So for that, the command is docker exec and then -it and the container name and then /bin/sh. Okay, so this is going to be something called paste, and my container name is app1 and then /bin/sh, right? So now I am in my container and you can see here my app.jar is there, and then lot of commands are going to not work, only basic commands will work. You can see ps-ef, which is nothing but the Java command, whatever the Spring Boot application is running here. Okay, so now we are in our container. Okay, means like inside the container command prompt we are here. Okay, so I'm going to exit and then I came out. If you want again connect, you are in container. Okay, if you say ls app.jar, you are seeing ps-ef, you can see these things. Okay, if I say exit again, I came back. So I came back to my local Mac desktop. So like this, you will be able to connect to your container terminal. So if you want to stop the container, you can stop using container app1, right? So I can say docker stop app1. My container name is app1, so I am stopping it. Okay, so if I say docker ps, right, so no other containers are running. Okay, but if with -a, you can see the stopped containers. So you can see the stopped container you are seeing, you can see it here, exited 143, right? So but without -a, only running containers you can see. So now if you say localhost and then access it, it's not working, right? So now again one more time, it is a stopped container, you are going to start it. So and then say docker start app1. Okay, now your container is running. So when you say docker ps, you are able to see it. Okay, -a will give you the stopped containers, and without -a, you can see the running containers. Okay, so now it is again running. So let's access this and then say, okay, so hello world v1 is coming. That's good. Okay, so now you have completed the container stop and start. Finally, if you want to remove the container, you can say docker space rm and then container name. Okay, so let's do that now. Okay, docker rm and then container name is app1. Okay, you cannot remove a running container. Stop the container before attempting to remove it. So let's go there and then stop it. Now we have stopped it. So if you say -a, you can see that, and then it is in exited state. You can see it here, right? So now I'm going to say docker rm and then app1. So now my container is removed. So ps it doesn't show, and even in the ps-a also it doesn't show. Why? Because even the stopped container is removed from my mission. Okay, so with ps it is not showing, docker ps, or with ps-a also it is not showing. So that's about it. Okay, finally if you want to remove the image, so you can say docker image and then image id. No, it should be docker rmi and then image id. So let me correct this. So whatever the downloaded image we have, just go ahead and then remove that image. So let's say first docker images clear docker images and then get the image ID. So this is the image ID. Okay, and then say docker RMI, which is nothing but remove the image, and then provide the image ID. Okay, so now the docker image is removed. So let's say docker images, nothing is displayed. So whatever you have pulled from our Docker Hub is not available. So now it is plain empty. So no other images on my local desktop. So that's about the flow. Pull Docker image from Docker Hub and then run it. So we have done it in 8 steps, and then all these will be as a reference for you whenever you want to execute. Okay, so you can go to this Docker GitHub account and then use it. Okay, so I'll see you in the next lecture with our next flow. Until then, bye bye. Thank you. Welcome back. In the previous lecture, we have completed about pulling a Docker image from Docker Hub and then running it on our local machine. So now in 04, we are going to build a new Docker image and then run it on locally and then push it to the Docker Hub. Okay, so let's see how we are going to do it, right? So as a prerequisite step, please ensure you have your own Docker Hub account. So you can go to hub.docker.com and then create your account here. Okay, so you can click on sign up for Docker Hub and then provide your Docker ID, email, and then password to complete those things. Okay, so I already have the Docker Hub account. So what I'm going to do is I'm going to log in. Okay, so sign up for your Docker Hub account and then put it ready. Okay, now moving on, the next thing is to run the base Nginx container, right? So why we are going to run the base Nginx container, what we are going to do as part of this complete steps is, like, we have a Nginx Docker files folder here. Inside that you can find Docker file and then index.html. So whenever you run a base Nginx image, it is going to provide the Nginx related simple index.html. So what we are going to do is we are going to change that to a different index.html, and then so I'm going to say welcome to Stack Simplify Nginx v1 custom image, right, in the index.html. And in my Docker file, I'm going to say get the base image from Nginx and then copy my index.html whatever I have created to the USR share Nginx HTML, okay, which is nothing but inside the image to this location, copy it. And now if I run it, so obviously instead of default Nginx index.html, we are going to get our index.html. So that image, whatever we are going to build it, we are going to push it to our Docker Hub. Okay, so let's see how we are going to do it. So first, before that, let's get our base Nginx image and then run it and then see what it is showing. Okay, so in our previous step 3, means like in section 3, what we have done is we have used the docker pull command to get the image and then run it using docker run. But ideally, if you want to run it, you can even without using the docker pull, you can directly use the docker run to do it. Okay, so what I'm doing here is using docker run, I'm saying -- name and then I'm saying my Nginx default. Okay, so my container name I'm giving as my Nginx default, and port mappings, my local host is 80 and also the container port is 80, and the image name is Nginx. Okay, so you can search for Nginx here, right? So and then you get the default Nginx image. Okay, so that one we are going to use. So I'm going to say docker run Nginx. Okay, I'm copying it and then going back, okay, to my terminal and then pasting it. So unable to find the image locally, so it will go and then download that image, okay, pulling from the library Nginx. So once it is downloaded, it is going to automatically start also. Okay, so it's downloaded and then started. So let's see docker ps, right? So whenever we see it is already running. So let's go to localhost and then see what happens. Okay, so we can minimize this. So we can see here we are getting welcome to Nginx. So this is the default index.html of Nginx. So we are going to edit it and then change it. So that's what we are going to build a new Docker image, very simple Docker image we are going to build with Docker file. So let's see how we are going to do it. Okay, so let's go here in the step 2, create a Docker file and copy our customized index.html here. So to do so, what we are going to do is, so we can go to any of the folders here. Okay, and in documents, I'll create a folder called mkdir, okay, Nginx image. Okay, inside that, I'm going to create the Docker file. Okay, so in Docker file, I'm going to copy these 2 lines, which is nothing but from Nginx and then copy the index.html from local to this location, right? So let me copy these 2 lines and then paste it, right? So I have created the Docker file. So I also should have the index.html here, right? So I'll create the index.html and I'll say welcome to Stack Simplify, and I'm going to say Nginx. I'm not following any HTML standards or anything here. I'm saying Nginx v1, and this is going to be a custom image, okay? And this is a simple file, okay, index.html. So now what we are going to do is we are going to build a Docker image and then run it locally, right? So docker build -t and then your Docker Hub ID / and your image name, and then the tag you are going to use and where you are going to build it. Dot means like from current location it need to take the Docker file and then also the respective index.html file. That's the reason dot. So if it is in your environment, means like you have your own Docker Hub ID, right? So whatever you have created as part of prerequisites, so you need to replace this command with your Docker Hub ID here, okay? So just if your Docker Hub ID is ABC, then just put the ABC here and then copy this entire thing and then run it, okay? So Docker and then build the image -t, which is nothing but the tag name, right? So stack simplify / my nginx _ image1 : v1 and then dot. So okay, build from the current location, means like current location I have the Docker file, so build from there, okay? So I'm copying this and then I will run it now. Okay, so now if I see Docker images, my new image, okay, so Nginx already downloaded, and using that it created a stack simplify my nginx _ image1 with v1 tag, and it is created 4 seconds before, okay? So now I need to run it, right? So let me clear this, and docker run -- name, and my image name is going to be my nginx1, and port mapping is 80:80, right? So if we don't stop this, then we are going to get the error. So let's go ahead and then stop our earlier one. So if you see, my nginx default is also using 80 of our local machine, right? So let me stop the old one, okay? And then now come back here and then run this one, okay? So docker run my nginx1 with port 8080, and my image name is stack simplify / my nginx image1 v1, okay? So let's run it. In your case, you just replace it with your Docker Hub ID here, okay? Okay, you have run it now. So let's go to localhost and then check it. So it's coming.
Welcome to VoiceOver.
1 second. Ideally it should come. So it's coming from the local cache. So let me try one more time. Yeah, so now it is coming, okay? So it came from the local cache whenever we tried here. So let me close this. So welcome to Stack Simplify Nginx v1 custom image. We have got it, okay? So now we have completed building the Docker image and then running it, okay? So if you want, you can even stop it, okay? So docker ps, it is running now. Docker stop my nginx 1, okay? And if you see docker ps, no other containers are running, but the stopped containers, you can see my nginx 1 and then my nginx default, okay? So if you want to remove them, you can even remove them, okay? So I'll say my nginx 1, and then all these things you can do via additional command now. Docker ps -a -q, right? Which is nothing but it will give the Docker image, Docker container IDs, okay? So you can even remove them using this command, okay? So now if you say docker ps -a, nothing is there, okay? So that's the reason why we are going to use -q, is because to get the Docker container IDs or Docker image IDs and then pass this output to another command like this, okay? So earlier we discussed this, right? So for that purpose I have executed this command and then shown it, even though it is not in our current things, okay? So now moving on, we are going to tag and push the Docker image to Docker Hub. So currently our Docker image name is my nginx _ image1 : v1, okay? So but what I felt is like, oh, v1 is not my not looks good, so we'll say v1 - release, okay? So then if I want to change my Docker images tag name, then we can use the docker tag, right? So docker tag command to do that. So let's do that now. So Docker images, and we'll have the stack simplify my nginx image one. So let's say Docker tag and then stack simplify my nginx image v1, change it to v1-release. Okay, so let's change that, right? And if you see the images, so now you have both v1 and then also v1 release. Okay, so now let's push the v1 release to our Docker Hub account. Okay, in your case, please replace your Docker Hub ID at every place wherever you see the stack simplify, right? So now I'm going to push this. Okay, it is pushing to my Docker Hub. So let's see once it is pushed. Okay, so let's go here, Docker Hub, right? So this is my Docker Hub and my repositories are here. So let's wait for it to be completely pushed, and once it is pushed, we can cross check whether it is available on our Docker Hub repositories or not. Okay, it is pushed now. Okay, so let's see, the next step is to verify the same on the Docker Hub. Okay, so let's go here and then refresh it, and you can see my nginx_image1 just now came updated a few seconds ago, and you can see the tag name is v1-release. So this completes the creation of a new Docker image, run it as a container, and then push to the Docker Hub. Okay, so we have seen that in a series of 5 steps. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in the previous lecture, we have ensured that we have created a new Docker image. We have built the new Docker image and then pushed it to the Docker Hub and then verified it. So now we are going to see few essential Docker commands. So most of them already we have used and then we have implemented so far in our last few lectures, but we can again one more time have a look into it. Okay, so Docker PS, which is nothing but list all running containers. Docker PS-a, list all containers stopped and then running, so both. Okay, so and then Docker stop and then container ID, stop the container which is running. So either it is a container ID or you can give the container name also. If your container is named with -- name when you are running it, Docker run and then -- name if you have given. So then when you are stopping it or starting it, instead of finding the container ID and giving it, you know the name, then you can directly give the name. Even for start and then restart also you can use those. Okay, so Docker port container ID will provide you the list of port mappings of a specific container, and for removing the container, either container ID or name you can provide. Okay, and Docker remove the running containers forcefully, you can use -f as the one of the argument. Okay, so and if you want to see the image info, pull the image from Docker Hub repository. So Docker pull and then image info. Image info is nothing but the complete image name. Okay, and pull the image from Docker Hub repository. This is an additional example for whatever we are seeing here. This is the example. So in addition, you are seeing the Docker exec -it and the container name and then /bin/sh to connect to the Linux container and execute commands on that respective container. So which means connect to the container and then execute commands or verify something, you can do this one. Okay, and if to remove the image, Docker RMI, and to log out from our Docker Hub account, Docker logout. To log in, Docker login, and then to display live stats of our container, Docker stats. So to display the running processes of a container, Docker top, and finally you see here the Docker version. So there will be lot of sub commands under Docker run and all those things, but on a very high level to manage Docker, these are the core commands which we should be aware of, and more commands will be adding the more when we are getting more gaining experience on the Docker by implementing multiple use cases. But from fundamentals perspective, how to stop container, start container, what is an image, how to download the image, how to run the image, and how to remove the image, and how to remove the container, or how to connect to the container terminal, all these things are required and all these things are listed here. So this completes the essential commands overview for Docker. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand a little bit about Kubernetes architecture. So why Kubernetes? So Kubernetes is a portable, extensible, open source platform for managing container workloads. So out of the box, the following features are available in Kubernetes: service discovery and load balancing, storage orchestration, automated rollouts and rollbacks, automatic bin packing, self-healing, secrets, and then configuration management. So let's see what are the Kubernetes components in its architecture, right? So primarily we see like we'll have both master and then worker nodes in the Kubernetes. And on all these nodes, we'll have the container runtime installed. Whether it is master or worker nodes, container runtime is mandatory. And we can say it as Docker or some other container runtime options available. And next thing is etcd. So etcd is the key value store which stores the master and node information. So one more will be kube scheduler. So all these things, what does these do? We'll see in our upcoming lectures. So but we'll have kube scheduler here and kube API server and kube control manager and then cloud control manager. So that's the master components on a high level. And in worker nodes, we are going to have kubelets and then kube proxy. So let's see one after the other what each of these components do and then their responsibilities. Okay, so let's start with the master component and then master node, and inside that container runtime is a default thing, so which might be Docker or any other runtimes. And let's start with the kube API server. So it acts as the front end for Kubernetes control plane. It exposes the Kubernetes API. So CLI tools like kubectl or even the master components like scheduler, controller manager, etcd, and worker node components like kubelet, everything talk with this kube API server. And next is etcd. It is a consistent and highly available key value store used as Kubernetes backing store for all cluster data. It stores all the master and worker node information. So next is the kube scheduler. So scheduler is responsible for distributing containers across multiple nodes. So it watches for newly created pods with no assigned node and selects a node for them to run on. And next is the kube controller. So this kube controller manager, controllers are responsible for noticing and responding when nodes, containers or endpoints go down. So they make decisions to bring up new containers in such cases. And it is a combination of kube controller manager is a combination of multiple controllers inside. Okay, so let's see what are those. So we'll have one node controller which is responsible for noticing and responding when nodes go down. And we will have replication controller responsible for maintaining the correct number of pods for every replication controller object in the system. And endpoints controller populates the endpoints object, that is joins, services and then pods. And one more, we'll have something called service account and then token controller creates default accounts and API access for new namespaces created in Kubernetes. And next one, we'll have one more which is nothing but cloud control manager in the master nodes. Okay, so this cloud controller manager is responsible for, means like this component embeds cloud specific control logic. So it is mainly for the cloud related architecture of Kubernetes. It only runs controllers that are specific to that respective cloud provider. So on-premise Kubernetes clusters will not have this component. And node controller for checking the cloud provider to determine if a node has been deleted in the cloud after it stops responding. And you'll also have route controller for setting up routes in the underlying cloud infrastructure. And also same as kube controller, you'll also have something called service controller, which is for creating, updating and deleting cloud provider load balancer. So these are all the master node components in the Kubernetes architecture. Okay, so now let's see the worker node components. Okay, so in a worker node, container runtime is going to be as usual on every worker node. So the underlying software where we run our stuff is going to be the container runtime inside the worker node or whatever the VM instance in them. Okay, so we are going to use Docker, but we have other runtime options like RKTR, containerd, etc. So now one thing here is the next one is kubelet, which is the more important one. So let's see about it. Okay, so kubelet is the agent that runs on every node in the cluster. So the more number of worker nodes, on every worker node we are going to see kubelet is present inside that. So this is the agent is responsible for making sure that containers are running in a pod on a specific worker node. So, and next is the kube proxy. So it is a network proxy that runs on each node in your cluster. It maintains network rules on nodes. So then what is the use of it, right? So in short, these network rules allow network communication to your pods from network sessions inside or outside of our respective cluster. So these are the core things about Kubernetes master and then worker node components. So I'll see you in the next lecture. Until then, bye-bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. In this lecture, we are going to understand about EKS cluster architecture in combination with Kubernetes cluster components. Okay. So as usual in EKS control plane, which is nothing but cluster control plane. So you will have the master node, same as our regular Kubernetes cluster. So we'll have the container runtime, kube API server, edge sets, kube scheduler, and here it is going to be kube control manager. And in addition to that, we are also going to have something called Fargate control manager, and then Fargate related scheduler also will be available as part of that. So which will schedule the Fargate pods on serverless Fargate infrastructure in AWS. So in addition to that, if you see there we have the worker nodes, and here you can say it as EKS managed node groups. So under this we are going to anyway have worker nodes only, and container runtime, kubelet, and then kube proxy are common everywhere. So now what is differing here? Okay, so means like you have the EKS cluster control plane and then EKS managed node groups, and on regular on-premise Kubernetes also we have all these things, means like the master components and then worker components. So what happens in EKS is EKS lets us focus only on our application workloads. So we don't need to worry about any of these components, either it is etcd high availability or kube scheduler pod or kube API server pod or this respective entire what is present in these blue boxes is not our job. Our core focus will be how to design our applications and then how to deploy those applications into Kubernetes cluster and its node groups available in AWS. So which means, so we really don't need to worry about the high availability or the maintenance or anything about these master or worker nodes. So once we create and then create the cluster autoscaler for our EKS, our job is done. So the rest end-to-end maintenance of our all these components will be the responsibility of the AWS. So that's about the EKS speciality. So with that said, we'll move on with our next steps in our upcoming lectures. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about Kubernetes fundamental core concepts, pod, replica set, deployment, and service on a very high level. So let's understand what are those actually, right? So pod is a single instance of an application. So a pod is the smallest object that you can create in Kubernetes. When you come into replica set, a replica set will maintain a stable set of replica pods running at any given time. So in short, it is often used to guarantee the availability of specified number of identical pods in a deployment. So a deployment runs multiple replicas of our application and automatically replaces any instance that fails or becomes unresponsive. So rollout and rollback changes to applications are additional features about deployment when you create it as a deployment. So deployments are well suited for stateless applications. And finally, service. So a service is an abstraction for pods, providing a stable so-called virtual IP address fronting these pods. So in simple terms, service sits in front of a pod and then acts as a load balancer. So this is a very high level introduction about these things, but in upcoming lectures whenever we deal with each section, so we are going to have a very detailed pictographical and then visual manner what we are doing and equivalent hands-on sections. Okay, so now we'll move on and then understand what is our approach in implementing these fundamentals, right? So we are going to use both approaches, which is nothing but imperative and then declarative way of implementing the Kubernetes core concepts. Okay, so using kubectl, with kubectl commands, we are going to create pod deployment and then service imperatively. And for replica set, we really don't have a kubectl command to directly do it, so we are going to use YAML file to create them. And in declarative approach, so we are going to use YAML as our language to create the Kubernetes manifest, and then use kubectl to create pod, replica set, deployment and then service, and then understand and then master these concepts hand to hand using even the live template writing using YAML also. So all in all, we are going to do this in two ways, which is one is imperative way and the declarative way. And over the process, everything, right? So everything is documented in a Kubernetes, means like in a GitHub repo on a step-by-step manner. So if you go to pods with kubectl, every step and then every command, whatever you are going to execute, everything will be available for you in a step-by-step manner, so that we really don't fail anywhere or stuck anywhere when we are implementing it. Okay, so if you see services with kubectl, whatever commands you want to use, everything you are going to use. And if you see services with YAML, so you are going to have a kube manifest with all the manifests, whatever you are going to write them directly, which means like you are going to create all these things by live template writing and then implement them. So that's about the introductory section of what we are going to do as part of this course. So I'll see you in the next lecture and then start with the pods with kubectl. So until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about the core Kubernetes concept named pod. So with Kubernetes, our core goal will be to deploy our applications which are in the form of containers on the Kubernetes worker nodes in a Kubernetes cluster. So Kubernetes does not deploy these containers directly on the worker nodes. Container is encapsulated into a Kubernetes object named pod. So a pod is a single instance of an application. So a pod is the smallest object that we can create in Kubernetes. So pods generally have one-to-one relationship with containers. So if you see here, we have one pod in worker node 1, and then we are having some amount of traffic coming to that. If our traffic keeps growing, so we are going to add new pods for scaling our application like this. And so that it means is like to scale up, we create new pods, and then to scale down, we delete the pods. So for our application, if the traffic keeps growing, we need to scale our application in the form of pods. So now, so we cannot have multiple containers of same kind in a single pod. So this is one more important thing which we need to understand. So if we have a worker node 1 and then you have a pod with Nginx serving the purpose of static content, or it is acting as a proxy. So now if your traffic keeps growing here, right? So you cannot scale your container image inside the pod. Always whenever your traffic is growing, you need to scale the pods instead of scaling the containers inside the pod. This is the wrong way and this is the right way. So 2 Nginx containers in a single pod serving same purpose is not recommended all in all. So now if we see, we can also discuss about multi-container pods. So can we have multi-container pods? Can we have multiple containers in a single pod? Yes, but in exceptional cases. Out of 100, 99% always one pod will have one container, and the 1% cases are, we can see now in our next slide, right? So we can have multiple containers in a single pod provided they are not of same kind. Example, in this Kubernetes cluster, in this worker node, you have a pod and you have a Nginx container serving the static content or acting as a proxy. And you have one more Nginx container or whatever the container, which is called the helper container, right? So they do the helper jobs here. So what are these helper containers? In Kubernetes terms, we call that as sidecar containers. So we can call them as data pullers, data pushers, or proxies. So as data pullers, they pull data required by the main container from some other service in the network, or they push the data by collecting the information from this Nginx main container, or they can even act as proxies, means like write static data to HTML files using helper container and read using main containers. Or moreover, if you go into more like our cloud technologies, usually the latest is like now you know the Istio and all these things came in. So we'll always have a sidecar container, which is nothing but the Envoy proxy. So in such cases, we use the sidecar container. But all in all, 99% cases, always pod to container is a one-to-one relationship. So now, when we are using these multi-container pods, so we have the following advantage. So the two containers can easily communicate with each other as they share the same network, and they can also share the same storage space. So multi-container pods is a rare use case, and we will try to focus on core fundamentals, which is nothing but one pod to one container, one-to-one relationship. Now, in the next lecture, we are going to focus on the Kubernetes pods demo. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to look into the pods demo. So let's go ahead and then do that now. So we'll go to our GitHub repo in Stack Simplify Kubernetes Fundamentals GitHub repo. So we are going into pods with kubectl 02 pods with kubectl. So we are going inside, and just now we have completed the step 1, which is nothing but the pods introduction. So we are moving into the pods demo now. So first thing what we need to do is whether our worker nodes are ready. So we need to say kubectl get nodes to check that. So kubectl get nodes, and our worker nodes are ready. And if you want to see them with wide option, so you can say -o and then wide. So it also provides additional information about our worker nodes internal IP, and our worker nodes external IP, which is nothing but our external internet facing IP address for our worker nodes. So now moving on, so let's go to the pods. So we are going to create a pod. So to create a pod, we can use kubectl run, as we are going to do this in an imperative way, not a declarative way. So we are going to say kubectl run and our pod name, which is nothing but my first pod, and the image what you are going to download. So I have pre-built a container image, which is stack simplify /kube nginx 1.0.0, so we can use it. So it is already publicly available on my Docker Hub. So if you see here, kube nginx 1.0.0, which is the tag. So we have multiple versions here. Whenever we are moving on with replica sets, or we are going to go inside deployments and then services, we are going to use different versions to understand in different manner. But for now, we are going to use the stack simplify /kube nginx 1.0.0 tag. So let's come back here and then use that. And then we also have additional tag named generator is equal to run-pod /v1. So this is required to create pod as a pod instead of a deployment. So this is one important note here. So if you want to, you are just creating pod and then you are doing the pods demo. Why do you want your command to automatically create a deployment, which is another core concept, and then get confused with that? So that's the reason we need to use this tag. But when we move on to the very latest version, which is nothing but 1.18 version, which is very recently released, so you really don't need to even add this tag. Okay, Kubernetes has done a lot of cleanup with the kubectl run command, and we really don't need it. But I am currently using 1.16 version, so that's the reason I'm going to use this. So let's copy this command and run it here. Right, our pod got created. So we can go ahead and then list our pods using kubectl get pods, right? And my first pod is ready and then running. So one important thing here is, for our pod, if you want to even give get PO, right? So this PO is nothing but the alias of pods. So you can give a shortcut, you can say, right? So it's the same thing. So now you have listed your pod. If you want, you can even use the -o and then wide option to see more information about your pod. So earlier you have seen only till age, but now you are seeing the IP address of your pod, which is nothing but your application, right? So your IP address of your pod is provided here, and on which node it is hosted also you can see. In this respective node it is running. So we have 118 and then 145 here, and out of which this pod we are only running a single pod, and it is currently present on 118 node. So next is what happened in the background, right? So we need to understand what happened in the background. So Kubernetes created a pod. What happens? So when we see that using the describe pod, we'll come to know. So let's go ahead and then describe our pod. So kubectl describe pod, and then pod name is the syntax. So let's go ahead and then describe our pod here, right? So we can see the events here. Successfully assigned a default my first pod to this respective node, which is nothing but the worker node. Then it pulled the image from the Docker Hub, right? And it successfully pulled the image and created the container inside the pod and started the container. So that's what happened in the background. So that is about what happened in the background. So we can see in the events portion of the describe command. So now what is this describe command? So the describe command is the very important command which helps us in troubleshooting. So if our application has been deployed and the pod is in pending state or crash, loop, back off state, or in different states, you can directly go into the describe command and then verify what happened in the events. And also here also you can see additional information about the same thing. So if you see here, the name of the pod is my first pod, and it has deployed to the namespace default, and in which node it has deployed it is showing in the describe pod. So you'll get end-to-end lots of information about everything. So what is my pod IP you are seeing here, and in addition to that, from where it has pulled the container, all these image ID and then information it is providing, whether it is started, ready, true, all these information you can see everything in the describe command. So it's always good to understand, means like when you have an issue, first start with the describe command and then go to the logs, kubectl logs. So we'll see that later. Okay. So now the next thing is access application. So currently we have created a pod, and this pod we will be able to access directly from our worker nodes. We can log into worker nodes and then access it currently. But how we are going to access it externally via internet, right? So that's our core thing, right? So to access it externally, we need to create a service. In our next lecture, we are going to focus on that. But for now, we created the pod. So let's go ahead and then delete the pod also. So using kubectl delete, we can delete our pod. So first you will say kubectl get pods, and we got the pod. So I'll say kubectl delete pod and my pod name, right? So I'll copy and then paste it. So my first pod, right? So my pod is getting deleted, and once it is deleted, so let me clear, and I'll say kubectl get pods, and I don't have anything in the default namespace. So that's about the pods. In our next lecture, we'll focus on creating a service and accessing this pod via internet. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes core concept named services. And in services, specifically, we are going to focus on node port service. So why we are introducing this concept very early during the pods demo itself? The reason is, so we have deployed a pod. Until and unless we test it and then access it, we really don't know what is happening, right? So everything, if we test, then we know what is happening. So in that line, so we are going to introduce this, which means like whatever the pod we are going to deploy on the Kubernetes cluster, we are going to expose it to the internet and then access it and then ensure that my application is running. So that gives a good feel for us, right? So let's do that now. So we can expose an application running on a set of pods in Kubernetes using different services available in Kubernetes. So those are cluster IP, node port, and load balancer. So cluster IP is specific to a cluster, which means like in its boundary is only a cluster, and inside the Kubernetes cluster you can access your pods with cluster IP if you have created a cluster IP service for your pod. And node port is nothing but using the nodes port, whatever it is exposed, using that port you will be able to access your application externally via internet. And another thing is load balancer. So this is specifically for our cloud providers like AWS and then Google and then Azure. So their load balancer service is integrated with Kubernetes, so that using load balancer service you will be automatically able to create a AWS Elastic load balancer or Azure load balancer or Google load balancer automatically. Moving on with node port service. So to access our application outside of Kubernetes cluster, we can use the node port service. So it exposes the service on each worker node's IP at a static port, nothing but the node. A cluster IP service to which the node port service routes is automatically created whenever a node port service is created. And the port range for our worker nodes is going to be 30,000 to 32,767. So now let's understand the entire flow in a diagrammatical manner. So you see, you have a Kubernetes cluster with a worker node here. So and then you have deployed your pod, Nginx pod, which is nothing but your my first pod, whatever it is we have seen earlier, we have deployed it here. So now we have created a node port service. So what happens, right? In a node port service, you will have something called, every service will have its own port. So that is nothing but the cluster IP service port. So your pod port is 80 and your cluster IP service port is also 80. So the next thing is target port. So in the service, you will have the definition called port, which is 80, which is nothing but the service port, and the target port. And the target port is nothing but container port in a pod. So this is nothing but your respective pod's port. So this is pod port 80. And the next thing is worker node port. So this is nothing but whatever it starts from 30,000 to 32,767. So whenever you are creating it using the imperative way, you don't have an option to declare it the specific port. But whenever you are doing it in a declarative manner using YAML, so you can define one specific port number from this respective range. So I can say 32, 331 or something, and then you can specifically declare your port and then use it when you are using via YAML. But when you are doing with imperative way using kubectl, you really don't have, and then automatically Kubernetes assigns one dynamic port between this range. So that's about the worker node port, and then cluster IP service port, and then container port in a pod. So now the next thing is, whenever a user tries to access using worker node IP and then node port, so the traffic comes via our worker node's respective port, which is in between this range, and then it will send to the cluster IP service under that on port 80, and then from there it will send to the target port, which is nothing but the 80 port on our pod, and then our application will be accessible. So this is about the node port service on a very high level. So in our next lecture, we'll focus on the entire demo for this one. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a pod and then expose it to the internet using the node port service. So just now we have completed the node port service introduction in our step 3, and then we are moving to the step 4. So now let's understand these ports one more time, which is nothing but port, target port, and then node port. So port is nothing but port on which node port service listens in Kubernetes cluster internally. So which is nothing but your cluster IP port. And the target port is nothing but we define container port here on which our application is running. And the node port. So node port is nothing but worker node port on which we can access our application. So these things are very important whenever we are defining our YAML in a declarative way, whenever we are creating a service. But even now, if we need to understand about port and then target port, because in our upcoming steps here, like we are going to understand more about this target port and then its importance, all those things. Okay, so now let's go ahead and then create the pod one more time, whatever we have created in our previous step. So let me copy this and then create our first pod now. So our pod got created. I'll say kubectl get pods, and then my pod is getting created and it is running now. Good. So now we are going to expose pod as a service. So the command here is kubectl expose, and then that respective pod with what is the pod name of that pod, and then the type is a node port service with port is 80, which is nothing but my service port is 80, and name of my service is my first service. So let's go ahead and then expose that now. It's exposed. So now if you want to see the services, kubectl get service, right? And you can see the default Kubernetes service with the cluster IP is available here, and we also got my first service with node port of type node port, and it also has the cluster IP, and the cluster IP port is 80 and the node port is 31084, and you also have the alias, which is nothing but kubectl get svc. Okay, so how for pods PO, the alias for services is svc. Even with svc we get the same output. So the 80 here, whatever you are seeing is the cluster IP service port, and 31084 is our respective node port, worker node port. So now the next thing is how to access the application, right? So you also need to get your worker node public IP to access it. So let's get that using kubectl get nodes -o wide. So you will get the public IP of your cluster here, so which is nothing but this one, and take it and then access it. And what is the port? 31084, and our application is accessible now. Welcome to Stack Simplify Kubernetes fundamental demo, and our application version is v1. So now let's go back here and then see one thing. Okay, so get pods -o wide, right? So this is running on 145 server, right? And then you accessed the external IP of 118 server, which is nothing but the another server, but still it is accessible. The reason is the service is across the worker nodes. Whatever the service you create, it will be across the worker nodes. We'll see more in our replica sets and then deployments and then services. But what I'm trying to say is both nodes will have the same 31084 assigned, and via any of the nodes we will be able to access our service. Just now we accessed it with 173, we can even access with 213, and then we'll get the same response. 31084, right? It's the same thing. So service will get created across the worker nodes. So that's about it. So now one thing we need to understand here is target port. So if you see here in this expose command, we didn't define the target port. So which means, what it means is whatever the service port we have assigned, the system feels that the target port, which is nothing but the container port, is also going to be 80 only, so it will take it by default the same value. Now if you try to change this to 81, so obviously what happens, you can see now, right? So your port is 81 and then you are not defining any target port, so which is different, right? Our container port is 80 and then you are trying to define your service port as 81. So let's see what happens, right? So let me copy it and come back and then paste it, right? Okay, service got created, but will it be accessible for us? So get svc, right? And this is the service, and we got 31100. If we access, it is not going to work because our pod is not running on port 81. So in these cases, which means like your service want to run on different port and your backend is on different port, so you need to always define your target port parameter also. For now, let's access this and see what happens, right? So let me come here, and the port is 31100, right? It failed. So in the same way, so now let's go here and then access it with, define it with target port 80 and then create a service. So we'll create this service as service 3. I have done service 2 one more time. I will correct it. So this is service 3, right? So now get ports. Here you have defined your target port, which is nothing but your container port as 80, right? So now we'll say SVC and its port is 31961. Ideally it should be accessible now for us. Okay, so 31961 is the port. So let's access it. So now we have got our application. If you want, we can even take the new tab and then access it, and then accessible. So that's about the importance of target port. So if we want to use our service port, a different one other than the default port what our container is listening on, so then you also need to define your target port in your kubectl expose command. So that's about it. In our next lecture, we'll focus on interact with pod and then other steps. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to interact with our pod. So we can get the pod logs and then view the pod logs or stream our pod logs, and even we can connect to our container inside the pod. All those things we are going to do now. So let's start with the pods now. So we can dump our pod logs using kubectl logs and our pod name. So and even we can stream the pod logs using -f. So let's see both of these things now. So we already have our my first pod here. So let me paste it and kubectl logs my first pod, and it dumped all the pod logs here, which is nothing but we are going to access the root context in our Nginx application, and then it is serving the content. So now let me do kubectl logs -f. So to stream the logs, right? My first pod. So now we have the logs here. So I am just entering, and then I'll try to access something, and then our logs should come here. So let me go here and then say enter, and we got it, right? So this is one more, and I will say /index.html and then access it, right? So we got it. We can see it, right? So /index.html. So we can even stream our logs using -f command. So let me type Ctrl+C and go back here, and that's about the pod logs. In addition to that, you can refer this link for kubectl cheat sheet, where you will have lots of commands for your understanding, mainly kubectl logs and then logs related options, right? So if you see here kubectl logs, right? So there will be multiple options available here to interact with our pods. So with the -l or -f or with -c, which means if we have multiple containers and then specific container logs if we want, then we can even provide the -c and the container name to get that respective container logs. So all these things we can see, and then all these are important commands for us when we are troubleshooting our issues on the application. Whenever we deploy applications and there are issues to troubleshoot, all these will be very helpful for us. So now the next thing is to go and then connect to our pod. So let's do that using kubectl exec command. Okay, so using this command kubectl exec -it and then pod name and then --, ours is a bash shell. So we will go and then access it, which means my container is using bash. So let's access it, and now I will be in my container. So it is in my first pod. So you can see here I am in my first pod in my container. So I can say ls, and then I can type the commands. I can go to usr share nginx html, and then I can say I'll have my index.html here. I can say cat index.html. You can see the same content whatever you have seen on the browser right here. Welcome to Stack Simplify Fundamentals demo, and then application v1, the same thing you are seeing. So you from again, if you want to exit your container, say exit, and then you are back to my MacBook Pro, which is your kubectl area. So now that's about connecting to the containers. And you can even, instead of connecting and then going inside and running it, so you can directly run outside itself, which means from your kubectl itself you can add the command and then run it. So kubectl exec-it and your pod name, and the command you want to run inside your respective container is env or ls or cat. All these things directly you can run here. So let's run it and then see. It will paste the environmental variables of our respective container. So you can see Kubernetes service port and then Kubernetes port, all these information from our container we are getting. In the same way you can do ls or you can do cat. Again we'll do index.html cat for us. So let's do that now. So we got the output Kubernetes fundamentals demo. And the next step is to get the YAML output of a pod and a service. So just to see our YAML definition, so we can even use kubectl get pod and the pod name and then -o YAML. Instead of -o void what we are doing, now you can say YAML, so that we'll get the YAML definition of our respective pod. So all this it provides in the YAML format. In the same way you can do the same for your service. So you can copy and then paste it here. Okay, so that's all. So now this completes the interacting with pod and then getting the information about our pod and all those things. So now you can see here in our YAML definition for service, one important thing is, see the node port is 31084 and the port is 80 and the target port is 80. So now you can even try for service 3 whatever we have created, right? So node port is 31961 and port is 81, which is nothing but your service port is 81 and your target port, which is your container port, is 80. So that's about the information about the ports in your service. You can see in the YAML definition whatever it has created. So now in our next lecture we'll move on with the cleaning up whatever we have created. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, whatever the objects we have created, we are going to delete them. So using kubectl delete, we can delete them, and using kubectl get all, we can get all the objects present in the default namespace, right? So I'll say kubectl get all, so which will provide all the objects present in the default namespace. So which is nothing but I have my pod, my first pod, and I also have the service, my first service 2, and then my first service 3, right? So now let's go ahead and then delete one after the other. Kubectl delete and then pod, and then pod name is my first pod. So I can type it and my pod got deleted. In the same way, we can go ahead and then delete service is svc and my first service, and 2 and then 3. So now if you say kubectl get all, you will only see cluster IP service of Kubernetes. Rest all got deleted. So that's about the cleanup. So I'll see you in the next lecture with the replica sets. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes concept, replica sets. So replica sets help us in achieving high availability and then reliability for our applications hosted on Kubernetes. In addition to that, it helps us to seamlessly scale our applications, and in combination with services and replica sets, we will also be able to achieve effective load balancing in Kubernetes. Finally, labels and selectors. So using labels and selectors, we will be able to tie all the replica sets, services, and then pods together. With that said, a replica set's purpose is to maintain a stable set of replica pods running at any given point of time. So if our application crashes and any pod dies, Example, if you see here in a worker node, we have 2 pods and then one pod got died. So if that is the case, replica set will recreate the pod immediately to ensure the configured number of pods running at any given point of time. So we configure the number of replicas in our replica set. So if we say that always it need to have 2 replicas, then replica set will ensure that it is running with 2 pods at any point of time. So in this way, reliability and then high availability for all applications are achieved. The next thing is load balancing. So to avoid overloading of traffic to single pod, we can use load balancing. So Kubernetes provides pod load balancing out of the box using services for the pods which are part of the replica sets. So labels and selectors are the key items which ties all these things together: pods, replica sets, and services. So we will know in detail about these labels and selectors when we are writing the YAML manifest in our upcoming lectures. So if you consider a Kubernetes cluster with 2 worker nodes, if you see the replica set is spanned across 2 worker nodes, and we have 2 pods in one worker node and then 2 pods in another worker node. And to access the applications hosted on these pods and then allow the effective load balancing, so we will have the services in middle. So services will distribute the traffic to this respective replica set and the pods present inside that. So with that said, in combination with replica set and services, we can achieve effective load balancing in Kubernetes. And the next thing is scaling. So when load becomes too much for our number of existing pods, Kubernetes enables us to easily scale up our applications, adding additional pods as needed. So this is going to be seamless and super quick. So let's consider a Kubernetes cluster with 2 worker nodes and you have 1 pod in each one, and then a service is load balancing the traffic to them. And all of a sudden you have a spike in your traffic. If that is the case, to scale, you have multiple options in Kubernetes. First thing is go ahead and then update your replica sets, number of replicas, and to the desired number how much we want, and then apply that. Or you can use kubectl scale to do that. Or you can even enable the horizontal pod autoscaler to autoscale the pods to achieve the or to support the amount of traffic spike at that point of time. Now let's go ahead and then implement the Kubernetes replica set demo. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are looking into the replica sets demo. So let's check into it. Okay. So we are in our Kubernetes fundamental 03 replica sets with kubectl section, and we completed the step 1 introduction just now, and then we are moving into the creating replica sets. So one important thing about replica set is we really don't have an imperative command to create a replica set. So we need to definitely define our YAML manifest. Okay. So here we are going to only look into whatever is required inside that in this YAML manifest, and then more than that, other things we are going to discuss when we are going to write the YAML once we learn the YAML fundamentals and then all those things. So for us, if you see here, API version is /apps v1 and the kind is replica set which we are going to create. Means like the object which we are going to create in Kubernetes is replica set. And the replica set name is my hello world rs. So that's the replica set name. And in addition to that, number of replicas means like number of pods it need to get created is 3 pods. Okay. Forget about labels and these selectors and these labels, all these things. Let's forget about it for now. We'll see when we are writing YAML definitions. Okay. So now replicas is 3 replicas and the next is container spec, right? So name of the container is my hello world app and my image is stack simplify / kube hello world 1.0.0. So this is the application. So let's go ahead and then create it using kubectl create, and then file name is replica set -demo.yml. So let's go ahead and then create it now. So if you fork this respective directory, which is nothing but this Kubernetes fundamentals, fork and then download or download this to your local repo, and you need to just go into 03 replica sets with kubectl and you'll find this replica set demo.yml file here, right? So I'll go into that now. So if you see here in Kubernetes fundamentals, I'm going to 03 replica sets, and I can find the file here. So I'm saying kubectl create -f and replica sets demo.yml. My replica set is getting created. So now the next thing is to list the replica set, right? So you can say kubectl get replica set, and it will be listed my hello world rs. You can see here desired number of replicas are 3, whatever we have configured here, and current is 3, and then ready is 3. Okay, so now the alias for replica sets is kubectl get rs. Even you can use rs if you want to, right? So and the next thing is to describe the replica set. Kubectl describe and rs is alias of replica set, and my replica set name is my hello world rs. So let's describe the replica set, right? So now if you see in this replica set, so let's go here, and we can see all the information. Okay, so successfully created the replica set controller and it created 3 pods here. Okay, so for all the pods it doesn't have any issue in creating it. So now let's list the pods. So kubectl get pods. So now we have 3 pods, means like 3 replicas got created, my hello world rs and some dynamic name, right? So in the same way we can even list the pods with wide option, so that we know on which nodes these pods were scheduled. So on 118 we have 1 pod scheduled, and on 145 we have 2 pods scheduled. So in addition to that, if you want to verify the owner of the pod, right, so we can give the kubectl get pods and then pod name and then -o and then YAML. Get the YAML output, and inside that when you refer the owner references you will get those details. So kubectl get pods and then any one of the pod name. So we'll get the replica set as the owner, right? So if you go up and we can see here, right? So owner references, we can see the name tag here, which is nothing but my hello world rs, which is nothing but the replica set. So in simple terms, to whom this pod belongs to is nothing but this pod belongs to that respective replica set. So that you can find using owner references. So now in our next step we'll focus on exposing this as a replica set as a service. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to expose replica set as a service, so that we will be able to access the application present in replica set pods via browser. So let's go ahead and then do that now. So we are going to say kubectl expose replica set, which is nothing but rs, and the rs name, replica set name, and the type is going to be node port, and the rest all is going to be same. Port is the service port, which is cluster IP port, and the target port is nothing but the 8080, which is nothing but my application port, whatever it is running, my container port. Kube hello world container port is 8080, and the name of the service is going to be my hello world rs service. So let's go ahead and then do this now. Right, so it's completed. So now let's go ahead and then get the service, right, and you have it as 30505, and get nodes -o wide to get the public IP, and the public IP is this one, external IP, and the port is 30505, right? So let's go here and 30505/hello, and we got this. Okay, so let me make it bigger, and Now if you want to refresh, and you can take the same URL and in new tab one more time access it, you see one more value here. Okay, and in one more time, and you can do one more time. So like this you can access, and then it will keep load balancing. So if you see here, it is D7HVK, here it is Z and BGW. So to which container it is going, that respective container's ID it is going to throw it here on the browser. So let's see what does that mean. Okay, so kubectl get pods. So you see it, right? The request went to Z and BGW container. Okay, so that's what it is showing here. And another request went to D7HVK. So and then you have this here. So like that, I have written a Spring Boot code, means like Java code, in my container, and then packaged it so that now whatever to which container it goes, that respective container ID you are going to see it here, just for fun. Okay, so nothing much inside that, but you need to access your application in this manner. Okay, so node1 public IP : node port whatever we have got, and then /hello. The context of this application is /hello because it is a hello world application. In our next step, what we are going to do is we are going to test the replica set's reliability or high availability. So what does this mean? So whenever a pod is accidentally terminated due to some application issue, replica set should auto create that pod to maintain the desired number of replicas. So that's what is replica set's reliability or high availability concept. So you have here 3 pods running, right? So and if you go ahead and then delete one pod, kubectl delete pod, and then delete one pod. So you are trying to simulate the accidental deletion. Okay, so automatically it should start creating one more pod. Replica set will create the pod immediately. So there is some connectivity issue, but we'll try one more time. Okay, so now the pod got deleted. So let's test this with kubectl get pods. So once we have deleted the pod, and now you see that the old 2 pods whatever are there is age of 27 minutes, but whatever you have deleted, and then replica set automatically created a new pod which is of 95 seconds. If we want, we can delete one more couple of pods one more time. Okay, kubectl delete pod, and then we'll also delete our D7HVK pod. Okay, so and then in that place replica set should create one more pod. So let's see that now. Kubectl get pods. Now you can see that, so D7HVK is gone, and then you have got in that place 27.4MJ new pod, 16 seconds its age. So you can see the first one pod is from 28 minutes it is running, the other is from 2 minutes, and this is from 16 seconds. So what here replica set is doing is it is automatically creating the pods to ensure that the number of replicas whatever we have configured here, right? So it is trying to ensure that the number of replicas are going to be 3 always. So that's about the replica set reliability or high availability concept. So the next concept is replica set's scalability feature. So we can simply scale our replica set just by updating our spec here, right? So we can go into our spec. So let me go here, and this is my replica set, right? So and then I will say here 6 replicas, right? And then save it, and then apply the change, which is nothing but kubectl replace and the same file. Okay, let me say clear and paste kubectl replace -f and the replica set demo.yml, and let's see what happens. So now our replica set got replaced. Kubectl get rs, the replica set we are going to see. Now you see the desired replicas are going to be 6, current is 6, and then ready is 6. So I'll say get pods, and then you should see 6 pods up and running here now. right? So that's about it. So from last 22 seconds, we have 3 pods came up online automatically. So in this way, you will be able to scale your replica set quickly by updating the number of replicas in your replica set demo.yml. So that's about it. And now the next thing is to delete the replica set in the service. So we are trying to clean up the stuff. Okay, so let's go ahead and then it will get rs. So we'll get the replica set name kubectl, delete rs, and we are going to say my hello world rs. The same way, get svc, which is nothing but kubectl get services, and kubectl delete svc my hello world service. Once this is completed, you can say kubectl get all to see that whatever is present in your default namespace where you have worked. Other than Kubernetes default cluster IP stuff, no other thing is available. So this completes the replica set end-to-end whatever we have learned using imperative way. Just we have used only the YAML file for us because imperatively you cannot create a replica set object. Now one thing important here is like one pending concept is present in replica set, which is labels and selectors. So this is going to be a common concept for multiple Kubernetes concepts, okay, like pods, replica sets, deployments, and then services. Everywhere we are going to use labels and selectors. So we are going to cover it when we are writing equivalent YAML files there so that we will understand in detail. With that said, in our next lecture, we'll start working on the deployment concept of Kubernetes. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes core concept called deployments. So we have already seen a Kubernetes cluster with 2 worker nodes and 2 pods in each worker node from a replica set. So now deployment is going to be a superset of replica set, which means replica set can provide few features, and when we call deployment as a superset, it can provide many features for us. Okay, so in addition to what replica set provides, so that's about the deployment advantage we have. And there is no difference in accessing the applications hosted via replica set or deployment. So all it is going to be using the service concept in Kubernetes. So now let's go ahead and then see what are the deployment features available for us, or what it provides for us or for our applications hosted on Kubernetes. So we can create a deployment to roll out a replica set. By default, whenever we create a deployment, a replica set is rolled out. And updating the deployment. So whenever we want to change our application version, update our application version, we can do the updation of the deployment. When we do this, automatically our version, whatever we are going to update, it is going to be recorded. So now using that, we can easily roll back to our respective older deployment, whatever we want, because it is maintaining the versions. Or if you have updated from v1 to v2, v2 to v3, and then v3 to v4, and now again if you want to go back to v2, yes, you will be able to go because it maintains the versions and then version history. So now we will be also able to scale our deployments. So how we have done the scaling in replica sets, in the same way in deployment also we'll have a tag of replicas where we can add the number of replicas, we can add it, or we can use kubectl scale to scale our deployment. And we can even pause and resume a deployment. So in deployment, the core thing here is like whenever you apply a change to your deployment, immediately it will be applied to your pods. So that is the thing. So if you want to make multiple changes, then you really don't want the pods to be recreated or terminated and recreated every second for every change. So you have 10 changes to make to your deployment, then pause the deployment and make all the changes and then resume the deployment so that all those changes will be applied to your deployment at a time. So like this, there are multiple things we can take an advantage using the deployment. So whenever you are doing the deployment, you can even get the rollout status or deployment status. And there will be something called cleanup policy. Cleanup policy is nothing but, so whenever we do the updation of our deployments, it maintains the rollout version history, and by default it maintains last 10 versions of our application. So we can go to that respective version using that, or we will be able to add more number of versions by adding additional tag in our YAML manifest under the spec of the deployment. We'll see that in the later cases if we want to. So, and next thing is canary deployments. So if we want to add a new version of our application in the live production traffic, and the traffic should distribute with old version and then new version, still we will be able to do it using canary deployments. So all these things are available for us with deployment. So let's go ahead and then create a simple deployment object and then expose it as a service and then access it via browser and then test it once. After that, again we'll move on to updating the deployment, rollbacking the deployment, or pausing and resuming. All those things we are going to see step by step now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to do the deployments demo. So we'll go to 04 deployments with kubectl. So let me go inside. And inside that 0401 will be creating our deployment, scaling our deployment, and exposing it as a service. So all those things we are going to do it now, right? So step 01, introduction to deployments, we have just now completed. So we are going to move on to creating a deployment, right? So to create a deployment, we are going to use kubectl create deployment and the deployment name whatever we are going to put and our container image. So we are going to use the kube nginx image, and if you see here, this is the Docker image location, and we have 1.0.0 to 4.0.0. So we have 4 versions of our nginx application which we are going to leverage and then test end to end all the deployment features about updating the deployment, rolling back the deployment, or pausing and then resuming the deployments. In addition to that, rolling back the deployment to specific version or rolling back the deployment to older version or previous version. All these things we are going to test it. So that's the reason we have 4 versions of our nginx application present here. So let's go back. So let's create the deployment now. So we are going to copy this and go here and paste it. So our deployment got created. So we'll say kubectl get deployments, right? So our first deployment got deployed. Even we can use the alias name deploy. So these aliases will help us in when we are in hurry. We really don't need to completely provide the deployments, or just give deploy and then it provides the output. In the same way for services it is SV, and then for pods PO. So it's always good to learn these aliases. For replica sets it is going to be RS, so like that. So now kubectl describe deployment and the deployment name. So my first deployment, right? So this is the deployment. Scaled up replica set by my first deployment, whatever the replica set name it is providing. So if you say kubectl get RS, so we have seen that creating a deployment will create the replica set. So it has created one. So we can see it, and it has one pod under it. So let me clear this and say kubectl get pods. So we have one pod created as part of this deployment. So now the next thing is to scale our deployment. So using kubectl scale, we will be able to scale our deployment. So let's do that now. Kubectl scale, and the number of replicas, I want it from 1 to 20, right? And my deployment name, right? My first deployment. So you can use deployment space my first deployment, or even we can use this way. Anything is fine. So now it is going to scale. So let's see kubectl get deploy and also kubectl get. So we have 20 and then already 16 is available now. They are coming up. So one more time if we check, so mostly 20 should be available. So you can even say kubectl get pods, and you see all 20 out of 20 are running. So one more thing here is kubectl get replica sets, and if you see in replica sets, so we got the output that 20 out of 20 are up and running, all the pods. So now the next thing is like we can scale down our deployment using replicas to 10. So let's go back here, and instead of 20, let's bring down our things to 10, and automatically our pods will get terminated now, right? So out of 20, 10 pods will get terminated, and then we will end up with only 10 pods. That's good. So now the next thing is expose deployment as a service. Again, we are going to use the same node port service concept what we have used for our pod earlier. The same we are going to use it. So instead of pod, we are going to use it as deployment. kubectl expose deployment and deployment name, and the type is going to be node port, and my service port is going to be 80, and the target port, my container port, is going to be 80, and the name of the service is my first deployment service. So let's go ahead and then create this now, right? So let the service get created, and now kubectl get svc, and my service is got created, and its port is node port is 32169. So I'll say kubectl get nodes -o and then void. So now I got the public IP, so I can use any one of them out of 2, and then 32169. So let's go ahead and then access it now, right? So 32169. So now our application v1 version is up and running, and then we are able to access it, means like a deployment exposed as a service for us, right? So let me go back here, and that completes the simple creation of a deployment, and then testing of scaling the deployment, and also exposing the deployment as a service. So everything we have done using imperative commands using kubectl, right? So in our next lecture, we'll focus on updating the deployment. So until then, bye-bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. In this lecture, we are going to work on updating our deployments. So we are going to go into 0402 update deployment. And if you see here, we can do the update deployment using either set image or edit deployment options. So in step 1, we'll use set image, and in step 2, we are going to use the edit deployment. So, and then there will be multiple things to understand, and then multiple observations we need to make when we are doing this. So that will be in this model, we'll get a lot of knowledge on what we are doing. So let's go up, and then so for the update deployment using set image, right? So one thing we need to do is like we need to get the container name correctly. So first thing is, if let's see the update deployment command. So kubectl set image, and then deployment and the deployment name, and container name is equal to container image. So here we need to have the container name. So to get this container name, we can get that container name using this command kubectl get deployment name -o YAML, and where we can find it is spec.container name. There we can find it. So let's find our container name. So if we go up, you can see that spec.containers.name, and then you can find kube-nginx. So that's our container name. So in kubectl set image deployment name, and then container name is kube-nginx is equal to my new container image, which is nothing but stack simplify / kube-nginx : 2.0.0. So earlier we have used 1.0.0. So that's the reason our application is coming as application v1. So now if we are going to update it to 2.0.0. So let's go ahead and then do that now. So kubectl set image, and then this one, and then we said that -- record true for our versioning, rollout versioning to be enabled. Copy and come here and paste it. right? So now our deployment got updated. Immediately we can see the rollout status here. So waiting for the deployment, and out of 9 of 10 updated, and finally 10th one also updated. So using rollout status, you can see how the rollout is going to happen. Now if you see the kubectl get pods, then ideally you see that all the pods got recreated, which means its age is only 23 seconds. Just now it got created. So with the new image, right? So now you can even see kubectl get deploy, right? So to see that all are up and running, up to date, and then available is 10. So now describe the deployment. So by describing the deployment, what we are going to understand, we can verify the events and understand that Kubernetes by default do rolling update for new application releases. So what is the rolling update, and then why we do rolling update by default? So when the Kubernetes does the rolling update, what happens is like the downtime of our application is going to be 0, right? So one after the other it is going to update our pods. And there is one more strategy in this update deployment. There is one more strategy is, in addition to rolling, there will be something called recreate. So if it recreates, which means like it will delete all the pods and then recreate at a time. So at that time you can expect the downtime for your application. By default it is going to be rolling update, so we really don't need to define anything even in our deployment spec itself whenever we are writing the YAML manifest. But there will be some cases like MySQL containers or these things wherein you want to recreate the stuff. So in those cases you can use the recreate strategy. But in general applications, whatever you use, 99.99% will be using the rolling update. So that's the reason Kubernetes by default defaulted it. Okay, so let's go here and then describe our deployment. Kubectl describe deployment and my deployment name, right? So let's see the events here once it comes, right? So you can see it here. So it has done a rolling update one after the other. Okay, scaled up replica set, and then it started updating one after the other, and then it already completed all the things. Okay, so one important thing we need to notice here is the replica set. So whenever we have done the update, it is going to create a new replica set. So the old replica set becomes 0 and the new replica set. So 26 minutes back we created the first deployment in our previous section. At that time this replica set it created. Means like with this replica set we have the old version 1.0.0. and it created a new replica set with 2.0.0 of our application. So this is one more observation which we need to know. And one more thing is get pods. Okay, pod template hash label. So this also you can compare and understand that it's a different one. So let's see here our pod and then template. So pod template hash label, you can see it here. It is pointing to our second replica set, whatever it got created. So recently, which is 2 minutes back. Okay, so that's about it. And verify your rollout history of a deployment. So we have the rollout history, so we can switch back to older versions using revision history available to us in our next section. So 0403 we are going to do the rollbacks. So at that time this will be helpful, but now we are going to just see the rollout history of our my first deployment application, right? Kubectl rollout history deployment and then deployment name. So it says that the version is 2.0.0 and this is the second one. So we have recorded it, so it is true. So now the last thing is access your application. So already I have it in our browser, but if you want you can go and then go to kubectl get svc and then get the node port here 32169 and get nodes -o wide to get your external IP and then access it. I already have it here 32169. So if I refresh it, so now it is V1, it should become V2. See, now my application version is V2 and the background also got changed to sky blue color. So that's about it. So now our successful deployment has been happened, means like we updated our deployment using the set image option without any issues, and all these observations we have done. So in our next lecture we'll focus on doing it using kubectl edit deployment. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, we are going to update our application from v2 to v3 using the kubectl edit deployment option. So this is very important option, and then this is the option we are going to use in real time most of the time whenever running deployments we have. So kubectl edit deployment name, and then we'll go inside the deployment spec and then update it. So that's the reason. So just look into it. You see it here, kubectl edit deployment and then space my first deployment, means like deployment name or slash, whatever it is. Okay. So, and then you are going to go to containers spec.containers.image and change your image version from 2.0.0 to 3.0.0. So let's go ahead and then do that now. So whenever you are doing it, you can even say that if you want to save the version history, you can say that -- record is equal to true. So let's go here, and so I can even say kubectl edit deployment my first deployment, and it is nothing but -- record is equal to true, right? And I'm going to go at the end, which is nothing but escape shift G, and I'll go up, and if you see, this is the spec.containers.image. So I am going to change from 2 to 3 here, 3.0.0, and I'm going to save it, escape : WQ, right? So now deployment got edited, right? So if you want, you can see the rollout history one more time. Okay, so maybe I am delayed, so it might have already got completed. Okay, so it already rolled out. So if you see the pods, again all the pods will be terminated and then recreated. See, all these are 15 seconds only, started just 15 seconds before or 20 seconds before. So that's a good thing. So now if you see, one more observation here is, so one more time you have edited one more replica set, means like this is one more deployment. So your one more replica set you will be able to see for your third version. So let's go ahead and then see that now. kubectl get rs, right? And kubectl get pods. So you can verify the hashtag here, right? So which is nothing but, this is the one current live one, which is nothing but 3.0.0 version and 774b, and for our pods also you can see 774b as the hash label, right? So that's about it. So now the next thing is rollout history. So let's see the rollout history of our thing, and it should be version 3, right? So this is the one we have done in version 3, and then that is what we are seeing it now. So finally, whenever we access the application, right, so we should see version 3. Currently it is v2 here, and if you want I can make it bigger, yeah, and if I refresh it should be v3. See, right? So now the application version is v3. So this completes our 2 options, whatever we have available using the imperative way to update our deployments, we have completed. So in our next lecture we are going to focus on rollback deployments. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to learn about rolling back a deployment. So we are going to go into 0403, and we can do this in 2 ways. One is roll back to the exact previous version, whatever we have just now updated, or we can go to the specific version of the rollback. So we can do that in both ways. So in step 1 we are going to roll back to a previous version, and in step 2 we are going to do in a specific version. So let's start with understanding, means like let's get the rollout history first, and then after that we'll go ahead and then see what we are going to do. So first thing is kubectl rollout history, right? kubectl rollout history and deployment and my first deployment. So we should have the 3 releases. One is the default version, whatever we have deployed, and then we have upgraded it using set image, which is 2.0.0, and later using edit deployment we went into 3.0.0. So if we want to see specific version what changes happened, we can even see that. So let's go here and in rollout history provide the revision numbers. So even you can say like this, okay, --, revision is equal to 1. So it will provide in revision 1 what happened. So we need to observe the image tag or annotations present there. So in this respective revision 1, directly it is a first deployment. So we will have only image, and in this image you can see 1.0.0. In the same way, for revision 2, it is going to be image tag is 2.0.0, and the annotation, if you see what is the change cause, in this annotation you can see kubernetes.io and then change cause, and using kubectl set image you have changed it to 2.0.0. So like this you can see everything clearly. So now let's see revision 3. So there also you will see the annotation and the change cause, and using kubectl edit deployment you have changed the image version from 2.0.0 to 3.0.0. So that's what is the verify changes in each version. Okay, so now roll back to previous version. So let's go ahead and then roll back. So to roll back we just need to say kubectl rollout undo the deployment whatever we have done. So kubectl rollout undo deployment, and my deployment name is my first deployment. We can even copy paste, or we can even do this way. So let's execute one more time. Okay, so the changes got deployed. So now, which means like from v3 it should go to v2 version. And so let's see the rollout history one more time, right? So rollout history and remove the revision so that we'll see all the history. So we should have a rollout history 4 now, right? So why? Because now we have changed it from 3 to 4, okay, and the image version from 3 to 2, which means here earlier you have the revision version 2, you have undo, means like you went to that version, so that's the reason now you got the 4 with 2.0.0. So now let's come back here. So if we roll back, it will go back to revision 2 and its number increases to revision 4. So our revision 2 number got revision 4 now, right? So now if you want, you can cross check your deployments and then replica sets, everything we can check now. So kubectl get rs, right? And it should be using the deployment whatever is used earlier for v2 version, okay, replica set, and get pods all should be deleted and then recreated now. So within last 76 seconds only. So all these got recreated. In the same way, if you want, we can access the application and then we should see v2 version of our application, because that is what we have rolled back now. So let's go back here, and currently it is v3, and then we roll back it to older version which is v2, and it should see v2. So that's the story here. So now in our next step we need to move on with the roll back to specific version. So let's do that now. So as usual, you can see your rollout history, and then we have seen just now that is nothing but 4 is the current version, right, with the 2.0.0 as the image. So now I want to roll back to specific version, and my specific version is going to be version 3, which is nothing but where I have the 3.0.0 application v3 version I am having here in this revision 3. So I'm going to say kubectl rollout undo deployment, my first deployment, and then I'm going to give the revision number here, which is nothing but to specific revision, and my revision number I am saying is this one 3, so which has the image 3.0.0. So I will say this, right, and once the changes are done, immediately we are going to see it roll back to that version. So I'm going to first check the pods, okay, and then it is deleting and then recreating it, and we will go ahead and then get the rollout history, right? So we should 3 should go away, and then we should get the same thing as 5, and we got it, right? So that's the thing. So now we can access the application, and we should have the v3 version of the application because we roll back to that version, okay, you can see that. So that's about the 0403 rollback deployments. One last thing in this is like if you want to restart your applications in a rolling restart fashion, means like all the pods need to be restarted due to some memory issues or some whatever you have. And if you want to restart your application, so you can do a kubectl rolling restart, and in your deployment name, right, deployment space deployment name, or deployment / my first deployment, and it will do the restart. So once the restart is done, you can say kubectl get pods, and the restart should be happening now. See, so now if you see here, all restarted. 8 seconds is the age, you can see it, right, 13 seconds. So just now all these things got recreated immediately. Okay, so that's about the rollback deployment. So in our next lecture, we'll focus on pause and resume deployments. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to learn the pause and resume deployment options in our Kubernetes deployments. So let's go inside that 0404 pause and then resume deployments, right? So why do we need pausing and then resuming deployments? So if we want to make multiple changes to our deployments, we can pause the deployment, make all changes to our deployment, and then resume it. So if you don't do so, as soon as you keep applying the changes to your deployment, live deployment, then automatically the changes gets deployed and then pods get terminated and then recreated. Okay, so what we are going to do is we are going to make two changes. One is we are going to make our application version from v3 to v4 as part of this pause and resume deployments, and one more change also we are going to apply about applying the CPU limits for our application. So we are going to do all those things. Okay, so before that, check current state of your deployment and then application, right? So if you see kubectl rollout history deployment, my first deployment, and then see our application current rollout versions, whatever we have here, right? So we are at 6 with the kubectl edit deployment here, right? So we are at 6 now, which means, and also verify your number of replica sets, how many you have currently, right? So mostly you should have 4 replica sets here, right? So now if we create one more version, one more replica set should get created. Okay, make a note of the number of replica sets present here. We have currently 4 replica sets present, and our rolling versions also we are seeing till 6 we are here. And one more thing is access your application and see the application version. So now I am accessing it, and if you see, we are in the v3 version of our application. So let's go inside and then pause deployment and make these 2 changes. Okay, so now what I'm going to do is kubectl rollout pause, means like I'm going to pause our respective my first deployment. So let's go ahead and then do that now. Kubectl rollout pause deployment and my first deployment, right? So once we have paused our deployment, so we can make whatever the changes we want to. So we are going to update our application from v3 to v4 using 4.0.0. Earlier, whenever you have done this set image command, automatically changes happened and then all the pods got recreated, all those things. Okay, so but now whenever you do this, nothing should happen. Okay, so as our deployment got passed, whatever you do on the live deployment object, nothing should happen. So everything should be as is. So if you go ahead and then see the rollout history, okay, so we should see the same thing, which is nothing but it is only at the 6th level, right? So no rollout history because it is in the deployment pause mode. If you see the replica sets, you should have the same count of replica sets, whatever you have seen earlier, which is 4 replica sets, right? So now if you resume the deployment, so then automatically changes will happen. Before that, we'll also make one more change saying that kubectl set resources for my first deployment with for the container kube nginx, and I am saying how much memory and then how much this one I am going to allocate. I am writing it here. So maybe I am using a simple cluster here. So this might be a bigger number, which is nothing but 512 mi and all those things. So I will say, okay, 30 mi, okay, 30 MB or even less. Okay, so I'm not even putting anything, right? So and then I'm going to put 20, right? 20 M CPU. Okay, so instead of 200 M CPU, I'm just giving 20 M CPU, right? So, and then make this change, right? So why? Because I am using a T3 medium cluster. So ideally if I give this much, then I am already using 10 pods. So then it is going to create a lot of problem for us. Okay. So this error you can ignore. So it's a timeout error. Okay. The change got applied. Okay. So now if you go ahead and then see your rollout history, still nothing should happen. We have made 2 changes, but nothing should happen because still we didn't resume our deployment, right? So, and if you see the application version also, it will be only v3 only. Okay. So now let's go ahead and then resume our application deployment. So kubectl rollout resume and then deployment / my first deployment. So let me do that. So as soon as we do this and then see the rollout history, then you should see the 7th version coming in. You see the kubectl get pods and they should get created, right? And then few are terminating and then few are creating. So all these things happens now. Okay. And we can go ahead and then access our application and see what happens. Okay. So let me go to my application and then access it once all pods are ready. And also let's cross check our replica sets count. Get RS, right? Earlier it is 4 replica sets and now as it is 4.0.0 version, we should have 5 replica sets. Okay, 1, 2, 3, 4, 5. That's good. So now let's go ahead and then access our application. We should see the v4 version of our application. See, now we have the v4 version. So we have successfully tested in deployments the following things: creating a deployment, scaling the deployments, exposing the deployment as a node port service, and updating the deployments with 2 options available for us, which is set image and then edit deployment. And also we have rollback the deployments using to previous version and to specific version. And in addition to that, we have also tested the pause and then resume deployment. So this completes the deployment section using the imperative commands. So let's go ahead and then do the cleanup of whatever we have created, right? So kubectl get deployments and then delete the deployment, right? Delete deploy and my first deployment got deleted, right? In the same way, delete svc, right? So before that we'll get the name of the service, get svc, and then delete service my first deployment service, right? So now if you see kubectl get all from our default namespace other than cluster IP of Kubernetes, nothing should be there. So we have completely cleaned up everything. So this completes the deployment section, and in our next section is going to be services, and then we will see services concepts in our next section. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes concept named services. So we have multiple Kubernetes services available here, like cluster IP, node port, load balancer, ingress, and then external name. So let's see one after the other what are they on a very high level. So cluster IP is used for communication between applications inside the cluster. Example, like you have front end and then back end application, and then they need to communicate each other, so we can use cluster IP. So the cluster IP's network range is inside the cluster, Kubernetes cluster. So let's see node port. So node port is used for accessing applications outside of Kubernetes cluster using worker node ports. So your Kubernetes, you have deployed an application in Kubernetes cluster and then you want to access it from your browser. So you can expose that as a node port service, so that using worker nodes respective port, you will be able to access outside of the Kubernetes cluster. And the next is the load balancer service. So primarily for cloud providers to integrate with their load balancer services. So example, if you take AWS, in AWS you will have something called elastic load balancer. So how you are going to use Kubernetes manifest to automatically provision a load balancer in AWS? So you can do all those things using load balancer service. And the next is ingress. So ingress is an advanced load balancer which provides context path based routing, SSL enablement, and SSL redirect, and many more. Example, you can compare it with AWS application load balancer type of concepts. So it has all the HTTP based features available inside that which you can leverage. So in the same way, the next is the external name. So to access externally hosted apps or databases or something inside your Kubernetes cluster, so you can use external name service. Example, for your application which you have hosted in your Kubernetes cluster, you have a AWS RDS database, a cloud provider database, and if you want to access it, so using that respective database's DNS name, using external name service, you will be able to access that in your Kubernetes cluster. So these are the core things available here. As part of the fundamentals, we already looked into node port service. Now we are going to look into cluster IP service. In addition to that, combining node port and cluster IP, we are going to implement a front end and then back end one example, so that we get a complete picture about node port and then cluster IP. And load balancer and then ingress and then external name will focus on when we are doing the respective cloud provider courses. So let's move on and then understand whatever we have discussed in a pictographical manner. So let's consider in a Kubernetes cluster, you have deployed your backend application. Example, like some REST services application or whatever is your backend application. And this backend application is currently using a RDS database which is in AWS. So if you want to access that from inside your Kubernetes cluster, so you need to define a DB external name service here. In the same way, you have your front-end application, right? And then this front-end application need to access your back-end application. So for that purpose, you need to define your cluster IP service in your Kubernetes cluster. And now your users want to access your application here, okay, in the which is hosted in Kubernetes cluster. So for that purpose, you will deploy your front-end service, okay. So it might be a node port service or load balancer service or ingress service. So based on the environment you are using and whatever is applicable for you, accordingly you can deploy that ingress service or load balancer service or node port service. So all in all, this is the way the services can be leveraged for us inside Kubernetes cluster in combination with external applications or internal applications. So in our next lecture, we'll go ahead and then implement our front end and then back end application with node port and then cluster IP. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to do the Kubernetes services demo. So let's see what we are going to implement as part of that. So in a Kubernetes cluster, we are going to do a backend deployment. So we have a simple Spring Boot REST services hello world service. So we are going to deploy it. As soon as we create the deployment, automatically its equivalent replica set and then pod gets created. So once that is done, we are going to create the backend app related cluster IP services using kubectl expose. So once we do that, so we'll go ahead and then create the front end deployment. So in front end, we are going to create a Nginx pod, and in that Nginx pod, we'll have a proxy to this respective cluster IP service of backend, which is nothing but my backend service. Now, for the users to access our application, we'll also deploy the front end app node port service so that users will be able to access it. So let's go to our GitHub repo and we'll go to our 05 services with kubectl, right? So introductory section we already discussed in our previous lecture. So let's go on to our step 2, which is cluster IP service backend application setup. So let's deploy a simple backend application and then front it with a cluster IP. So the application we are going to use is a simple Spring Boot REST application, just a hello world REST application. So what we need to do if we want to deploy a application, we just need to create a deployment and then front it with a service. So kubectl create deployment my backend REST app and the image of that, right? So let me copy this, go to my terminal and then paste it. So it should create our respective application, right? So we can say pods to see our pod is running, yes. And if you want, you can even say logs-f, okay, kubectl logs-f, and then check the logs of our Spring Boot application. It should be up and running now. Started your hello world application in 3 seconds on port 8080, okay. So if you see here also, we have exposed, means like we are going to expose as a service with the port 8080, right? And the target port is also 8080. So we really don't need to mention target port 8080, but for our convenience, means like following a standard, so I just put it. In addition to that, you really don't need to provide when you are creating a service using kubectl imperative command expose, right? So you really don't need to provide type is equal to cluster IP here. Reason is cluster IP service is by default created by, means like it's a default service, okay. So we really don't need to specify that. If it is a type is equal to node port, yes, we need to specify, but for cluster IP we really don't need to specify it. So kubectl expose deployment my backend rest app port, target port, and my service name, my backend service. The service name is my backend service, okay. So now everything is created, kubectl get svc. So my backend stuff is completed now. So now I need to create a front-end Nginx reverse proxy, and then that Nginx reverse proxy should proxy to this my backend service. So for that purpose, I pre-built the container and then put it here. So if you go to our node port service, so in my Nginx conf, I have put in the proxy pass my backend service colon 8080 as the port, whatever we are seeing, right? My backend service, and then port is 8080, right? So if it is not in default namespace and then some other namespaces or something, again we need to give the full cluster DNS name, which is svc.default.svc.local, all those stuff we need to give, but as we are running in the default namespace only, okay, kubectl get ns, right? We'll list the namespaces. This is a different concept which we'll look into it later, but currently we are in the default namespace. We really don't need to provide any full cluster DNS host name here. So that's the reason, to make it very simple for you and not to confuse too much. So I just gave whatever is my cluster IP service name here. The same thing I have provided, right? And then I have pre-built the image and then put it ready. So in our Docker Hub, so we can directly use it and then run these commands and then everything should work for you, okay? So and no, I want to create my own reverse proxy related Docker image, okay? Yes, you can do it. So I have provided the steps and the source here, kube frontend nginx. If you click on that, so it will take you to 00 Docker images, 03 kube frontend nginx, okay? So prerequisite is you should have your Docker account, and then you can create your Docker file like this. Everything is present in this v1 release, the Docker file, and which is nothing but from nginx you are taking your source image as nginx, and you are copying the default.conf whatever is there in the current directory to etc nginx conf.d, right? So if you see in v1 release, you will see the default.conf also here. Inside that you can see proxy pass, backend cluster IP service name, and then port. That's what you have put it here, okay? So the same thing, and you can go here and then review these things, and then after that you can go into this v1 release folder, right? cd to v1 release, and from there you can build it, docker build -t and your docker hub id and the kube frontend nginx :1.0.0, and take the files from the current directory dot, okay, and then push that to your docker hub id, and then you can start using it if you want, okay? So but for me, like, you can leverage this current whatever the Docker image, and then you can continue, but it's up to you. Just I have given why, because it is nginx, right? So I didn't give any steps for related to Spring Boot related application. Why? Because again it might confuse you and then create complex stuff, but here for nginx it's a simple thing, right? So you can try out your Docker skills there with those steps, and then come back and then leverage that here so that you will be more confident. So for that purpose I gave the detailed steps for kube frontend nginx building, okay? So now a lot of things we discussed it, so let's go ahead and then create the front-end deployment and then create the front-end expose that as a service, okay? kubectl create deployment, my front-end nginx app is my deployment name, and the image is cube-frontend nginx. Okay, so let's take this and we are here. Okay, created, right? And now let's go ahead and then expose it, right? So clear kubectl get pods, both pods should be running now, and get svc, we should have two services related to backend service and then front-end service node port and then node port id. So if you want to access your application, so you can say get nodes and -o wide, right? And take the public IP here, and 32209 is our port. So let's go to the browser and say okay, and /hello, right? Sorry, so the IP colon 32209 is my port, and then /hello is the context, right? So we got the response. So let me make it bigger, and if you see it here, 32209 is our node port and then /hello. So that is the thing. So the same thing we have done it, 32209, and the context is /hello. Good. So now what we are going to do is, so we are going to scale our backend application so that how the load balancing happens, and then you can even see different values here. Where is this? Here, right? So this container ID, right? So this is going to change continuously. So whenever you refresh the browser. So let's test that for our convenience. Okay. So kubectl scale -- replicas is equal to 10 and my backend application. Okay. So I'm scaling my backend application. So let's go here and then scale it. So now kubectl get pods, my backend should be 10 backends I should have, right? So it's coming up. So let's, okay, so all are up and running. So now let's go ahead and then test that now. Okay, so where is this? Here, right? So I'll keep saying refresh, right? Okay, so we can refresh it. Something, okay, see, you can see this is changing continuously. H60 MB now. So it's load balancing across all the backends, right? 9GVFM, WNZZ. So like this you are seeing all the containers are up now and then healthy. We are not even seeing that error. Okay, so VFMWG. Okay, so you can see how it is going on. So that's about it. So we have completed our services demo successfully. And one thing here is we really didn't look into load balancer and then external concepts here. So these things we will look into as part of our series of courses, whatever we are doing for AWS, Azure, and then Google Cloud. So in those things, we will extensively look into this stuff. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So far, we have completed from Kubernetes fundamentals perspective. Using imperative way, we have created a pod, and for replica set, we really don't have a imperative command using kubectl. So we used the YAML format to create it, and the deployment and service also using imperative way, we have created it. So now using YAML and then kubectl, we are going to create pods, replica sets, deployments, and then services in a declarative manner using YAML. So let's go ahead and then do that now. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about YAML basics. To write Kubernetes declarative manifest, we definitely need a little bit of knowledge on YAML. So we are going to look into a few YAML basics which are required for our Kubernetes manifests. So let's go ahead and then understand what is YAML on a high level, and then move on and then implement few sample things required to understand better about YAML. So YAML is not a markup language. So YAML is used to store information about different things. So we can use YAML to define key value pairs like variables, lists, and then objects. So YAML is very similar to JSON, which is nothing but JavaScript object notation. YAML is primarily focuses on readability and then user friendliness. So YAML is designed to be clean and easy to read. So we can define YAML files with two different extensions, .yml or .yaml. Anything would work for us. Okay. So the next thing is, what are the core topics we are going to cover here? Okay. So YAML comments, and then key value pairs, dictionary or map, arrays or lists, spaces, and then document separator. So let's go ahead and then implement them now. So we'll go back to our GitHub repo, and we are in Kubernetes fundamentals GitHub repo, and we are going inside 06 YAML basics. So we are going to start with comments and then key value pairs. So in YAML, so to define comments, you are going to provide it with hash, and key value pairs you can see name colon space and then value. So key colon space and then value. Space after colon is mandatory to differentiate key and then value. So let's go ahead and then define this on YAML now, right? So here in our YAML basics, we'll simply say sample file.yml. So I try to use YML instead of YAML in all our notifications, so both are same. So we are going to define a simple key value pairs. Okay, so now we are going to say name is equal to Kalyan and age is equal to 23 and city is equal to Hyderabad. Okay, so everywhere if you see here space, so this space is mandatory for any of these things. Okay, so to differentiate key and then value, so we need to have this space. So if you remove the space, you can see that the notation looks different, right? So have the space and it looks as a key value pair. And now we are going to use Visual Studio Code for that, and whatever you want, you can just go here and then say VS Code download, and then you will be able to download the Microsoft Visual Studio Code. And next is dictionary or map. So what is a dictionary or a map? So set of properties grouped together after an item is called dictionary or map. Okay, so now if you see here, this name, age, and then city are grouped under a property or an item named person. So now person item has these properties. So now this person is a dictionary object. Okay, so now let's define that now. So we are going to say person and like this. So if we define like this, so these are not grouped under person. If you see this one, so this is one more key value pair like it looks, so it is wrong. So now we need to select all these things and then say tab. So we need to have equal amount of spaces here, and now if you see, this is the parent and these look as child. And now under person we have these properties, name, age, and then city. So now this is dictionary. Okay, so now the next thing here is equal amount of blank spaces required for all the items under a dictionary. So we have equal amount of spaces. So one tip here is whatever you select here. Okay, so if you say enter, directly it will come here in Visual Studio Code, and then if you want to write something else, you can write school. Okay, ABC school, something if you want to write, you can write. So directly it will come under the same indentation level in VS Code. Okay, and another important thing here is whenever you are writing YAML in VS Code, so if you want to give these indentations, you can say tab, and then it gives us two spaces for us. So instead of typing 2 times space, so you can even say tab, tab, tab wherever you want to write. So that is one way of doing it. So now we completed the dictionary and then map. So let's understand about arrays or lists. Okay, so dash indicates an element of an array. So I have something called for this person, he has some hobbies, and list those hobbies. Okay, so listing means those are lists, right? So now we'll go here and immediately under hobbies, right? So I'm going to say tab, and I'm going to say cooking and cycling. So like this. Okay, so like this you can write those things. Now one more means like list you can define this way, or you can define the list in the other way, which is hobbies and then square brackets, and you can say cooking comma cycling. So in any way you can write the list. So this one we are not going to use. In entire Kubernetes manifest we are going to use lists this way. So now the next thing is multiple lists. So how you are going to define multiple lists, right? So let's example, you have friends, okay, and you want to define your list of friends. Okay, so I can say name of my friend is friend 1 and his age is 23, and I have one more friend, okay, so whose name is friend 2 and whose age is 22, and I have one more. So you can, like this you can keep writing the lists. Okay, so multiple lists. Okay, multiple lists. So that's about multiple lists, whatever we are going to define. So now you can consider this as one document, this person document as one document. So what next? Okay, so you want to write one more document in the sample file. Okay, so in the sample file YAML I need to write one more document. I really don't want to create one more file here saying sample 2.yml, and then I really don't want to write it here. I want to write everything in a single file. So for that what I can do, right? So there will be something called document separator in YAML. So I can say this one, and then now I can write one more file here. Okay, so I can copy my sample pod template and then paste it here. Now if you see, so this is a separate document of YAML, and this is separate document, and then it is separated using, okay, document separator, right? YAML document separator. That's the thing. So if you see here, this pod template and all these things, we'll move on with next steps of live template writing, and there also you will understand in detail. But you can see here, you can define, you can come from top. So API version is a string, and then we have v1 value, and then kind is pod and it's a string, and metadata is a dictionary, and you have name and then labels. Under labels you can define multiple values here. Okay, so tier is equal to front end, etc. So now this is one more dictionary. Okay, and under root element spec you have containers, and on containers you can define multiple things. Okay, so here it is one more time, you can say this as list, and under containers this is one container. If you want to define one more container, so you can say name and container is my app2, and then you can write one more image here, right? So I can say, where is this? So I can even write here image is equal to abc slash something stack simplify slash cube nginx 2.0.0. and if you want to define ports one more time for this respective container, then you can even define those things. Okay, and then you can define container port and all the information you can define. So like this you can keep writing whatever you want in the format it is required in YAML. So the core things involved around the YAML is comments, key value pairs, dictionary or map, array list, spaces, and then document separator. These things will be sufficient for writing our Kubernetes manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to write pods definition using YAML. So we are going to go to 07 pods with YAML. So we are going to do this in 3 steps. One is we are going to understand about the YAML top level definitions, and then we are going to create a simple pod definition using YAML, and then to test whatever the pod we have created, we are also going to create a node port service using YAML. So let's go ahead and then do that now. So if you go inside the kube manifest, you will have 3 files present here, which is kube base definition, pod definition, and then pod node port service. So the pod definition and pod node port service are going to be empty. So we are going to write them now. Okay. So let's go to kube base definition. So I'll take you to my Visual Studio Code, and if we go to the kube manifest, and inside that you can find kube base definition.yaml, right? So if you see here in Kubernetes, the 4 top level YAML items are API version, kind, metadata, and then spec. So let's see one after the other. So in Kubernetes, everything is nothing but objects. So the core objects what we are discussing now is pods, replica sets, deployments, services, and many more we can add, right? So if you see, we'll start with the kind. So the kind is nothing but the K8s objects, which is nothing but Kubernetes objects, which is nothing but we can define our pod here or replica set or whatever is the respective object. For that, whatever the YAML definition we are writing, that respective Kubernetes object will be defined here, and its equivalent API version we are going to define here. Example, if it is V1 or whatever it is, right? So how we are going to know what is the API version for this respective Kubernetes version, or maximum it is not going to change for most of the time, but here and there new changes comes into these objects, and then this API version keeps changing, not very regularly, but here and there sometimes. Okay, so for that purpose, always if you want to go and then refer the latest documentation, so we can go here, and if we go here, so you can find here. So this is the pod v1 core for v1.18. What is the definition? So let me open it here, and you can see here pod v1 core. This is the API definition. So you can see the version is v1. So which means we can define our version as v1, and then kind is pod, which is nothing but pod, right? So now if you want an example of the pod, you can even see here, right? So now the most important thing here is whatever we are going to try to do here is we are just going to create a simple pod and then expose it as a service. But what Kubernetes recommends is never ever go and then directly create a pod. So always a pod need to be created using a controller like deployment controller or job controller or stateful set controller. Okay, so this is just for our testing and then understanding about how to create a YAML definition for pod. So we are creating the definition and then we are creating the pod, but it is recommended always to create it using respective controllers. So let's come back here, and so let me remove this whatever we have created here, and now let's copy this, right? So this we are saying these 4 are the top level objects. One is API version, kind, metadata, and then spec. So what does metadata mean, right? So you are creating a object of type pod and its name, right? The pod name you can define here. Okay, so it can be my app pod, something like that, right? And you can even define additional labels here. Okay, so label can be app is equal to my app pod, something, whatever you want. Okay, so but the core thing primarily is 2 things which it will have primarily is name and then labels, and under labels you can again define your key value pairs, whatever you want. Okay, so but name is always required for any of the Kubernetes object whatever we create, right? So in the metadata, the one thing important is name and the other is labels. So later when we are doing the advanced stuff, we will even defining the namespaces and all those things, but core is name and then labels will be always a mandatory thing which we need to fill when we are defining it. Okay, so in such a way that which will be useful for us in the long term, or we can make it as a best practice to ensure that in metadata, name and then labels we are going to definitely use it. And finally specification or spec. So spec is nothing but our respective Kubernetes objects specification, whatever we are going to define. So the core content what we are going to define. So let's go and then remove this and then take this and then go to our pod definition here, right? And copy in the pod definition. Okay, so now we have seen that for our pod the version is v1. So API version : space v1, and the kind is going to be pod. And the metadata, under metadata we already know that name we are going to define, and we are going to say my app pod is my pod name. And labels, right? So when we have multiple number of pods and then multiple objects in Kubernetes, if we want to filter about for this respective application, what is my set of pods or set of services, all those things, labels will be very helpful in the long term. So always it is good to define at least one label for our application, right? So again, labels is going to be a dictionary object. So if you see here, metadata is a dictionary object, and if you see here, on that we have defined name and then labels. And under labels, again we can define multiple key value pairs. Example, app is equal to my app, and I can say tier is equal to front end. So like this, how many labels you want, whatever you feel like in future you can use it for filtering or whatever the basis. So you can keep defining those things. But for now, I will leave it as very simple. Name is equal to my app pod, and labels is equal to app : my app. Okay. So now the specification of our core pod, right? So every pod, what it does, okay, it usually runs a container. So if it need to run a container, it need the container image information, right? So it will have a object named containers here, item named containers. Okay. And this containers is a list. If you see here, I can say this as a, so I'm just dictionary. Okay. And again, this is one more dictionary, right? So in YAML terms, I am defining these things. Okay. So if you see, this is a string, right? And again, this is a string, right? So containers is a list, which means I can define a list of objects here, right? So why? Because in any pod, we can run multiple containers. We have already discussed about multi-pod applications, right? So we can define multiple containers inside a single pod. That's the reason under containers, you can define multiple containers. Due to that, you will get this list object as the containers. Okay. So, and I'll say my container name as my app, and I will define its image now. Okay. So I can say stack simplify / 1.0.0. So this is a simple Nginx image I have built and put it in my Docker Hub. So we are going to use it. So, and under this respective means like this is a list, and then if you want to define one more container, you can again define with name, right? So my app backend or something, right? And its image you can define here, and if you want, you can define its container ports and all those things. So we'll define additionally ports for this container. Okay. And the container port is going to be 80, right? So I'm going to remove the other container. We are just going to do it with simple one container in a pod. So 99% cases, we are going to have one-to-one relation with our pods. So that is pod to container. So we'll also follow the same standard here. Okay. So this is my pod definition. So in our next lecture, we'll focus on creating the node port service. But for now, we'll go ahead and then create this pod and then verify it. Okay. So let's go back to our browser, and now we have created the pod, and then let's go ahead and then create the pod definition in our Kubernetes cluster, right? So we are in the Kubernetes fundamentals folder. So we'll go into 07 pods with YAML, and we'll go inside kube manifest, and then you can find the 02 pod definition, whatever we have created. So you can even see what we have created, right? So now we can go ahead and then run it, right? kubectl create -02 pod definition.yaml. Right, it is getting created. Okay, so now my pod got created. So kubectl get pods, and the pod is running, right? So in our next lecture, we'll go ahead and then create the node port service, and then we will test it. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. Let's go ahead and then create a node port service to access the pod whatever we have created using YAML definition, right? So let's go to our Visual Studio Code, and this is the 02 pod definition whatever we have created, and let's again take our API version base and then put it in 03 pod node port service. So now let's see what is the kind we are going to create is service and its API version, right? So let's go here and then take the documentation reference. So I can go back and put it in new tab. Okay, so this is the service pod API object reference. Okay, so let it open. So we can see the version we are going to use is v1 and the kind is service. Okay, so I will say v1, and now let's define the metadata. So metadata is going to be the name of my service. So my app pod related node port service we are creating, right? So nothing but we are creating the name of the service here. Okay, so and now if you want we can even define labels for our service if you want to. Okay, so app is equal to my app. So this is optional for services, but if you want to create we can create. Okay, so if you want to filter our services, means like we have created multiple services for a specific set of applications, and then if we want to filter them using the labels all those services, we can still define our labels for our service. Okay, so and now the next thing is spec. In spec for a node port service, the type of the service we are going to do, which is nothing but node port, right? What happened? Yeah. And the next is, so we'll have something called selector, and one more will be there, ports. In service, these are the high level objects, type, selector, and then ports. So the selector is nothing but, so we need to load balance the traffic across pods using these labels and selectors whatever we have defined here. So if you see here in the 02 pod definition, our pod label is going to be app:my app, right? So if you define this in this, means like if you go ahead and then define that respective label here, the same label, so what it states means is load balance the traffic coming to the service across pods matching this label selector. So whatever the traffic coming to this service, if we need to route the traffic to that respective pod, this service is going to identify this pod based on this label app:my app. So this is the key value pair. So based on this selector only, it is going to send the traffic. So whatever is defined in the selector, the labels defined in the selector, only to those pods it is going to send the traffic on a very high level. So let's also define the pods. So we have also seen this, the name of the ports we are going to define is HTTP, and this is name is optional thing. Okay, if you want you can define, and I'm going to say my service port is going to be 80, and the target port is nothing but my backend application port, which is nothing but my pod respective container port. Okay, and one more thing we can do here is node port. So if you want, means like whenever we have created a node port service using imperative commands, we really don't have an option to define the node port specific port. Okay, but when you come to the YAML definitions, you get that advantage to define it. So let's go ahead and then define that. So I'm going to use the port as 31231. So you can say this as node port, and this as container port, and this as service port. Okay, so like this you can define all the stuff here in your service. So if you see on a very high level in service, the core thing here is this labels is optional. If you want you can have it or you can remove it. If you are getting confused with selector and then that label, just remove it. Okay, so in metadata the name is the core thing, and you have defined the name as my app pod node port service. And in spec, three things are important: type, selector, and then ports. And then type is node port you have defined. So if you are using the load balancer service, you are going to say load balancer, right? or if you are defining the external name service, you are going to say external name, or if you are going to define the cluster IP service, you can even say cluster IP. But cluster IP is the default service it creates. You really don't need to define the type there. Okay, so that's about the type node port. And selector and then ports. You will also have selector and then ports. Ports we have defined here. Selector is nothing but whatever you define the label inside the selector, right? So if that label matches with the pod's respective label, then the traffic will be sent to those respective pods, or traffic will be distributed to those respective pods whose labels match with the selector value present in a service. So that's about it. So let's go ahead and then create this service now. Okay, so kubectl create -f and 03 pod node port service. kubectl get svc. Our service got created. So let's go ahead and then access this now. So I'll say get nodes -o void. Right, so I can take any of the external IP here. I can go to browser and 31231, right? So welcome to Stack Simplify Kubernetes Fundamentals Demo application V1 we have up and running. So we have successfully created the pod definition and also the node port service using the YAML. So in our next lecture, we'll focus on replica sets. Okay. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to create the definition, YAML definition for our replica sets. So this is nothing but 08 replica sets. So let's go here, and as a step 1, we are going to create the replica set definition. And then as a step 2, we are going to create replica set and then verify it. And as a step 3, we are going to create the node port service and then access it via browser and then test it, right? So let's go to our Visual Studio Code. And if you see here, 01 is the kube base definition, which will have API version, kind, metadata, and then spec. So let me copy this, go to our 02 replica set definition, which is empty. I copied these things. And then let's move on to find the API version by referring our documentation here, okay? So Kubernetes API reference doc for replica set is v1 apps, okay? So which is nothing but group is apps and then version is v1. So let's make it as apps/v1, okay? So if it is core, we really don't need to mention it is core. Just if you type v1, it is good. But if it is apps, then we can say apps/v1. And the kind is going to be replica set. We can see it here. So now one important thing here is 90% of the cases or many cases, what we know, always a replica set will get created or triggered by creating a deployment. So which means like 99.99% we try to create a deployment and automatically a replica set gets created. But why we are learning first replica set and then moving to deployment is both are same. It's not a different thing. But if we change this to deployment, the same thing, entire definition, whatever we are going to create now, is going to match with the replica set. And in addition to replica set, we can keep adding more and more features under the spec when you add it as a deployment, okay? But when it is a replica set, it is only a few things you can add here. But let's learn few things now and then extend it to become a deployment in our next lectures, okay? Always a deployment is a superset of the replica set. Or you can say that replica set is a small subset of the deployment features, okay? So now let's go to metadata. In metadata, we already know enter and then tab and then name, right? So this is a dictionary. So we are going to say name is going to be whatever we want, okay? So my app to RS. RS is nothing but replica set, okay? So and now let's start with the spec in our replica set, okay? So we'll have three things here to discuss. So one is replicas, okay? So second is selector, and third is template, okay? So now replicas are going to be nothing but how many replicas? Again, these are spec is a dictionary object, and then you have three types of properties under it: replicas, selector, and then template, okay? So let's start with replicas. So we need 3 pods to be created using this replica set. So that type of definition you can provide here for the replicas. And now the selector. Selector will have something called match labels. Okay. So what does this mean is like, what is your pod definition, how I need to identify your pod definition label, and then have the same thing here. Means like whatever we define the label for our pod, the same thing need to be defined here, so that replica set will identify this is my pod definition, and that respective pod definition need to be ensure that it scales accordingly, or it need to be increased or decreased, everything. Means like replica set will identify your respective pod based on the label you have identified in the pod, and then the same label if you mention in the match labels. Okay, so let's not define anything here. Let's move to the template first. Okay, so template is nothing but your entire pod definition copy should be present under the template. So you already know that we have defined a pod definition in our respective pods with YAML. Okay, so let me copy, means like let me open it in a parallel window. So how to open here is like let's catch control and then right click and open to the side. Okay, and let's make this simple. So now you have your pod definition here. So the entire pod definition from metadata. Okay, so kind and API version is not required from here. Okay, so from metadata to end, whatever is there, that is your pod definition, comes under your template section of your replica set. So go to the starting and then paste it. So is it aligned? So now let me close this pod definition. We really don't need, right? We copied it. Okay, so now it doesn't look like aligned. So why? Because it came at the root element, but ideally it should be under template as a child element. Okay, so what I'll say is select, and one tab, it came directly equivalent to template. So I'll again type tab one more time, so that now under template metadata is a child element and it has the pod name as my app2 pod. So we are checking for 2, right? So in the labels I'll say app is equal to my app2. Okay, and spec containers, and then container name my app2 container, or whatever you want to put it here, that is fine. Okay, so that's all. Now this is the template section. So now we need to discuss about match labels, means like selector match labels for our replica set. So whatever the label we have present in our pod definition here, right, my pod label, the same thing should be present here. Okay, so I'll paste it here. So if you see now under match labels you have my app2, which means like the replica set will identify this as your respective pod. It need to scale up or scale down. Okay, so this pod. Okay, so one more change we will do here is this one. Okay, so earlier for the pods with YAML we have done 1.0.0. So now what we'll do is like we'll use 2.0.0. So now your tag is app2. This will not be in confusion with the existing my app pod, whatever you have created as a single pod. Okay, so you will not have any issues related to that. Okay, so now let's go ahead and then create this pod and then test it. Okay, so now we'll go here and then now we are going to create our pod. Okay, so let's go back here, and I should be in the section 08 replica sets with YAML cube manifest. I am inside that. So I'll say kubectl apply -f and 02 replica set definition.yaml. So if any issues, it is going to throw an error for us. It didn't throw any error. So get rs, it looks good. Okay, so let's wait for the response to come back. So all are running, current and ready, everything is ready. kubectl get pods, and we should see the pods running. So kubectl describe pod and then my app2 pod. Let's describe it. Okay, and see if it is 2.0.0 image is running here. Okay, so yeah, I downloaded and then using the 2.0.0. So now one thing we can do is, we already know replica set will ensure that always whatever the defined replicas present inside that, it is going to maintain the same number of replicas. So what we are going to do is kubectl get pods, and then we are going to delete one pod, and then automatically your replica set should recreate that pod. So it's taking time. So now my replica set related pods are running. So I'll say kubectl delete pod, and I will delete this respective pod. Okay, and its age now should be not 93 seconds. Okay, so it should be lesser than that once replica set creates it. Let's cross check that now after the deletion is completed. So one more time, kubectl get pods. So I got a timeout error, we can ignore that. So now if you see here, these two parts are with the age of 2 minutes, but whatever we have deleted, it automatically recreated, replica set recreated, and it is 34 seconds. Okay, so in our next lecture, we'll go ahead and then create the node port service for this replica set and ensure that we access it via browser, and then in browser we get the v2 version of our application. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a node port service for our replica set and then test it. Okay, so let's go back to our Visual Studio Code and go to our cube base definition and then copy it in our replica set node port service. As we know, for our type of service we are going to create is service, and its version is v1, and the name of the service is replica set node port service. And for any service, the following three are the high level things, which is nothing but type, selector, and ports, right? So now let's start with the type, the node port service we are going to create. So let's mark it as node port, and let's complete ports before going to selector. Okay, so now ports, we are going to have a ports now, so which is list of ports. So now it is going to be name is HTTP and my port name. So this is the port name, and it is going to be 80, and we are going to define our target port, which is our container port is 80, and node port, which is nothing but on the worker node what port you want to use, you can define it. So I am going to say 31232. For our pod node port service, we use it 31231. Here we are using 31232. So now the selector, again as usual, go to your replica set definition, and then this is the label you have in your pod template. So let's get that, and then to these pods it need to load balance, right? Your respective service need to load balance or send the traffic to those respective pods. Okay, so then it need to identify the pods based on a selector. Okay, so that is nothing but label selector. So it is going to be my app 2. Okay, so now your node port replica set service is created. So let's go ahead and then create that now. kubectl apply 03, right? And if any error it is going to throw here, any definition error or something. So ideally no error. So get svc, it looks good. So 31232, our replica set node port service got created. So we can go ahead and then say get nodes -o wide and get the public IP and then access it with 31232. So if you remember here, so we are accessing 31231 with the v1 application with a plain pod, and with the replica set we are going to say 31232. Okay, and we should have a v2 version of application. So with the plain pod we got v1, and then with replica set we got v2. Okay, so this completes the creation of replica set definition using YAML. So in our next lecture we'll focus on deployment. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to understand about deployments with YAML. So 09 deployments with YAML. So as we discussed earlier, so deployments are nothing but, again deployment is nothing but a superset of replica set. So we have created a replica set in our previous lecture. So we are going to copy all those templates and then change its kind to deployment, and then container image to 3.0.0 for a difference, and then change the node port service to 31233 for accessing it on the browser. Earlier the pod is 31231 and replica set is 31232. You can see it here. Now we'll use 31233 for deployments, and then change all the names to deployment in the sense like the file names or whatever we see wherever, right? Instead of replica set, change it to deployment, and also change the labels and selectors to my app 3. Okay, and then create the deployment node port service and then list and then test it. So before going there, let's cross check our API reference document. And for deployment also, it is app/v1. So just if we change the kind from replica set to deployment, mostly our things should work. Okay, so let's go to our Visual Studio Code, and this is the replica sets with YAML cube manifest folder. So let me copy it and then go to 09 deployments and then paste it, right? And I'll rename the file to deployment here, okay, instead of replica set, okay, so that we have it as a deployment reference. Okay, and for node port service, whatever we are going to create also, I'm going to change it to deployment. Good. So now our base setup is done. So let's go to 02 deployment definition, and the first thing is API version, it matched with our this one. Okay, so we really don't need to change anything here. Okay, so only thing is kind is going to be deployment, and the name is going to be my app3 deployment. Okay, so now replicas are good, selector is good, and the app, which is nothing but the selector match labels, we said that we will change from my app2 to my app3. So let's change it. Okay, so and the template, my app3 pod, I can say this one, name of the pod, and the labels I can say my app3. So the most important thing is this one, the label and the match label, both should match, and the container name I can give it as my app3. And finally we also said that we will change the image version. Okay, so for our difference to see on our browser, so I'll say 3.0.0. so this completes the deployment spec update. So we really didn't add any new tags or anything. So this is like anywhere replica set is a subset of deployment, right? So all these things should work as is without anything. So for deployments, we can keep adding more and more stuff based on like how the deployment should happen, and then like it should be in a rolling update fashion, or it should be in a recreate fashion. So update strategies with the recreate or rolling updates. So all those superset options you can keep adding to your deployment if you want to. But the base is replica set and then deployment, more or less it is going to be the same way. Okay, so now let's go to node port service, right? So this is good and no changes required inside that. So let's go to node port service, and this is going to be a deployment node port service. Okay, and the selector is going to be my app3, right? And the node port I'm going to change is 31233. Okay, so now we have quickly completed creating the deployment definition and deployment node port service. So let's go ahead and then create them now. Okay, so we'll go to 09 deployments and we'll go to kube manifest, and I'll say kubectl apply -f 02 deployment definition. And if you want to also at the same time create one more, so that is nothing but 03, you can do this way. Okay, so now two files you have provided for kubectl to create. So it created my app3 deployment and then deployment node port service. So I'll say kubectl get deploy, which is the alias, and it's up and running. So I'll say kubectl get pods. So I should have 3 more pods related to my deployment got created. I should have 2 replica sets, right? One for the replica set whatever we created, and one which deployment created. Okay, and I'll also see the SVC. Okay, and it has the 31233, which is deployment node port service. So and we'll get the nodes -o wide, and we'll get the node IP, and with 31233 we are going to access it in browser. Okay, so next one, http://31233. Okay, and we see the v3 version of application. So with pods, v1 application, it's up and running. With replica sets, v2 application up and running, and with pods we have v3 application. So now we have successfully created the pods with using the deployment, and then we have tested it using node port service. So in our next lecture we'll focus on services, and there, as we already seen node port service effectively, there we'll see cluster IP service, and also we'll create a front end and back end application in services, and then understand it in detail and then test it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to work on services with YAML. So if you remember, when we have done with imperative commands, which is with kubectl, we have created a backend deployment, front-end deployment, and backend cluster IP service, and then front-end node port service, everything using kubectl. So now equivalent YAML files we are going to define and then do the same thing. So this is what we have implemented using imperative commands, and now using declaratively, we are going to write the YAML manifest for that, means like the Kubernetes manifest, and then test it. So we are going to create a backend deployment and then backend cluster IP service, and then we are also going to create manifests for front-end deployment and then front-end node port service. And then all in all, we'll go ahead and then deploy and then test it. So let's go ahead and then start with writing our backend template. Okay, deployment template. So as usual, again, we have 00 base definition and backend deployment, backend cluster IP service, front-end deployment, front-end node port service. So all are empty. We are going to write it now. So let's go ahead and then take our base definition, which is API version, kind, metadata, and then spec. So for deployment of our Kubernetes object is deployment, and its version is going to be apps v1. And in metadata, we are going to say name and then labels, two things, right? So my deployment name, I'm going to say it as backend REST app. Okay, and labels, I'm going to say app, and also I'm going to say tier. Tier, I'm going to say backend, right? And app, I can say backend REST app. And now in the deployment specification, so we have something called replicas, and we'll have selector, and we'll have template. Three things primarily, right? So replicas, I'll say 2 or 3 replicas, whatever we want. And in selector, we'll have something called match labels, and whatever we define in our labels of our respective pod template, the same thing we need to provide here. So I'll say it as backend REST app. And now in the pod template, right? So what are important things here? So we will have something called metadata and pod specification. Okay, two things which are on a high level, right? So now in metadata, I'll have as usual labels, and in labels, I'll define backend REST app. And if you want, we can even define the tier, right? So that's all. And now this is my container specification, right? So I'll say containers, and I'll have the name of the container, which is backend REST app, and I'll have the image, right? So image, I can get it from my Docker Hub. So let's go to Docker Hub, and if you see here, there should be something with hello world, right? So this is the one. So let me copy till here, and then 1.0.0, and this is a Spring Boot REST application. So it is going to have something called 8080 port. Good. So now if you see, we have completed the deployment specification. We have quickly written it in hardly less than 2 minutes. And everywhere, if you see, right, API version, kind, and metadata, common stuff here. And in the specification, replicas, selectors, and then templates. And the core thing which we need to verify is the selector match labels app is equal to backend REST app should match with my pod template related label backend REST app, and which matches, we are good. So now let's go ahead and then add the node port service for backend, cluster IP service for backend, sorry. So we are going to create a backend cluster IP service. So let's take this and then our base definition, copy here and paste it. And the kind we are going to create is service, and its version is always going to be v1 currently. And the metadata, we are going to have name and then labels, two things here. Okay, so let's go ahead and then define them. So name is going to be my backend service. So now this is very, very important. Okay. Why? Because if we remember in our 05 services section also we have discussed about it. Okay, so backend service name should be my backend service, so that front end Nginx proxy can proxy to this respective backend service accordingly. The container we have built for our front end service means like front end Nginx proxy with this my backend service in the proxy name. So Nginx proxy pass needs this name. Okay, so good. So now the labels, as usual, the labels are going to be app : backend REST app, and here I am going to say backend. Okay, so these labels, whatever we provide in services, ideally are not leveraged anywhere other than for labeling and then filtering, but as a standard, if we provide, that is very good option for now. Okay, in our current case, to follow the standard, we are adding it. Okay, so now for a service, there are three things which are important, right? So type, selector, and one more, which is nothing but ports. Okay, so now type. So for type, cluster IP is a default service. Okay, so we really don't need to mention type here. Okay, if you don't even mention also, it is going to directly create the cluster IP service. For node port or load balancer or external name, we specifically need to mention the type. So we are not mentioning it. So now selector. Selector is nothing but service selector. Means like this service to which pod it need to send the traffic. So it is based on the pod respective label. So in the backend deployment, you have the pod related label here, and it has the label backend REST app. So for that, it is going to send. So I'm going to say app is equal to backend REST app. So the next thing is ports. So let's define the name of the port is HTTP, right? And we can define list of ports here, which means this is HTTP ports, and then you can define HTTPS ports, and then some port as 8443, and then target container port as 8443, etc, etc, etc. You can define here. Okay, so but for us, we really don't have any HTTPS here. Only we have HTTP port, which is 8080, and which is nothing but the cluster IP service port. Okay, so let's define that cluster IP service port. Okay, and next is target port, so which is going to be another 8080, which is nothing but my container port. Okay, so now we really don't have anything. This is the cluster IP service. You really don't have anything, or we don't need to define anything like node port here. Okay, so let me remove, and I really don't have any other ports, so this is not required. Okay, so ports is nothing but a list. Usually it is a list. So list of ports you can define. So that's about it. Okay, so now we have defined the backend cluster IP port. So this completes the creation of backend deployment and backend cluster IP service. So let's go to that respective folder here. So I'll go to 10 services with YAML, and I'll go to kube manifest, and then we'll go ahead and then create apply -f, and I'll create 02 backend service, and one more time I'll also give -f, and then 02 over 03, right? 03, no, where is that? And 01 backend deployment. So we are creating the backend deployment and backend cluster IP service 01 and then 02. So let's see if we have typed anything wrong in our manifest, and then if we want to correct anything. Okay, so once it creates, we'll know. Okay, both got created, but we didn't see any issues. So we'll see kubectl get deploy, right? And it is taking a little bit of time for my cluster to respond. So my backend REST app is up and running. So I'll also say kubectl get pods, and my backend REST app is running. If we want to check the logs, kubectl logs -f, and one of the logs we can cross check here. So let me paste it. Okay, so started my hello world application without any issues. So we have tested our deployment. We'll also test the service, means like test in the sense verify our service. So my backend service, the cluster IP service got created with 8080 port. Okay, so this completes the creation of backend stuff. In our next lecture, we'll focus on creating the front end and then testing end to end. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create the front end deployment and then front end node port service. So let's go ahead and then complete that now. So let's go to our cube base definition, copy it, and go to our front end deployment and paste it. So now we are going to create the kind is deployment, and its version is going to be apps/v1. So now in metadata, there are two things which we need to focus. One is name and the second is labels. So name is going to be front end Nginx app, right? It is going to be a front end app, right? So and in labels, we are going to say app is equal to same. We can try and then put the same front end Nginx app. Okay, and tier we'll say front end. Good. So now we have completed the core section here, and now we'll focus on the specification section. Okay, so as usual, we know that for deployment we'll have replicas, selector, and template are the three high level objects under the spec. Okay, so now replicas will give 3, and in selector we'll have the match labels, and under match labels we'll provide the label as app is equal to front end Nginx app. This is the same match label we need to provide whenever we are creating the pod specification here, right? So and now under the template we are going to create the pod specification, and pod specification we'll have something called metadata and then spec. Two things under that. The child tags under template are metadata and then spec, right? So now in metadata, as usual, we can have name. So ideally, whatever the name we give for the pod here, it is going to take the reference from the deployment name. So ideally, we really don't need to give name here. So we'll focus on labels, and we'll have two labels here. One is app and the other is tier, and tier is going to be front end and app is going to be front end Nginx app. Good. So now the next thing is going to be specification of our container, right? So containers, we are going to have containers is a list of things, and under that we are going to have a container and then image name. Okay, so let's go ahead and then define those things. Okay, and we'll also have something called ports, and I am going to say container port is going to be 80, and name of my container is going to be front end Nginx app, and the image I am going to bring that from my GitHub repo, my Docker Hub repo. Okay, so let me go to my stack simplify here, right? So where is this? Yeah, repositories, and let's go to kube frontend Nginx. Okay, so this will have the my backend service as the proxy. Okay, so let me copy this till here and I'll paste it, colon 1.0.0, right? So this completes the deployment creation, and now we'll go ahead and then create the front end node port service. So as usual, go ahead and then copy the base definition here. So let's define the service. Kind is service and the version is v1, and metadata will have name and then labels, and in name we'll say front end Nginx app node port service, and labels I'll define it as front end Nginx app. Okay, so let me remove this, and tier I'm going to say this is a front end tier, right? Front end. Okay, and now in specifications we'll have three things here. Okay, type, selector, and then ports. Okay, so type we are going to define it as a node port service. That is good. And the selector, which is nothing but to which pod it need to send the traffic to from the service. So we'll go to here and then find the pod specific label here. App is equal to, sometimes we do the typos, so always go and then get from that respective pod template. Okay, so it is always good to do that way. Okay, and then in ports we'll have HTTP ports here, and I'll say port is nothing but cluster IP service port, and target container port, which is going to be 80, and node port. So till now our demos 3.1, 2.3.1, 2.3.2, 2.3.3 over, and we'll use 3.1, 2.3.4 for us. Okay, if you don't define, all automatically cluster will provide the dynamic IP here in the respective range. Okay, so we are going to define it 3.1, 2.3.4. So this completes the creation of service 2. So let's go back to our command line and then create those things. Okay, kubectl apply -f and 03, and then -f. 03 is deployment, and 04 is front-end node port service. So let's see if it creates, and if not, any issues. Okay, so it created the deployment, kubectl get pods. So we'll see what are the pods it's going to create. So it's created 3 front-end pods, no issues. Okay, so I'll say kubectl get svc, and our front-end Nginx app node port service also up and running. So now we need to get our nodes public IP and then access it in browser. Copy any of the nodes public IP here. So I can copy this one or this one, whatever it is, right? So I'll copy this and go to the browser, and I'll create a, so let me close this Docker Hub. So we have 1, 2, 3. Now we are going to create one more, and then I'm going to say 3, 1, 2, 3, 4, and the context of my hello world application is hello, and I got the output. So now let's clear here kubectl get pods, right? And you can see that backend REST app, and then this is the pod ID, right? So we are getting 56.4xn. Okay, so how the load balancing is happening, we can even continuously refresh and then see that. Okay, so see 4bcns. Okay, so one more time, if we refresh, it might go 56.4xn. So it is just load balancing across all the pods. As soon as we refresh, we are getting different IDs here, right? So that's about it. So we have successfully completed creating our backend and front-end applications using kube manifests here, and then deployed and then tested end-to-end. Okay, so in our next lecture we are going to learn little bit about recreating the objects using kubectl apply, and then understand better about it. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to delete and recreate objects using kubectl apply. So earlier you used to use kubectl delete, and then you used to provide the resource name to delete it. But here, whatever the resource you have created or the object you have created, you will be able to directly delete using by referencing those YAML files. Okay, so let's see that now. Okay, so kubectl get all will provide lots of stuff whatever we have created so far. So now we will say that, so we have 4 files here. So kubectl delete -f 01 and 02 and 03 and one more time 0-f and then 04. So all the things related to backend and frontend should go away now. Okay, so all got deleted, you can see, right? So if you say get all, so anything related to our backend and frontend should not be shown now. So if you see only the pod backend REST app getting terminated, you can see these things. Okay, so nothing related to backend and frontend will be seen after these gets terminated. Nothing, right? So now you can see deployments, only my app3 deployment. So nothing in the services also, there is nothing related to frontend and then backend. So that's about it. In the same way, if you want to create it again, you can create it directly using apply hyphen and then those values. But one more interesting thing here is, so if you have these 4 files and then creating apply and then -f01 and then -f02, again it's a long command, right? So what you can do is come out of your kube manifest and just let me go here, and I don't have anything here, so I'll say mv this file, right, 00. This is not a valid file, this is just only a definition for us, right? Paste and then paste, and then I'll say it as back up. Okay, so for our testing here. Okay, so now we have only 4 YAML files here, 1 2 3 and then 4. So let me come out of kube manifest and then I'll say kubectl apply -f and then kube manifest entire folder. So whatever the YAML files present in that folder, directly present, okay, not under the recursive folders, but directly present under that folder, it is going to get created. Okay, so if I say kubectl get all, again we'll be able to see the deployments and services, whatever related to front end, right? Front end and back end related pods are getting created, and its services also, front end Nginx and then my backend service all got created. So like that we'll be able to create and then delete. In the same way, if you want to again delete all these things, we really don't need to give that big command here. Okay, so kubectl delete -f and kube manifest, and then it is going to delete everything. Good. Okay, so now if you see get all, nothing should be there. So these are some of the things which we can effectively use for our, see, this is getting terminated, no other services related to front end or back end. Good. So now the next thing is go back to kube manifest and then change our file back, okay, to the same value, so that whenever you are doing the course, it doesn't give a different show there. Okay, so now this is completed. Good. So in our next lecture, we'll go ahead with another topic. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about AWS EKS storage. So in EKS storage, we have different type of drivers and then provisioners. So if you see here, we have in-tree EBS provisioner, EBS CSI driver, EFS CSI driver, and then FSX for Lustre CSI. So in-tree EBS provisioner is a legacy one and will be soon deprecated. So we are not going to look into that, and future it is going to be with the CSI drivers only. So what does that CSI mean is like container storage interface. So with EBS, which is nothing but elastic block storage, which is for persistent volumes, so we can use EBS CSI driver. And we also have elastic file system, which is a fully managed file system by AWS. So if you want to use it, we can use EFS CSI driver. In addition to that, regular FSX for Lustre CSI will be available for Windows file systems and other stuff. But the core thing here is we are going to primarily discuss on EBS CSI driver in our upcoming continuous lectures. And then we are going to use this EBS CSI driver, leverage this driver, and then use the EBS service in AWS to have the persistent volume mounts for our MySQL database. But let's see this a little bit about these drivers. So these are the latest and greatest available today, and they are in beta releases, but they are also ready for production use. And as on today, so these drivers are not supported on AWS EKS Fargate, which is nothing but serverless infrastructure. And it allows EKS clusters to manage lifecycle of EBS volumes for persistent storage or EFS file systems and FSX for Lustre file systems. So entire lifecycle of these respective services, which is EBS or EFS or FSX, can also be managed using these drivers from EKS. So now EBS and then EFS are supported for Kubernetes 1.14 and then later versions. And FSX for Lustre CSI is supported from 1.16 and then latest versions. So now moving on, So let's see little bit more about the EBS CSI driver, right? So before going in, so let's understand what is this Elastic Block Store before moving on. Okay, so EBS provides block level storage volumes for use with EC2 and then container instances. So we can mount these volumes as devices on our EC2 or container instances. So EBS volumes that are attached to an instance are exposed as a storage volumes that persist independently from the life of the EC2 or container instance. In simple terms, even if we terminate our EC2 instance, or even if we terminate, or if our container instance got terminated, or our respective Kubernetes pod got terminated, still volume is persisted independently. So we really don't need to worry about the data stored in those volumes, right? So we can dynamically change the configuration of a volume attached to an instance. We can increase the size of the instance, means like we can increase the size of the volume or decrease the size of the volume. We can do all those things. Okay, so AWS recommends EBS for data that must be quickly accessible and requires long-term persistence. So EBS is well suited for both database style applications that rely on random reads and writes, and to throughput intensive applications that perform long continuous reads and then writes. So for in both ways it is useful. So now let's see what we are going to build on a high level. So in a EKS cluster, so we are going to create a deployment which is nothing but the MySQL deployment. So for this respective MySQL deployment, we are going to leverage the Elastic Block Store as the volume mounts inside this deployment, which means for this MySQL database, we are going to use data volume mounts as from Elastic Block Store. So in addition to that, as part of this deployment, whenever we are creating, right, so we need to learn few other Kubernetes concepts here. One is storage classes, persistent volume claims, config maps, environmental variables, volumes, and then volume mounts. So all these things we are going to learn as part of this entire use case. In addition to that, so unlike earlier, which means like earlier we used to use a persistent volumes first, means like as a Kubernetes administrator, I used to create a storage class and a persistent volume, and then I need to go and then claim that volume using persistent volume claiming. So but now we are going to use the another latest feature, dynamic volume provisioning here. Okay, so that is going to come in, and then we'll discuss whenever it comes, we'll discuss in detail about that. But for now, let's move on with what we have. As part of that, as usual, again we are going to understand about node port service and then deployment of MySQL. So I also changed this to cluster IP service because this deployment is going to use MySQL deployment is going to use the cluster IP service. So moving on, so once we complete this, means like creating the storage class related Kubernetes manifest, persistent volume related manifest, and then config map related manifest, and deployment with environmental variables, volumes, and then volume mounts, and then cluster IP manifest. So once we complete 1, 2, 3, 4, 5 manifests, then we'll move on to the next thing, which is nothing but our user management service. So we have created a persistent database, but how we are going to know that? By integrating it with an application, we will know better, right? So that's the reason I have created a simple Spring Boot user management microservice. So wherein you will be able to create the users. Whenever a user is created, it will come and then store it in the MySQL database. And whenever you delete the user, it will be deleted from the MySQL database. Whenever you list the users, it will fetch the users from the MySQL database and then show it to you from your Postman client or from browser or whatever, right? So whatever the client we are using. So all those things we can do. So that type of application we are going to deploy here and then create a deployment for that. So which means we'll create a deployment with the respective environmental variables here, which is nothing but why do we need to have environmental variables in this deployment is nothing but these environmental variables will have the database information to connect to this respective database. So what is the DB host, and then what is the DB username, DB password, and what is the schema we are going to use. So all those things. So the schema, whatever we are going to create inside this MySQL database is user management schema, which we will define in this config map, and then that will get created. So we'll create a deployment with environmental variables to connect to this respective MySQL here. And in addition to that, we are also going to create a node port service to access the users, means like for access to users, we are going to create a node port service so we can access it via internet. So all these things we are going to do. So let's go back one more time to our GitHub repo and go to our EKS storage with EBS Elastic Block Store. Okay, so if you see here, we are going to use EBS CSI driver and use EBS volumes for persistent storage to MySQL database. So the core topics involved here are first installing the EBS CSI driver on our Kubernetes cluster, and then create the MySQL database deployment and then cluster IP service, and finally create the user management microservice deployment and then node port service. So as part of that, the following Kubernetes concepts are covered: storage classes, persistent volumes, config maps, environmental variables, and then node port services, environment variables, all these things. And in addition to that, after this entire section is completed, the entire EBS section is completed, all these things, and then if you still have doubts or if you want to implement few things, whatever is not referred in this section, again you can definitely go to these references and then look into. So why? Because we are using here only the dynamic volume provisioning here, but you can even do the static provisioning or even resize your disks, or there will be different options available here, and then you can use these reference links to understand better and then change whatever you want, or in your real world environments based on your requirements, whatever you want to do, you can use these things. Okay, so I'll see you in the next lecture by moving on with installing EBS CSI driver. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to install the EBS CSI driver on our Kubernetes cluster. So we are going to create an IAM policy for EBS and associate that IAM policy to our worker node IAM role. So and then install the EBS CSI driver. So once we create this role and then associate it to our EBS EC2 instances, means like EKS EC2 instances worker node IAM role. So which means like the pods inside the Kubernetes will be able to access that respective EBS services from the Kubernetes cluster. So let's go ahead and then do that now. So go to services IAM and then create a policy with following details. So let's copy this and then go to IAM service, right, and then go to policies and then create a policy, right, and go to JSON and remove existing and then add this and go to visual editor, and it will validate the entire policy here, and the following EC2 actions it is going to pick as part of this. Whatever the JSON we have copied, it has picked close to 12 actions from EC2 and review policy and provide the name of the policy, right? So the name of the policy we are going to say is Amazon EBS CSI driver, right? And even we can say that for EKS so that it looks good if we want. Okay, so EC2 instances access for EKS. Okay, so and then create a policy, right? So once the policy got created, get the IAM role worker nodes using and associate this policy to that role. So you can get your IAM roles on our EKS cluster using this command kubectl in the kube system namespace describe config map AWS auth. So we can get this way. The one way of getting it is this way. So let me go to terminals. So I didn't have my terminal open. So let's go here and open the terminal, right? Make it bigger. Okay, so and then let's paste this kubectl -n kube system, which is in kube system namespace, describe the config map AWS auth, and it should provide the role ARN. So this is the role ARN, so which means like we need to search for this in the IAM, and then under this we need to associate the policy whatever we have created, right? So we are here now and we can go to roles and then search for that policy. Okay, so I have copied this and I have copied from EKS-CTL here. Okay, so from here I have copied this and then searching here, and then I got the policy role here. Okay, so inside this role we can attach the policy, right? Attach, and I can say Amazon EBS CSI driver. So this one we are going to attach to our worker node IAM role. So the other way of finding the role is, so we can go to EC2, right? And in EC2, if you see here, we'll have the running instances, and in that we'll have our T3 medium related EKS cluster related instances. If you see, these are related to EKS demo cluster, right? So now I can go here and then I'll find the IAM role here. Okay, so you can see, right, IAM role. So I can click on this directly and then associate if I want to, right? So if you see, already it is associated. Just now we have associated. So this value and this value should be absolutely same, right? So 1K8 and 1K8. Okay, so in both ways we can go ahead and then identify our IAM role, right? So now we have provided the equivalent permissions for our EC2 instances present in the EKS cluster. Now we can go ahead and then deploy the EBS CSI driver. So we should be 1.14 or later. So let's verify our version. So we are at 1.16.6 beta. So good. Okay, so now we are going to deploy the Amazon EBS CSI driver, right? So I'll copy this entire thing and then paste it. So it will reference to the Kubernetes special interest groups AWS EBS CSI driver GitHub repo. Okay, so I am deploying it. Okay, so whatever is the latest as on today, it is going to deploy that version. So it will take a while. So it is creating the cluster roles, daemon sets, all whatever is required, it has created. So what we can do is, so I can say get pods -n cube system. Okay, so this should be created in cube system. So let's cross check. Okay, so you can see it has created the EBS CSI controller and then EBS CSI nodes here. Okay, so I'll also add this there. Okay, so in our document. Okay, so it has created and then it is up and running. So in our next lecture we'll focus on the next concept. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Welcome back. In this lecture, we are going to create the MySQL related Kubernetes manifests which are required for us, and then we are going to build them using live template writing, and then we are going to deploy and then see that how the MySQL is going to come up with the persistent storage using Elastic Block Store, which is EBS service in AWS. So let's go to 0402 SCPVC, which is nothing but storage class, persistent volume claim, config maps, and then MySQL deployment and then service. So we are going to create 5 manifests here. So we'll start with our step 1. So if you see here, we are going to create the storage class manifest, persistent volume claim, user management config map, MySQL deployment, and then MySQL cluster IP service. So let's start with the first one, which is our create storage class manifest. Okay, so let's go back to our Visual Studio Code here, and I have created the empty files here and then put them ready for our development of live template writing. Okay, so we are in the 01 storage class. So as usual, we are going to create our basic template first, which is nothing but API version, kind, metadata, and next is spec, right? So now let's start with the API kind. Kind is nothing but we are going to create a storage class. Okay, and next is API version. So for storage class, the API version is going to look like this. Okay, storage.k8s.io/v1. So let's see in our API specification document too. So we can see it here now, storage.k8s.io/v1. So that's what we have implemented it for our storage class. And now the metadata we are going to give as tab and then name, and then I'm going to say EBS storage class. Okay, and now when coming to the storage class, it is not going to be spec here, so it is going to be the provisioner. Okay, so who is going to be the provisioner? My provisioner is going to be, if it is Azure disk or if it is GCE persistent disk, then the provisioner is going to differ. And now we are going to use it in AWS, so it is going to be ebs.csi.aws.com, right? So, and now one more important thing here we need to work on is volume binding mode. So this can be immediate or wait for first consumer, right? So let me save this and then see what is this wait for first consumer. So let's come back here, and if you see here, this wait for first consumer mode will delay the volume binding and provisioning of the persistent volume until a pod using the persistent volume claim is created. So what happens is, like, whenever the storage class you created, and then whenever you create your persistent volume claim, so if you don't add this volume binding mode to wait for first customer, then it is going to immediately dynamically provision and then mount your volume. So means like it is going to provision your volume there. So in which availability zone we really don't know. It is dynamic, right? So it can be in availability zone 1 or means like US East 1A or US East 1B, we really don't know. And whenever you go ahead and then later you go and then create the pod, what happens is, like, if your volume is mounted in US East 1A and your pod got scheduled or created in US East 1B, then you have the issue, right? So considering all those things, there is a new option provided here, wait for first consumer. So what happens in this case is, like, whenever you create the pod, at that time only it will provision the equivalent volume for you. So what happens at that time is both will get created in the same topology, which is nothing but in the same availability zone. So that is one key important thing. So that's the reason whenever we are using in our AWS here, we can use wait for first consumer. Anyway, even though using EBS with MySQL databases here on Kubernetes, it will have equivalent setbacks and then drawbacks. We'll see in our later lectures those things, and then already a next lecture is planned in detail for this, like to avoid these EBS related issues. So then how we are going to use the RDS database in Kubernetes cluster, all those things already planned. But for now, let's go ahead and then start writing our template related to config map and then persistent volume claim. So we just now completed the storage class related manifest. Okay, so in our next step, we are going to create the persistent volume claim related manifest. So I am not going to go for everything to API version. We are not going to go to refer the API reference doc every time. So you can refer whenever you have time there. But for now, we'll go with the standard stuff here. Okay, so this is the standard API version, kind, and then metadata and then spec. And now what we are creating is persistent volume claim, right? And its version is going to be v1, and then in metadata our standard thing is to create a name, right? So I'm going to say EBS MySQL PV claim, right? And in spec we'll have three things on a very high level, that is access modes, and next is storage class name. This respective persistent volume claim need to refer, right? And next is resources, how much you want to reserve the space, means like how much you want to take the space for your respective mount point of your MySQL database example, right? So your volume mount, how much you want to take. So let's start with access modes. So we want read, write once, okay? And the storage class name, whatever we created here, is EBS SC, right? EBS storage class. So I'm going to give that. And resources, in that we are going to request how much, okay? So we are going to request the storage, and the storage is going to be 4 gigabytes, okay? 4 GI, okay? So that's all. Now we have completed the persistent volume claim related Kubernetes manifest, okay? So we'll also complete user management config map manifest, and then we'll go to the next one, okay? So we are going to create a config map manifest which will be mounted in our MySQL deployment, so that whenever the MySQL pod got created, automatically it also need to create one small schema named user mgmt schema. So that we will use for our user management microservice deployment. So whenever the user management microservice is deployed, it expects that there is a user mgmt schema present in your respective database. So for that purpose, we introduced the config map concept here. Means like, why config map is like, whatever you want to do, whatever the configuration you want to send to your pods, right? In whatever the way, you can define it as a config map and then mount it in your container. So we are going to container definition, which is nothing but our deployment. So we are going to do that so that we'll know the use of config map, how we are going to use it. So standard API version, kind, metadata, and here it is not spec, it is going to be data. Okay, so and what we are going to create, config map, and the version is going to be v1, and the metadata, and here I'm going to write the name. It is going to be user management -db creation script. Okay, so in data I'm going to create a mysql underscore user mgmt.sql script. Okay, so and I'm going to write the content of my SQL script. Okay, so I'm going to say drop database if exists. Okay, and database name is user mgmt. Okay, and then create database user mgmt. So we can give small or big, whatever it is. Okay, so create database user mgmt. So this is about creation of our config map. How we are going to mount it in our MySQL deployment file, we are going to see in our next steps. Okay, but for now, one thing we need to understand here is, let's save it and go back here. So these are few steps to execute here in persistent volume claims manifest. That is nothing but, let's create storage class and PVC and then list them and then see how it is going to look like. We discussed about wait for first consumer, right? So what happens, we are going to see here now. So let's go here and go to, what is this section? Section is 04, right? So let's go to 04, and in 04 we'll have something called kube manifest. We need to go to 0402, right? Inside that you will find kube manifest, right? We have that. Okay, so I'm going to say kubectl apply -f kube manifest. So it need to create three things for us. Okay, so storage class, persistent volume claim, and its equivalent db creation script related config map. So I'll say kubectl get sc, which is nothing but the storage class. Okay, and I have got my ebs_csi aws.com, which is the ebs_sc got created. So now I'll say get pvc, which is nothing but persistent volume claim. Now you can see, right, it is waiting for the first consumer. You can see the status is waiting, so it is not already allocated or volume already binded. Okay, so if you want get pv, nothing. So persistent volume still not yet created. Volume claim is waiting to create the volume. Until and unless the pod got created, it is not going to create it. Okay, it is not going to bind the volume and then create the persistent volume. So let's wait for it. Okay, so now we have completed these things. So let's, if we want, we can even delete it or we can leave it as is. Okay, that's not a big deal. Okay, so in our next lecture we are going to focus on creating the MySQL deployment and then MySQL cluster IP service, and then we'll move on with creating those deployment service, all these manifests, and then testing it. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Back. In this lecture, we are going to create the MySQL deployment manifest. As part of that, we are going to create environmental variables related to, or MySQL deployment related to root, password, and all those stuff. And we are going to create the volume mounts and then also create the volumes for our container, right? In addition to that, we are also going to create MySQL cluster IP service manifest. So let's go ahead and then do that now. So let's go to our Visual Studio Code and we will start with our MySQL deployment. So as usual, we'll start with API version and then kind, metadata, and spec, right? And now our kind is nothing but we are going to use deployment, and its version is apps/v1, and we are going to say metadata, we are going to say the name as we are going to create a MySQL deployment. So I'll just say MySQL, and under spec we'll have 3 top level objects. Okay, so ideally we'll have something called replicas, and we'll have selector in general, and then template, which is nothing but our pod template, whatever we are going to write. But here we are also going to have one more extra, which is nothing but, if we want, we can define usually strategy. Okay, so our strategy type is going to be rolling update or recreate. Okay, so we are going to say recreate. It's a database, right? So whenever this pod terminates, again recreate that pod. Okay, so that's what we are saying. It will always be only one replica, this database, and we really don't need to have any rolling updates or those stuff. Okay, and the selector, we know that we'll have something called match labels under that. So let's define our match label is app is equal to MySQL. Okay, so the same thing we need to define for our container related template metadata labels also. Okay, so now under template, again we are going to have 2 things, right? So one is metadata of your pod, and second is spec. Okay, so now under metadata you are going to define, if ideally we really don't need to define the name of our pod here because it is part of the deployment, right? So if we define labels, that will be sufficient. Okay, and it should be same as our respective match labels, whatever we defined here, app is equal to MySQL. So now under the spec we'll have the child elements, one is containers and the other is volumes. Okay, so 2 things. Earlier we used to have only containers in our previous whatever in our Kubernetes fundamentals are everywhere. So now we are introducing the concept of volumes, so we are going to also add volumes here. Okay, so now in the pod template spec we have created, we are going to add containers and then volumes. So let's start with the containers now. So under containers we are going to have a name of my container, okay, and the image name, right? And so name of my container is MySQL, and I'm going to use the MySQL 5.6 container image. Okay, and now container is done. So something I need to provide for MySQL container is environmental variables. Okay, so I'm going to define those things. Okay, so that is going to be, what are those things? Okay, MySQL underscore root underscore password, and its value is going to be db password 11. So we are going to use db password 11, right? So for the container, one more thing important is, right, ports. So let's define the ports, right? So I'll say container port is equal to 3306, and name of this port I can say MySQL port, right? So that's the thing. So for now we'll leave it here, and then we'll under containers, for this container we have the environmental variable and all those stuff defined. So now if you see here, you can find a little bit of mistake here, you can see, right? So under containers you have a container name MySQL and the image. So this env and then ports also part of this container, right? Name MySQL. So we need to do this way. So now if you see, name, image, env, ports all are under single line now. You can see that, right? So that's good. So now the next thing is volumes. Okay, so these are again one more top level, right? Under spec, one is containers, another is volumes. So we are going to define 2 volumes here. Okay, so now let's start with the first volume. Okay, so and the name of the volume is MySQL persistent storage, and here we are going to mount persistent volume claim, and claim name I am going to provide is EBS MySQL PV claim. So whatever we have created here, right? EBS MySQL PV claim. The same thing it should be here. Okay. So now what happened is we have mounted for our respective container one volume which is MySQL persistent storage with name, and we are mounting the persistent volume claim named EBS MySQL PV claim. So one more we need to map, which is nothing but our config map, user management DB creation script. We are going to map it. Okay. So user, so we can go here and then get that name. So it's a big name. So let's copy it here and then come back. Where is this? Here, right? And paste the name here. Okay. And now we are going to have something called, it is of type config map, right? And what is the name of the config map? It is going to be the same thing whatever we have copied just now. Okay. And I'll say script. Good. So now we have mounted the volumes also. So now these volumes we are going to use as volume mounts inside our container, right? So these are the volumes available for us which we need to mount in our respective container named MySQL. Okay. So let's go ahead and then mount those volumes in our container. So for that purpose, equivalent, like how name, image, env ports, at the same level you need to write something called volume mounts. Okay. So now you can define here name of the mount and the mount path. Okay. So now name of the mount is MySQL persistent storage. So I can give the same name here, right? And mount path I am going to use is var lib MySQL. Okay. So which is nothing but the storage of MySQL will be present in varlab MySQL. So we are mounting that folder to our container, MySQL container. So one more we'll have. So again, name and then mount path. Okay. And we are going to mount the user management DB creation script. Okay. And when you want to mount it, during the docker entry point initiation db.d. Okay. So we'll see what it is shortly. Okay. So docker entry point init db.d. So let's come back. What does docker entry point init db do? So when a container is started for the first time, a new database with the specified name will be created and initialized with the provided configuration variables. So we are going to create user mgmt database there, and using the .sql MySQL DB script .sql. Okay. So whenever the container starts for the first time, so it is going to create that. So that's what we have created it in our config map. The drop if any database exists, and then create the database user mgmt and then mount it. Okay. So mount it here, so that, and then use the docker entry point init db here. Whenever you mount, then the mount path you are going to use docker entry point init db, so that it is going to run this script whenever the first time the container is going to start. So it will run this MySQL user management.sql script. So that's about it. So now we are going to go ahead and then create our cluster IP service now. So we have completed the deployment part, which is nothing but the MySQL deployment we have completed. If you want, we can see one more time. So we have created the base template here, and then after that we, under the spec, we have something called replicas, selector, strategy, and then template. So template is pod template. Strategy is, as it is database, it need to recreate. There is no rolling or another strategies applied. Standard recreate type we are going to apply. And selector is going to be under match labels app MySQL, and replica always it is going to be one pod. So it is one. And now under the pod template, as usual, metadata and spec will be available. And metadata, we have defined our pod label as app is equal to MySQL. And under spec, we'll have two things here, containers and then volumes. So we have created two volumes. One is for the persistent storage, mapping it with our EBS MySQL PV claim, whatever we have created. And the second is user management DB creation script. That is nothing but the config map. We have mapped those two volumes. And then these two volumes will be mapped to our respective pod, and from pod we are going to mount it to our container which is nothing but our volume mounts here. And in the volume mount, we are going to create a mount for MySQL persistent storage under the mount point var lib MySQL, which is nothing but the core MySQL database storage data files path. And the another is user management DB creation script under the mount path docker entry point initdb, which is nothing but whenever our container is going to start for the first time, so whatever is present in the config map, it is going to run. So that's about the MySQL deployment. In our next step, we are going to create the cluster IP service. So let's go ahead and then create the first time, which is nothing but v1, and the kind is equal to service, and I'm going to say metadata, and I'm going to say name, which is going to be MySQL. Okay, so and next is going to be spec, and it is a service, so and it is a cluster IP service whatever we are going to create. So we are going to have selector and then ports usually. Okay, so and I'm going to give the port as 3306. Okay, and the selector is going to be app is equal to MySQL, which means whatever the traffic comes to this service, it need to route to the pod whose selector, whose label matches with app is equal to MySQL. Now another thing important here is we already know that MySQL deployment is going to be always only one pod. So which is nothing but this is the only one pod. So we are not going to scale it, or we are not going to have multiple replicas. If we know that is going to happen, so we can do one more setting in our service, which is nothing but cluster IP is equal to none. What does this mean? This means, okay, so we are going to use pod IP directly. Okay, so we really don't need to allocate a separate IP address in our network for this respective cluster IP service MySQL. We can leverage directly using the pod IP whenever you say cluster IP is none. So that's about the entire spec creation, whatever we have created for MySQL deployment and then MySQL service. So this completes the step 2, which is nothing but creating of our entire manifest. Okay, storage class, persistent volume claim, user management config map, MySQL deployment, and then MySQL cluster IP service. Okay, so in our next lecture, we are going to create these things and then test these things, connect to that MySQL database, and then test it end to end. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, we are going to create MySQL database with all above manifest whatever we have created, right? So we are going to create it and then verify the storage class PVC, PV pods, and then also list the pods and then connect to our respective MySQL database and then see the schemas. Okay, so let's go ahead and then do that now. So we are in our respective folder, which is nothing but 0402 SCPVC config map MySQL. Okay, so kubectl apply -f kube manifest. So whatever the manifest under that, it is going to create it. If any issues, it is going to throw the error and then we are going to know about it. So we know that under the cluster IP service, we have a validation error. I didn't provide cluster means CLUSTR. I didn't provide the T here. Okay, so let's go there and then fix that. Okay, so cluster IP, right? So that's good. So now let's try one more time. So it should get created and the service also got created. So now if you see the get PVC persistent volume claim, so now it is bound, you can see, right? So earlier it is in pending state whenever we have directly created them and then no MySQL pod got created. So now we'll see PV, which is nothing but persistent volume, got created and then it's in use. Okay, it's bound. Okay, so this is the persistent volume, it got created. So now let's go back and then see the pods, right? So our MySQL pod is running. Okay, so that's about it. So if you want to find it with the respective label, means like app is equal to MySQL, so you can do like this. Okay, -l app is equal to MySQL. Even you can list using MySQL pods. That's all. Okay, so how to use labels? This is a just simple command. So now we'll move on to connect to this MySQL and then see what happens. Okay, so let's use the command kubectl run and then use the interactive terminal IT and then delete this pod whenever it has been exited, and then we are going to use image, right? MySQL 5.6 for our client also, restart never, and then MySQL client, and then MySQL -host is MySQL only. Why? Because whatever is running is a MySQL service only, right? And the password is db password 11 for our root password. Okay, so let's run this and then see what happens. Okay, so right, so we should get the MySQL terminal ideally. So let's see. It is taking little bit of time. If you don't, yeah, we got it. Okay, so now if I say show schemas, so I should have, in addition to default schemas, user mgmt schema. So it got created. So whatever we have defined in our config map under data, the mysql underscore user mgmt.sql got executed, and it also created the user mgmt schema. So with this, we have completed the creation of our entire section, which is creating a storage class, creating a persistent volume claim, and then using the dynamic provisioning. And we have created the config map, and then we have also created the deployment for MySQL and also the cluster IP service for MySQL. Okay, so if you want to see, we can even see. So I can exit from this. So I'll say quit, and my container, my pod got terminated. Okay, MySQL client pod got terminated. So good. So if I say kubectl get pods, and I should have only one pod now. Yeah, and then I should see SVC, which is our cluster IP service. So that's good. Okay, so now this is about the entire stuff. In our next lecture, we'll discuss little bit about the references section, and then we'll close this entire 0402 section, and then we'll move on to user management service. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture, we are going to discuss about the references section exclusively, mainly related to EBS CSI driver. So I have provided all the links for you for your additional understanding, and then more about the features available there and all those things. So this is the core link about our EBS CSI driver. So we can go in there, and this is the dynamic provisioning, whatever we have implemented, and more examples are provided here for additional stuff here. So let's go here. Okay, so this is the EBS CSI driver, and if you see the current version it is running is v050, and whenever you are testing it might be even 1.0 or whatever, right? But whatever it may be the case, so the core thing here we need to understand is here. Okay, so whatever the features it provides: static provisioning, dynamic provisioning, mount option, NVMe, block volume, volume snapshot, and then volume resizing. And important things when we are seeing the features is alpha state. Okay, so volume resizing and volume snapshot are in alpha state, and they are sometimes working, sometimes not working. They are unstable as on today. So that's the reason I didn't include these things. Okay, so block volume is in beta stage, and this dynamic provisioning, these are also in beta stage, but the thing is they are ready for production. That's what AWS says, so we can use these things happily. But the core thing is, whatever you see alpha stages, you cross check before you are using for your things. Means like when you want to use resizing, you need to say allow expansion true in your storage class. Okay, I didn't define that here. Allow expansion true, you need to define an additional tag here. Okay, so but as it is in alpha state, it is not good to add that and then demonstrate it. Okay, so it might change the why? Because once it comes to beta, the changes will be minimal, but if it is in alpha, the tag might change or whatever it is. Okay, so that's about it. Don't worry about installation steps, whatever here provided. So you need to you follow the steps whatever I have provided here, which is straight and then easy. And now next thing here is one more thing is this is the one examples for EBS CSI driver. So we have implemented dynamic provisioning with our MySQL, and we have for block volume and then for resizing. So if you see the resizing, allow, I told you, right, allow volume expansion true. So like this you can provide all these things, but whatever you want to provide, and then based on your requirement what you want to use, accordingly you can refer these examples. Means like you can go inside these examples and then go inside this spec and then find the example.yaml or whatever, and then find the options related to your storage class and then persistent volume accordingly, and then leverage and then use it whenever you are doing in your real-time environments based on the requirement whatever you have. Okay, so that's about the references section here. Okay, So dynamic provision, direct link I have provided, and resizing, snapshots, everything you can see here, all the examples here. Okay. So in our next lecture, we'll focus on creating the user management microservice, which is connecting to the MySQL database we have created. We'll create some users and then reference them in the database and list those users and everything. And then again, we'll clean up everything. So that's about it. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to create the deployment for our user management microservice, and also we are going to create the user management node port service related Kubernetes manifest, and then also provide the environmental variables required for this application to connect to the MySQL deployment, whatever we have created earlier, right? So let's go ahead and then do that now. So let's go to our GitHub repo and we'll go to 0403 user management microservice with MySQL DB. So we are going to create two YAML file manifests. So microservice deployment and then also node port service. So as part of that, we are supposed to provide the following environmental variables to our respective container, which is nothing but the user management service container. So let's go ahead and then do that now. So now if you see here 0403 user management microservice, and inside that kube manifest, so whatever I have created, the 5 things, whatever as part of 0402 storage class and then persistent volume, claim, config map, and then MySQL deployment. So all those 5 I have copied back here, whatever we have created in our previous lectures. Okay. So now we need to create 06 and then 07 microservice deployment and then microservice node port service. So if you see the base template related to our Kubernetes, which is API version, kind, metadata, and then spec also, I have put it here. So what we need to do? So now we are creating the user management microservice deployment. So the kind is going to be deployment, and for deployments, the API version is going to be app/v1, and for metadata, we can say it is going to be name, right? So user mgmt microservice, and we can also give labels if you want to, and I'm going to give the label as app:/space user ngmt rest app, or even microservice, whatever you want to give. So now we are in the spec part, and under spec we'll have 3 core child elements for a deployment. So one is replicas, and second is selector, and third is going to be pod template. So now replicas, we can start with 1 replica, so that's not an issue. And selector means in deployment we'll have something called match labels. Okay. So and whatever we are going to give here is app and then user mgmt rest app. As usual, whatever is present in match labels, pod template labels also, we need to have the same value. Okay. So under template means like this is nothing but this is the pod template, and under pod template we are going to have 2 core things. Okay. So child elements. Okay. Metadata, and one more is going to be spec, which is nothing but pod specification. Okay. So and under metadata we are going to have labels only. Name, ideally we are a part of deployment, we really don't need to give pod name here. Okay. And the label we are going to give the same thing, whatever is present here. Okay. So good. So still here we are good. Under template we have 2 child objects, metadata completed. Now we are writing the spec. So under spec we'll have something called containers, and then if we have any volumes to be mounted to this pod, then we can have volume. But currently we don't have anything, so we have only containers, right? So containers is a list, and then you can have 1 container under this, which is name, and then user mgmt rest app, and it's image, right? Container image you are going to provide, right? So we'll provide that shortly. And next is going to be container ports, right? So let's define the ports here, and I'll say container port 8095 is my application port for user management microservice. So means like which is my container port, whatever I have defined in my application whenever I built the container, it is 8095. So I am providing it. So if you want to give the name of the port also, you can give with the tag name if you want to. Okay. So I am leaving it. Okay. So all those are minor things. So I am leaving it. So we have completed name, image, and then ports. So the next thing is going to be the env, right? So let's complete the environmental variables. So under environmental variables, we provide it as key value pairs, right? So and environmental variables are also a list, okay? So we can have name and then value like this, okay? So we are going to provide db hostname, db port, db name, db username, and then db password. So 5 things, okay? So we need to have 5 things like this, okay? So let me copy paste and 2, 3, 4, 5, okay? So now let's start with the db underscore hostname, okay? My db underscore hostname is going to be MySQL, okay? So that is what is my thing, whatever we are defined here, right? So and the next is db underscore port, right? And the value of db underscore port is going to be 3306. Put these in double quotes and ensure that we have the db name, so which is nothing but our application, means like user management application to which schema in our database, MySQL database, it is going to connect to. So we have created a schema named user mgmt schema, so we can use that. And the next is db underscore user name, right? So we have going to use root user, and root user password also with MySQL underscore root underscore password, we have defined it as db password 11. So let's define the variable db password, and I'm going to provide it as, so let's also provide the db password. So whatever we have given in our MySQL deployment here, which is nothing but MySQL underscore root underscore password, the same thing, let's provide it here, right? So which is nothing but db password 11, okay? Now let's also update the image name here. So let's go to our Docker Hub, and if you see in the repositories, you'll find something called kube user management microservice, okay? So inside that you'll have 3 tags. One is 1.0.0, 2.0.0 h2db, and then 3.0.0 x-ray. So whatever you find 1.0.0 is going to be the user management microservice connecting to the MySQL DB. So you can take this tag completely, user cube user stack simplify cube user management microservice : 1.0.0, which is nothing but this one. So usually I have also in the readme updated that this needs the following environmental variables passed to our respective container, right? So now let me copy this and come back and then add it here, okay? So now this completes our microservice deployment creation. We'll move on to our user management node port service, whatever we want to create. So let's start with the kind is service, and the API version is v1, and the name of, means like under metadata will have usually 2 child items, name and then labels primarily, and in future if you want to use namespaces, you will have the namespace item, but we are not using anything like that for now. We are going to go to the default namespace, so we leave it like this, okay? And user mgmt hyphen rest app hyphen service will be my service name, and under labels I'm going to give it as user mgmt app rest app, okay? So now the next thing is under spec. So we'll have 3 things usually under a service, which is under spec child elements, primarily important ones. So selector and ports, okay? So type, selector and ports. So as we are going to create a node port service to access this user management application via internet, so we are going to create it as node port. And next is selector. So selector is nothing but whatever is present in the pod template label, which is nothing but, so in the pod template label, whatever is the label, so we need to provide the same thing here, so that what happens is whatever the traffic comes to this service, it will be able to send to that pod based on this label. Means like it can select that pod based on this label, whatever we provided. And we'll have 3 types of ports. So one is we have provided the ports, and under that one port will be our service port. Port is nothing but service port, and our container port, so we can give it as 8095, same thing, and we can even define our node port whatever we want. So now again we can say it as 31231, okay? So this completes the creation of user management node port service also. So we have created deployment, and then service. So in our next lecture, we are going to test these things and then understand how it is going to behave. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to create the user management service deployment and then node port service. So as part of that, we are going to create all the things one more time. If you see here, so whatever we have created earlier, which is nothing but kubectl get all, so the storage class and then persistent volume claim and already deployment of MySQL and then MySQL cluster IP service, everything I have deleted. So there is a reason for it. So let's go ahead and then observe why we have deleted. So whenever you are executing this kubectl command, so which is apply -kube manifest, you should be in those respective folder for that section. So we are in 0403 user management microservices with MySQL DB, right? So inside kube manifest, you will have all the 5 things now. Okay, so 01, 02, 03, 04, 05, 06 and then 07. All these 7 things, templates, whatever is there, all are available. So let's come out of kube manifest and then say kubectl apply -f kube manifest. Okay, so it is going to create all this stuff now for us, okay, which is nothing but storage class, persistent volume claim, config map, deployment service for MySQL and deployment service for our user management service. So let's see the pods now. Okay, so now container is creating, but already user management microservice container already got created. So if you see logs -f, so what happens is before MySQL got created, user management microservice got created. So but it will fail because MySQL is not ready. It will restart the pod. So you can see it now here, okay, because it's MySQL is not available. It will restart once, and after that again in the next restart, if it finds the pod, then it is going to MySQL pod, then it is going to connect to that MySQL. Okay, so now let's see what happens. Okay, see now it is user management microservices up and running. So it has restarted the container for the fact that for the first time MySQL is not ready. So to identify this type of issues, I have deleted everything and then whatever we have done during the MySQL section and then recreated now. So how to solve this? Okay, so which means our application container should not start before the MySQL container starts. So how to do this in our next section we are going to look into. But for now, our application is up and running, which is user management, and also our MySQL pod is up and running, right? So if these two are up and running, what is our current job is to get the node port and the node IP address, right? So 31231, whatever we have given directly in our service, so we'll get that, and we'll also get the node public IP address and take that and then access it and then test it on the browser. So this is the external IP. So we will use this IP, any one of the IP we can use it. So let's go here, right? So http://IP:, and then 31231 is our node port, and the context should be user mgmt/health status page for our microservice application. The same thing will be present for you in our documentation also here. So if you see here, this is the one, EKS worker node public IP, 31231 is the port, and user mgmt/health status. Okay, so this tells that our microservice application is just up and running. So let's access this and then see what happens. Okay, so if I make it bigger, user management service is up and running and the version is v1. So you can very clearly see that our REST application is up and running, or our microservice application is up and running. So in addition to that, if you want to see kubectl get storage class, persistent volume claim, and also persistent volume, you can even see those things now. So storage class EBS CSI AWS is provisioned, and its volume claim also bounded to the volume, and this is the volume with 4 GB capacity. Okay, so which is here, right? Default EBS MySQL PV claim. So that's about it. So now in our next lecture, we are going to focus on test the REST services present in this user management application using Postman. Okay, so I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to test our user management microservice using the Postman. So we are going to download the Postman client and then install it using this link, and then import the Postman project AWS EKS Masterclass microservices _ Postman collection.json present here. so which is nothing but this one, and then just import that to our Postman client and then create the environment required for that, which is nothing but with our respective public IP and then port, node port, whatever is there, create the environment so that the URLs present inside that are going to get replaced, and then test all the services like create user, list user, update user, delete user services. Okay, so let's go back to our Postman client. So if you see here in the import, right, so once you download and install your Postman client using the import, so you can copy that respective file, whatever you have, which is present here, whatever I have shown you, right? So this one, you can, this JSON file you can import. So once imported, it creates like this, which is nothing but, so this is the collection name and this is the user management microservice. Okay, so inside this, the first thing is user management health status, right? So before doing that, what we said is we are going to create the environment for that, which is nothing but using our worker node public IP and then port. So we need to go to settings here in the right corner, click on that, so that we'll be able to create the environment. So the environment name, so whatever we have provided here, whatever you want, you can provide your design name. I am saying UMS means user management service node port. Okay, and the variable I have given here is URL. Okay, and what is my initial value and then current value, it is going to be the same, so which is nothing but this one. Okay, so whatever the node public IP, right, and 31231. So let me copy it and then paste it. Okay, so no slash at the end, you can see, right? So http:// public IP of worker node : 31231. So it is the same thing here, automatically replaced. So let me click on add, right? So I have the UMS node port. So let me close it here. And in the environment, this is no environment. If I test, so it will not go anywhere, could not send request. Okay, so let's select the environment UMS node port and test our health status, whatever we have tested here. So this is the same health status. Okay, here it is working, so here also it should work. Okay, so you can see that user management microservice up and running. So this request sent to our respective container present in our Kubernetes pod or on our cluster, right? So now let's go ahead and then create the user management create user. So this user, whatever you are creating, should be present in our MySQL database, whatever we created here. Okay, so kubectl get pods. Okay, so whatever the user you are creating via user management service should be present in this MySQL. We are going to test that later. Okay, so now let me go ahead and then create that. So if you see here in the body, you can see username is admin1, email, role, enabled, true, first name, last name, and then password. These are the things we are going to post. So let me say send. So it will post to this environment and then user should be created. Okay, so you can ignore this 500 internal server error. So this is coming because of some message you are seeing here, right? User will be created, but you will get this error because it's underlying one more microservice, which is nothing but notification microservice is not up and running. We just deployed the user management microservice. So how I have written the code is create the user and send the notification to the user, whoever we provide the email here. Okay, so what it is sending is it is not able to post the data to notification/send, which is nothing but the notification service under 8096 port to send the notification and then do that, because notification service we really didn't deploy, so it is not going to work. But user will get created, you really don't need to worry. So that you can verify using the list users service. Okay, so user management / user, so that is the list user service. So we created user, now list user service we are testing. Okay, so now you see that user got created, which is admin1 and then all these details. So if you want to update the user, so currently user has fname1 and then lname1. So if you want to update the same user, so with fname2 and then lname2, so you can just update it. Okay, and then send it so that changes got reflected. So now let's go and then list the user one more time. So you can see that fname2 and then lname2 got updated. So if you want, you can go and then update the same things the way it is required. Okay, so now these changes are done. If you want to delete the user, so my username is admin1, right? So if you see here, so my username here is admin1. Okay, so using the username admin1, earlier it is 2, just replace it with 1. So user/admin1 and then delete it. Okay, so now user should be deleted. So if I go and then list the users one more time, no user is present. Okay, so now let me go back and then create the user one more time. So now the user got created. List the user one more time, and user is there. So, and if you want, we can create one more user. So I'll say admin 2 and Kalyan 2, and just I'm giving some 2 users. Okay, so and then save and then send. Okay, so I've sent one more user I have created. If I say list all users, I have 2 users now, admin 1 and then admin 2. So what I'm going to do with these 2 users is we are going to go to the next step. So we have tested all these services, delete user also. So we are going to verify these users in our MySQL database by connecting to our MySQL database. Earlier also we have run this MySQL database command using kubectl run. So it is going to download the MySQL 5.6, whatever is our main container image. In the same way for the client also, it is going to download the same 5.6 container, and from that container it is going to connect to the MySQL host, which is nothing but our MySQL deployment, whatever we have done. And then it is going to take us to the MySQL prompt. So there we are going to run these commands. So let me copy this and I will run this. Okay, so now it will take a little bit. Yeah, so okay, so it should run now. So we are in the MySQL prompt. So first thing is show schemas, so which is nothing but what all databases available. Okay, so now I need to connect to user mgmt schema. So I will say use user mgmt, right? So I connected to that schema, right? So now I will say show tables in that schema. Okay, so now I see users table is created. Okay, so I'll say select star from users. Okay, now if you see that I have admin 1 and then admin 2 records got created in this database. Okay, so now let's come back here to Postman and then delete the user. So admin 1 if you want to delete, or admin 2 I will delete. Okay, so deleted the admin 2 user, and then if I say list all users, I have only admin 1 user. So let's execute the same select star from users. So you see only one admin 1 is there. So now you can see end to end that whatever the user you have created already present in our EBS volume, which is nothing but the persistent storage, right? So that's about it. I'm going to quit this. As soon as I quit it, the MySQL client related container is going to get terminated. That respective pod is going to get terminated. Okay, so this completes the creation of users and then deletion using Postman. Okay, so and one more thing we are going to do is we are going to delete all the objects now. So which is nothing but kubectl delete -f kube manifest. Whatever is there present inside this kube manifest, all those files will be executed, and then those files, whatever the objects created as part of that, going to get deleted. Okay, so let me clear this and kubectl get pods. So one more time I'm repeating whatever the thing. So earlier we have this issue, right? So one time our application got restarted because MySQL is not up by that time. In our next lecture we are going to discuss about init containers to fix that type of issues. Okay, so no restarts will happen about our application. Our application should wait till the MySQL container is up. For that we'll implement the initialization containers concept. Okay, but for now let's go ahead and then delete this. About this concept also I have written a little bit here. If you want, you can review the problem observation, what we have observed, and then how we are going to fix it is using init containers in our next section. Okay, so I'll say kubectl delete -f kube manifest. Okay, so all my storage classes, persistent volumes, everything whatever it has created will get deleted. Okay, and once it is deleted, so we can say kubectl get pods and mostly nothing is there, right? Kubectl get storage class pv comma pvc, all those things. Okay, let's see what is present here. Okay, so nothing, the default storage class other than related to Kubernetes, but rest all nothing, we can see it here. Okay, so if you want, you can even type kubectl get all and then verify the same thing, right? So this completes the section 4 related to EKS storage with EBS block store. Okay, so in 05 section we'll focus on few of the important concepts related to Kubernetes. So liveness probes, and then requests, and then limits, and then initialization containers. Okay, readiness probes, those things. And in 06 we'll focus on, instead of MySQL DB, why we need to use RDS DB. Means like custom built MySQL DB present using EBS. Instead of that, as we are in cloud, why can't we leverage RDS database service? So we'll see that in our 06 section. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to learn few important Kubernetes concepts which are required for our application deployments on the Kubernetes clusters. Okay. So in our previous lectures, we have implemented all these things like a MySQL deployment where we have the MySQL database, and for that we have mounted the persistent storage of Elastic Block Store from AWS with all these Kubernetes concepts like storage classes, persistent volume claim, config maps, deployments, environmental variables, volumes, volume mounts, all these things. Okay. So now what we are going to do is, we have completed the underlying part here, but we also need to focus on our application we are deploying here, right? So first thing is secrets. So whatever the DB password, whatever we have provided for this application, why can't we send it in the encrypted format? Okay. So for that purpose, we are going to use secrets. The same we can apply for the MySQL root password environmental variable in deployment. So the next thing is initialization containers. So these are nothing but we have seen one issue related to before the MySQL container started, the application got started and then one more time it restarted. It didn't wait for the MySQL service to come up. So to ensure that MySQL container to come up and then start the application, we can implement initialization containers. So in addition to that, we can implement the liveness and then readiness probes of our application so that the traffic can be allowed to this respective pod only once the liveness and then readiness probes are successful. So those we need to implement for our application. In addition to that, we can even implement requests and limits for our application pods, which means how much CPU, how much memory in the Kubernetes cluster our respective application pod should be taking. We can request those things and then also put a hard limit for that using limits. In addition to that, so if we have multiple versions of our application, or if we want to deploy in the same EKS cluster, you have staging and then development and then QA environments. So you can even create namespaces separately for dev, QA, staging, and then deploy the same application and then same version inside those separate namespaces. Okay. So like this, you can use namespaces to differentiate your environments or in various regions, or even for namespaces like you can allocate for dev environment, my Kubernetes cluster, this much resources only should be allocated for this namespace, this much CPU and then this much memory. So all those things we can implement, and those are very important for the applications we are going to deploy on Kubernetes cluster. So these things we are going to implement now. So if you go here in 05, Kubernetes important concepts for application deployments. Okay. So we are going to look into Kubernetes secrets, initialization containers, liveness and readiness probes, and requests and limits, and then namespaces in 5 sections now. Okay. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Come back. So let's go ahead and then implement the Kubernetes secrets for our application and the database. Okay. So Kubernetes secrets let us store and manage sensitive information such as passwords or OAuth tokens or SSH keys in a base64 encoded format. So storing confidential information in a secret is a safer and more flexible way instead of putting them directly like DB password 11 or whatever in the application manifest, deployment manifest, or even the database related deployment manifest. Okay. So what we are going to do is we are going to create a secret for our MySQL DB password. Okay. So if you have base64 installed on your Mac machine or on your Linux machine, so my DB password is DB password 11. Okay. So you can directly run this here. Okay. And then get the secret and then update in your respective secrets file. So like this, or you can go to this URL base64encode.org and then provide your DB password 11 here in the encode to base64 format, and then click on encode, and then you will get the value. So both are going to be same anyway, but based on your, if you are using Windows and then you don't have base64 installed on your Windows machine, so you can use base64encode.org also. So now we'll go ahead and then create the Kubernetes secrets manifest. Okay, so if we go to this one, right, so our Visual Studio Code editor, so in 05 Kubernetes important concepts, you can see 0501 Kubernetes secrets. So there in our previous lecture, whatever we have created, which is nothing but in 0403, right? So all those manifests we have brought here, which is nothing but all the 7 manifests, whatever we have created, we have brought here, and then we are going to live edit them by creating the Kubernetes secrets file first. Okay, so as usual, so I have put the Kubernetes standard template here, which is nothing but API version, kind, metadata, and then spec. So the kind is going to be secret, and the API version is from core, it is v1, and now the metadata, the name of the secret here, right? So in metadata usually we will have name and then labels, right? So we'll give name, that will be sufficient for us. So I'm going to say MySQL DB password will be the name of my secret. Okay, and instead of spec, usually this will have something called data. Okay, so like how the config map we create with data, right? It is the same thing. In addition to that, there will be one more top level object called type, and type we need to provide opaque, because ours is a unstructured content, which means like key value pairs. So we'll show what is that key value pairs now. So opaque means Kubernetes point of view, the contents of the secret are going to be unstructured. Okay, so let's see what does that mean. Okay, so you can give, so under data, so you can give the key value pairs whatever you want. So I'm providing one key value pair here, and we can get whatever we have generated here. Okay, so this is the password, right? I'm saying DB password, and whatever we have generated for DB password 11, the base64 format I have pasted here. So if you have something, even if you want to encode DB username, you can provide, or if you want to DB host, if you want to put, so you can even put DB host. So like this, how many features, how many you want to put, that many you can put in key value pair. So that's the unstructured way of putting it. So that's the reason we have provided the type opaque. Okay, so now I have provided DB password with DB password 11, which is in base64 format. So now we have completed the Kubernetes secrets file creation here. Okay, so now let's go ahead and then update our MySQL deployment. In our MySQL deployment, if you see here in the environments, you have name is MySQL root password and the value is DB password 11. So instead of value directly taking it here, you can do one thing for this. Okay, so let's remove this and say that value from. Okay, so we are getting the value from secrets. Okay, and from where you are getting, it is getting from the secret key reference. Okay, so secret key ref is the tag here. Okay, so and you need to provide your 2 objects here. Okay, so 2 attributes. Okay, so name and the key, right? So from which secret it is going to bring the value? So from MySQL-DB-password, the name of your secret. So whatever you have provided here, the name of the secret. So this becomes the name and this becomes the key. So from which key it need to fetch is DB password key it need to fetch. So let's go to MySQL deployment and paste it here. That's all. Okay, so value from secret key reference and name is MySQL-DB-password and the key is DB password. So now the MySQL root password will be DB password 11 in this manner. So the same way we can implement the same for our user management microservice deployment. Okay, for this DB password. Okay, so as usual, one more time. So we'll say value from, right, and I will say secret, under that the child object is secret key reference. Okay, and we'll have 2 child objects here, name and then key under secret key reference, and the name is going to be MySQL-DB-password and the key is going to be DB-password. Okay, so now we have updated wherever we have the password in our application, we have updated with the secret whatever we have created. Okay, so now we can go ahead and then implement, means like we can run the stuff. Okay, so which is nothing but we can run the Kubernetes manifest here, means like apply or create the manifest and then see what happens. So create all the objects and then test it. So let's go here, and if you see, there are nothing running in my application cluster now. So what I'm going to say is, so I am in the 0501 Kubernetes secrets folder. So I'll say ls, and then you'll find only kube manifest, and if I go there, inside that you can find 08 secrets. So I'll come back out of kube manifest, I'll say clear, and I'll say kubectl apply -f and kube manifest. So now I should have everything get created, which is nothing but my secrets, and then everything will get created. Okay, so now everything got created. So now let's see what happens. Okay, so kubectl get pods. Okay, and this container is getting created, and this, as usual, the user management container already started and running, which might fail and then restart because MySQL is not ready. So this issue still exists, and in our next section, which is initialization containers, we are going to fix it. Okay, so see, one time restart happened, that's fine. Okay, so now everything is up and running. So mostly, so kubectl logs, and then if the DB password is wrong, then obviously this will not come up in running state, right? We'll have issue. So we'll see that user management came up successfully or not. Okay, so it's coming up. Let's wait for it to initialize and then see. Okay, so if it initializes properly and says that started user management service, okay, see, started user management. So my DB password, whatever I encrypted, and then whatever how we have implemented using secrets, everything is working fine. Using this thing, we can ensure that it is, we can ensure that it has worked. Okay, so now Control C, and then if we want, we can go to our browser, and then as usual call it, the cluster IP is going to be same, and then health is same, so it is going to work. Or if we want to go to Postman and then list all users and then see, it's going to be nothing. Okay, so why? Because we have recreated the stuff, everything. Right now entire thing we have deleted and then recreated, which means like entire all the storage classes and then PVC, everything we have deleted from previous section and created. Nothing you can see here. Okay, so health status, you can see it's 200. In the same way, if you want to create the user one more time, you can create the user and go to list users, and then you got the user. That's all. Okay, so this completes the secrets section. So what we need to do is, as we have completed this, we'll go ahead and then delete all this stuff whatever we have created. In our next section, again we are going to create it and then see that how our initialization containers solved our issue. So let me remove everything. So we have deleted everything. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about Kubernetes init containers and then implement them. So let's get into 0502 init containers, right? So before going and then implementing them, let's understand what are these init containers on a very high level. Okay, so init containers usually run before the app containers inside the pod. So init containers can contain utilities or setup scripts not present in the core app image, and then they can run before the app container runs. So we can have and then run multiple init containers before the app container starts. Okay, so init containers are exactly like regular containers, except init containers always run to the completion. In addition to that, each init container must complete successfully before the next one starts. So if we have multiple init containers, one after the other, each need to execute the task assigned to that container and then complete it, and the next one starts and then complete it. Finally, all the init containers are succeeded, then only the app container will start. So if a pod's init container fails, Kubernetes repeatedly restarts the pod until the init container succeeds. However, if the pod has a restart policy of never, Kubernetes does not restart the pod. So you can even consider this as one of the example of your multi-container pods. Okay, so earlier we have seen in our initial Kubernetes fundamentals, we discussed about running only one container per Kubernetes pod. But if you want to run multi-container pods, so these are some of the examples like init containers or envoy proxy or few of the things. Okay, so now let's go ahead and then implement the init containers. So let's see what is this actually. Okay, so under the pod template spec, so which is nothing but init containers will be one of the equivalent level to containers whatever we see in our pods. So let's go here and go to user management microservices deployment. So you see it here containers, right? In the same level you can have the init containers. Okay, so init containers, so that's the thing I'm discussing here. Okay, and so you can have the name of your init container, and we are using a simple busybox image here. And then what we are going to do is, so we are going to check from our init container in user management pod that whether my MySQL service is up or not. So every time in a while loop we are going to say netcat-z MySQL, which is nothing but the MySQL cluster IP service, and then 3306 port. So I'll keep checking regularly until and unless it is up. So once it is up, I can say MySQL DB server has started, and then this task will be completed. The init container task, whatever we have provided, it will be completed, and then it will move on to the containers present in the container section, which is nothing but our user management REST app. Okay, so let's copy this stuff here from whatever we have everything. So let me copy these things, right? So and paste it. Okay, so under init containers, so we have the name initdb, and the image is busybox image we are using, and the command we are going to use is a shell script with the netcat-c under shell netcat-z and then MySQL 3306. So let me save this, and we have used the all other templates as is from our previous 0501 section, and we updated only user management microservice deployment section with the init container. So now let's go ahead and then test it now. So you should be in 0502. So let me go for 05 section important concepts, and I should be in 0502 Kubernetes init containers. Okay, so now let's see the next step is to create the Kubernetes manifest, means like create all the Kubernetes objects. Okay, so kubectl apply -f kube manifest. Okay, so now it need to create the pods. So let's see what happens. So now we can watch the pods, kubectl get pods, and you can see that init container is running now. Okay, so we can even put in the watch mode. -w means kubectl get pods, -watch mode means whatever is happening. So now MySQL got running, so that now init container should pick it, and then it should be successful, and then start the user management container next to that. Okay, so now see init container is successful, and then it is initializing the user management container inside that. So pod is initializing inside that, and we'll wait for it to be in running status. So it's running now. Okay, so now let's see one more time kubectl get pods, and our user management microservice should be running. So now one thing we need to do here is, so in the kubectl get pods output, you can see that there is no restart happened for our microservice. Okay, because it waited for the MySQL container to come up, and then only it started the user management REST app container inside this user management microservice pod. Okay, so now one thing important here we need to see is describe the pod. Okay, so I'll say kubectl describe pod and this complete pod information. Okay, so copy and then paste. So why we are going to see is like we can see two types of containers present here. So let's come up. Okay, so successfully assigned the pod scheduling, and then to the default namespace, and then it has the container image, and then it created the initdb container, and then once it started and then it completed, then it started running the next container, which is user management microservice. Okay, so created that container and then started that container. So now the one thing we need to see here is what all containers, right? So if these are the events, whatever we have seen what happened. In addition to that, we can also see init container here, right? So which is the initdb container. So it executed the command whatever we have provided inside that, and verified that MySQL DB server has started or not. So reason is completed. You can see, right? It completed. So as soon as it completes, then it immediately terminates that container. Exit code is going to be 0. And then it will move on to create the user management REST app container next to that. Okay, so it created this container and then started this respective container. So this completes the init container concept applied to our user management microservice. If we want, even we can access our health status page and see that it is up and running. It's up and running now. Okay, so now let's go back, and we have created and then tested. Let's go ahead and then delete the stuff. Okay, so copy, and then I'll say clear, and I can say kubectl delete -f, and then kube manifest. So everything whatever we have created, we are going to delete. Okay, so in our next lecture we are going to see liveness and then readiness probes. Okay, so if you want more information about pod init containers, you can click on this and then read about those things. This is the direct Kubernetes documentation link which will provide you more information about init containers. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about the probes available in the Kubernetes. So we have three types of probes available. So one is liveness probe, readiness probe, and then startup probe. So liveness probe. So kubelet uses liveness probe to know when to restart a application container. So in general, if our application has some deadlock appeared inside that and then it is not able to progress more, and then if liveness probe is detected as failed, then automatically the container will get restarted. So whenever we have application failure situations, and then if liveness probe fails, it will restart the container, so that again fresh instance of the container will start up and then start taking the traffic. So liveness probe will be used for that reason. So now the name here, readiness probe, states that kubelet uses readiness probes to know when a container is ready to accept the traffic. So until and unless the readiness probe is succeeded, so we will not allow that container to get the traffic. In simple terms, whenever we start or deploy our application, so we will wait for the settings provided in readiness probe to succeed, and once it succeeded, then only it will allow the traffic to that respective container. So when a pod is not ready, it is removed from the service load balancer based on the readiness probe signal. So if the pod is not ready, then ideally it cannot be go and then add to the service load balancers, right? So in that cases, readiness probes will be very much helpful. In other terms, like you have a elastic load balancer with application load balancer, or any other load balancer, classic load balancer, or whatever the load balancer may be. So this respective pod, if it need to go and then register inside the pod, then readiness probe should be successful. In understanding and then handling those type of signals, readiness probes will be helpful as an example. And next is the startup probe. So kubelet uses startup probes to know when a container application has started. So ideally, when a container application has started, why the startup probe should know, means like why the kubelet should know when the container application has started. So there will be several reasons for that. Okay, so firstly, whenever we configure the startup probe, it automatically disables the liveness and then readiness probe until the startup probe is successful. That is one thing, to avoid any interference with the app startup. And second thing is, this can be used to adopt liveness checks on slow starting containers, avoiding them getting killed by the kubelet before they are up and running. So if sufficient amount of time it already took to start the container, usually the default timeouts of pods and then Kubernetes will kick in, and then it will go into an infinite loop of terminating and then restarting. So to avoid such situations for the slow starting containers, application containers, so we can use the startup probe. And important thing here is, whenever the startup probe is in action, until and unless it succeeds, it is going to disable the liveness and readiness probes, even they are defined in our manifest, deployment manifest. And next thing here is options to define probes. So there are three options to define the probes, means like in three ways we can define the probes. Either it is a liveness probe or readiness probe or startup probe. So one is check using commands. So we'll have shell scripts, right? So we can create using shell that netcat-z localhost 8095 to check whether that respective localhost with that port is available or not, or any other cat command, or whatever the command, whatever we want to use to ensure that our application is up. So we can use those shell commands. That is one way. And the second way is using the HTTP GET request. So example, like you have a health status page in your application, and when your application is up, then you can provide that health status page link, so that using HTTP GET, it will go ahead and then check that respective page is available for us or not. Or using plain TCP socket connection, which is nothing but whether the port 8095 is listening and then up and running or not. So in these three options, we can define our probes, whatever is applicable to whatever the probe in our respective application situation. Okay, so example, readiness probe, I want to define using HTTP GET. I will define with that. Or my liveness probe, I want to identify like in such a way that using nc-z and then localhost 8095. So I'll assign for this. Anything, anywhere you can use, but the way how you want to define it depends on your application context and then how you have defined your core application. Okay, so no restrictions on using which to which. Okay, so all three can be used for all three types of probes. So in our next lecture, we will focus on creating the liveness and then readiness probes for our user management microservice and then test it now. Okay, I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So we have just now completed step 01 introduction for liveness and then readiness probes. So now let's see what are these and then how we are going to define them in our user management deployment manifest. Okay, so we are going to create both liveness and then readiness probes, and the liveness probe we are going to define using command, which is nothing but liveness probe with a command sh-c and then netcat-z localhost 8095. And for readiness probe, we are going to do it with HTTP GET and then path with our same user management health status URL, whatever we used to test earlier, right? So the same thing with port as 8095. And we are going to also provide initial delay seconds and then period seconds. So we'll see what are those things. Usually initial delay seconds are nothing but number of seconds after the container has started and before liveness or readiness probes are initiated. So the amount of time after container started and then readiness or liveness probes to be triggered. So the difference time, how much it need to wait before triggering these probes. So the reason for that is once we start the container, so just for the application to settle down, start and then settle down, we can give some amount of delay, right? So usually 10 seconds or 30 seconds or 50 seconds or 60 seconds. Okay, so default is usually 0 seconds, means like default is 0 seconds, and then minimum value allowed here is also 0 seconds. But the core thing here is we really don't want that edge to be given and then it got failed, liveness probe or readiness probe to be failed. So usually we'll give 10 seconds to 30 seconds based on our application. But for our demo, I have given 60 seconds so that until and unless these 60 seconds are completed, you are not going to see that pod is running. It will not come into the ready state. Okay, so always it will be showing 0 by 1, not 1 by 1 in the ready state. We are going to identify that now. But so to differentiate that or to show that, I have put 60 seconds here. But in general, based on your application, you can put 10, 20 or 30 seconds. Okay, so let's go ahead and then define liveness probe and then readiness probe in our application. Okay, so here is the thing. So now if you see here, so it is a image level, means like container level definition, this liveness and then readiness probes. Okay, so here name you see, right? Name, image, ports and then environment. At the same level we need to write our liveness probe. Okay, so I can say liveness probe. Okay, so I can minimize this and then now go up and then start writing for the liveness probe. Okay, so it can be now then for the liveness probe it is going to be exec, right? Execute the command. Okay, so execute, and we are going to have a command. Always I am typing tab, and we are going to have 3 commands. Okay, so one is bin sh and which is going to be -c, right? -c, and next is nc-z and localhost 8095, right? And another thing which we need to implement under liveness probe is, okay, so there will be exec, it will execute this command, and also it will add the initial delay seconds. Okay, so which is going to be 60 seconds. Okay, and there will be one more called period seconds, okay, so which is nothing but how often in seconds to perform the probe. Default to 10 seconds. So every 10 seconds we will do the liveness probe check and then also the readiness probe check, okay. So we can say period seconds and then 10. In addition to these two things, we will also have some other timeouts here, okay. So there will be a documentation link here exactly to the Kubernetes site. So if you see here at the end, you will find other stuff too, which is nothing but timeout seconds, number of seconds after which the probe times out. Default is 1 second. Minimum value is also 1 you need to provide. So successful thresholds, minimum consecutive success for the probe to be considered successful after having failed, or failure threshold. So like this, if you want to still exclusively define other stuff like timeout and then success thresholds, failure thresholds, you can go ahead and then view this documentation link and then add those. So for now, we are giving initial delay seconds and then period seconds. So in the same way, we are also going to define the one more thing, which is readiness probe, okay. So I am going to copy paste it. One we already have live written it, right? So another one we will try to copy paste it. So it is the same one. One is liveness probe and next is readiness probe. And here, instead of execute command, we are going to use HTTP GET. In HTTP GET, the core thing is to which path it need to find it and port which one, 8095. So we have the user management health status page available in our application. So we provided that and port. And if you want, you can define your host here, but default host is going to the pod IP only. So we really don't need to define that. As usual, we'll have initial delay seconds and then period seconds, okay. So anyway, liveness probe we have defined here, but we can't test that. The reason is like our application, we are not crashing or we are not taking into any deadlock situation, okay. So we cannot replicate that in this respective demo. But for readiness probe, yes, we are going to see that whether after the container got started, it is going to take it is going to wait 60 seconds to make the ready state of the container pod to be one by one. We are going to see this and then understand that, okay. So let me save this. So I have saved it. So now we are good. So let's go back to our terminal and we should be in 0503 Kubernetes liveness and then readiness probes section, okay. And we are going to say kubectl apply -f and then kube manifest. And then it should start creating all the stuff for us, all the objects, whatever related to it, storage classes, persistent volumes, config maps, all the deployments. So we are going to say get pods -w. We are going to watch it, okay. So first thing is it is going to create the MySQL container. Till the MySQL container is created, microservice pod is going to wait because init container will be there, right? So until and unless this is running, it will be in the init container state. And once the init container is successful, then only user management microservices application container will start, right? So init container is successful and then application container pod initialized and then it started and then you are seeing 0 by 1 and it is 28 seconds now and it is 0 by 1. Ideally, by this time it should, if there is no readiness probe, automatically it will be 1 by 1 here, okay. But we have the readiness probe for 60 seconds for the initial delay after the container got started, which is nothing but the application container, user management REST app container. So it is going to wait for 60 seconds, okay. So let's see, now this is 28 seconds and after 60 seconds it is going to come as 1 by 1 or after 60 to 68 seconds. Why? Because after that again it need to run the readiness probe in 10 seconds interval, right? So hardly within 70 seconds, which means 70 plus 28, 88 or 98 seconds. By that time, usually our application should be up. So let's wait for that and then see what happens. So now you can see after 95 seconds, our application is up. Okay. So now if I go here and then verify this, so our application should be up and running. So our readiness probe started working here. Okay. So now I can say Control C to go ahead and then clean up the stuff. In our next lecture, we are going to focus on requests and then limits. So those also very important concepts required for our applications to define. So we are going to look into that requests and limits and then we'll move on to other concepts of namespaces. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. in this lecture, we are going to implement requests and then limits, which is nothing but resources for our container inside the pod, right? So if you see here, on a very high level, we can specify how much each container in a pod needs the resources like CPU and then memory. When we provide this information in our pod, the scheduler uses this information to decide which node to place this pod on. In simple terms, so once we provide this information, so scheduler will find out on which node I have the equivalent resources, whatever provided is available, and based on that it will go ahead and then schedule it. So when you specify a resource limit for a container, the kubelet enforces those limits so that the running container is not allowed to use more than the resource, the limit we have set. In addition to that, the kubelet also reserves at least the requested amount of that system resource specifically for that container use. So these two are very important. So if we have some critical container we are going to run on Kubernetes, which should always have that set of CPU and then memory. So using these resources like requests and then limit for your respective container, which is so critical application, so you can reserve the memory and CPU what it needs. In addition to that, in high traffic conditions, it might increase to 500 MI of memory and then 1000 M of CPU. So then automatically you can even provide the limits, but it should not cross more than this. So like that you can even provide these things. So 1000 M is equal to 1 vCPU core. Okay, so we have provided 0.5 CPU, which is nothing but 500 M. In the same way, memory also 128 MI we have given, which is nothing but maybe bytes. Okay, so 128 maybe byte is equal to 135 megabytes. Usually we will say 1024 MB or 100 MB or 500 MB, right? So in the same way you can define here maybe bytes. Okay, so I have provided 128 maybe bytes of memory for my application, and CPU I have provided 500 M, which is nothing but the means milli CPU. And I also provided the limit that for my user management microservice application, I should not give more than 500 MI of memory and 1 core CPU, 1 vCPU. So now if you see, we are using 2 T3 missions here, right? So if we go ahead and then provide the limit as 5 CPU, means like 5000 M, right? So based on our limit only, it will go ahead and then schedule, right? So our 8000 CPU. So and if my respective 2 T3 missions doesn't have that, then automatically the pod will go under pending state. Okay, so it will not come and then create it. So that's the reason always whenever we are evaluating our resources, requests with the memory, CPU, limits and then requests, so we need to ensure that what is my cluster size and then all those things. But the other hand here is whenever we go to the auto scaling concepts, right? So horizontal pod or vertical pod or cluster autoscalers, whenever you enable those things, so these things really doesn't matter, which means once you define these things for your specific things which are critical, and already you enable the auto scaling stuff there, so whenever things reaches the limits, automatically the cluster will auto scale with nodes, and in addition to that it will also scale whatever the resources it is required. So based on that, usually it will not have an issue. But if you are using small clusters and then if you have trouble, right, in defining those things, so then obviously you need to be very careful about what you are defining and then how much your application is going to consume. So with that said, we can go ahead and then define these things in our application, right? So which is nothing but resources, requests, memory CPU and then limits, memory CPU. Okay, so this is part of our container definition, so which is nothing but which should be under environment same level, which is liveness probes, readiness probes, and it should be here also at the same level. Okay, so which is nothing but resources, and under that we'll have two things, one is requests and the other is limits. Okay, under requests we are going to have CPU and memory, right? And under limits also we are going to have CPU and memory, and you can copy and paste whatever is there available here, right? So memory is going to be 128 MI, right? And CPU is 500 M. Okay, so in the same way here also the CPU is going to be 1000 M, right? And this one is going to be 500 mi. Okay, so for this demo I am going to put this, and then later I am going to remove this resource request in the next lectures. Means like in all the templates I am going to remove these things. Why? Because I really don't want to block my cluster related resources for 500, means like half CPU and then 128 mi for this respective user management microservice only. So if it want to take how much it want to take, it can take it. But if I want to scale this, right, means like if I scale to 10 and then automatically my cluster, whatever is 2 T3 medium servers, might go into pending state. So that's the reason I'm going to remove, and the next templates, whatever you see in the next sections of here, whatever you see, these might not be there, but you really don't need to worry. We learned it in this section, and then after that we removed it. Okay, so let's have it that way. Okay, so let me save it. Right, so we have saved this one, and now what we are going to do here is we'll go back to our create K8 objects and then test it. So let's go back to our terminal. So I am in 0, we'll go to 05 section, and then 0504 section we need to go, which is requests and then limits, and I'll clear and kubectl apply -f and then kube manifest. Okay, so and then everything should get created, and then ideally we should not have any issue. So why? Because our cluster has that level of capacity. So and then we can watch the pods here, and it will take a while to get the container, MySQL container gets created, and then from init container it need to go to liveness and then readiness probes. All those things will take, right? So until it is ready, I'll pause the video. So our pod is running now, user management pod. So let me come back out of this, and then I can say kubectl pods, and then all are running. So we can go to browser and then verify, and our application is up and running. So one thing we can check here is kubectl and then get nodes, and then let's see our node, right? So kubectl and then describe one of the node, right, to understand what we have, how the resources are distributed for that node, right? So I just need to provide the described node here. So let me do that, right? Okay, so if you see here, so for MySQL we didn't define any CPU requests or CPU limits. Okay, for kube system AWS node already it is defined, which is system related stuff. Okay, or for kube system kube proxy also 100 M of CPU is reserved for them. Okay, in the same way, let's see in our default namespace we have something called user management microservice. Okay, so let me make this smaller and then see what happens. Okay, so I just reduced the font to understand little bit clear. So you can see in the default namespace we have user management microservice. So we have requested 500 M, means like my request is 500 M and my limit is 1. So what is this 25% and then what is this 51% is? From this node of 25% of this node I have already requested, and then I am going to, that is reserved for this respective user management microservice. Okay, and its limit is I'm going to use 1 CPU, which is nothing but, if you see here for the T3 medium, so if you come here, right, no, not this one. Okay, yeah, so if you come here for the T3 medium, so you have something called 2 vCPU and then 4 GB of memory. So out of 2 vCPU, 1 vCPU you have already reserved for this user management microservice. What it states for us is already you are using 51% of the CPU from this respective node. So that's what it is trying to tell us. In the same way, 128 MI I am using as a request, which is nothing but 3% is already reserved from the entire 4 GB. And in addition to that, 500 MI, which is 14% is reserved for this limit. Okay, so how much is the limit here? It is 4 GB, out of which this much it is reserved, it is saying. In the same way, if you see here, this is the overall for this node. In the same way for the other node also we'll have, right? So in that line, so whenever we are defining the requests and then limits for our respective containers, we need to ensure that proper planning is required, and then if my cluster will sustain in high load conditions or not, and considering the cluster level resources what it consumes, like whatever the kube system or whatever is present in the kube system, like in future you might install external DNS or ALB ingress controller, lot of other things will come into the picture which are system related. So for all those things considering, we need to ensure that how much this cluster can allocate, and then accordingly we need to decide. So this completes the understanding of resources and requests, and then we have also implemented it. So let's go ahead and then delete them now. So let me paste it and then delete it, and let's also go back for our previous font. Okay, so in our next lecture we'll focus on namespaces. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture we are going to understand about Kubernetes namespaces on a very high level. So namespaces are also called virtual clusters in our physical Kubernetes cluster. Why? Because we create a Kubernetes objects inside these namespaces which will be isolated from other objects outside of this namespace. So that's the reason we call it as a virtual cluster. So usually these namespaces are used in environments where we have many users spread across multiple teams or projects. So we have many projects and then many teams which are accessing all these projects deployed on the Kubernetes cluster. And if we want the complete isolation boundaries defined for these each teams or the environments, then we can use the namespaces. For simple clusters with the minimum number of users or minimum number of applications which we really don't feel as complex, we can directly don't need to use namespaces. But personally what I recommend is, this is what Kubernetes recommends, but personally what I recommend based on my experience is start using namespaces. Irrespective of if you use the resource quota and then other advanced options, at least if you start using the namespaces and then pushing your objects to that respective isolated boundary, excluding the resource quota concepts. So what happens here is like you will get a lot of advantages when you are getting to experience those things, you will understand better. But my personal recommendation is start using namespaces. Even in these tens of users of in this area also start using namespaces. It's no harm in having your objects dedicated in a namespace instead of having them in a default namespace. Irrespective of if you don't use this namespace concept also, whatever you are creating is going to go into a default namespace. So if that is the case, what is wrong in using namespaces? So that's my recommendation. So moving on, so what are the benefits we are going to get? So when we create these namespaces, it creates the isolation boundary from other K8 objects for the objects whatever we have created inside that namespace. So we are going to see all those things in our next slide. We can also limit the resources like CPU and memory on per namespace basis using the resource quota option available in Kubernetes. So you can create a namespace and provide the resource quota like it need to use only two CPU cores and then 4 GB of memory. So you can do that. So that's the reason you can even call it as a virtual cluster. So now moving on. So how to get the namespaces? So you can say kubectl get namespace, and then you will get the by default whatever has created as part of the cluster creation. So Kubernetes cluster creation, all those default namespaces will be available. So let's start with what is this default namespace. So let's understand this default namespace is nothing but so far whatever we have done in our continuous previous lectures, whatever we have done so far, whatever we deployed, all objects were deployed under this default namespace. Our user management application or our Nginx application, whatever we have done, all those are getting under this default namespace. That's the reason whatever I say is like whatever we create anyway going into one default namespace. Instead of that, if you want to clearly and then claritily manage your objects in Kubernetes, start trying to use namespaces. And next thing is kube node release. Okay, so this namespace is for the release objects associated with each node, which improves performance of our node heartbeats as the cluster keeps scaling. Okay, so using the auto scaling when the cluster is scaling, so this using this kube node release, we are going to have the better performance of our cluster. Okay, but the core thing is we really don't need to worry about that, or we really need to look into that one. So one more will be there, which is kube public. So this namespace is created automatically and is readable by all users, even the unauthenticated users of my Kubernetes cluster. So this namespace is mostly reserved for cluster usage in case that some resources should be visible and readable publicly throughout the whole cluster. So kube node release and kube public, we really don't need to worry about these things. Okay, so one thing which is default, where we create by default whenever no namespace is mentioned, it is going to go into default. And the another thing which we have is kube system. So this is what we should be aware of. So all the Kubernetes system related objects will be created in the kube system. So let's go ahead and then see that now. So let's see what all present in our kube system namespace. Okay, so I'll say kubectl. Okay, so get all objects and then hyphen namespace kube hyphen system, right? So it will provide all the objects present in our system. Okay, so you can see it here. So the following pods are present, and then you also have a service named kubedns, which is a cluster IP, and you also have AWS node 2 pods, and then core DNS 2 pods, and then EBS CSI controller, which is Elastic Block Store CSI controller 2 pods, and CSI node, which is a daemon set running on each of our cluster nodes. 2 cluster EC2 instances we have, and on them they are running. And we also have kube proxy. So you can see AWS node is a daemon set, and EBS CSI node is a daemon set, and kube proxy is a daemon set here. Okay, and in addition to that, you have core DNS and then EBS CSI controller deployment created, and you also equivalent replica cells also you can see here. So kube system is nothing but all the system objects are running here inside the kube system namespace. So let's understand little bit. Okay, so kubectl get namespaces, you can say ns is the alias for namespaces here. Okay, and in addition to that, one thing we have done just now is kubectl get all, right? So and then hyphen namespace we have given. You can even give hyphen n and then kube system, and the output should be same, right? So get all objects from the kube system using hyphen n. So that's about it. Okay, so now let's come back and we'll move on to the next slide. So here what we are going to understand is a pictorial representation of our namespaces. So if you see, I have a simple application with a simple backend application. So maybe my REST service application, which we have seen in our previous examples, and then which is fronted with a Nginx proxy, right? So now whatever my backend application, whatever I do the deployment, when it creates a replica set and its equivalent pod. At the same time, to access that inside the cluster, we create a cluster IP service. And once for the front end service, you create the deployment and automatically replica set and then pod created. And if you want to access via internet, you can use node port service or the load balancer service. Okay, so now all these objects are packed under a namespace named dev. So which means whenever you create these objects, you can direct them to create it directly on the namespace dev. In the same way, if I want to create QA, again the same objects can be created in QA. So now if you see, by default, if this gets created in default namespace with the same names, they cannot get created in the same default namespace one more time. But now our namespaces are different. If example, this deployment name is backend 1. Okay, so now it is in dev, it gets created, and in QA it gets created. In other environments it gets created. How it can get created is because of it is completely a isolation boundary for all these objects using these namespaces. Now let's see the namespace manifest in a declarative manner. So as usual, our standard template is API version, kind, metadata, name, and then spec. So namespace doesn't have any other additional information. We really don't need to have any spec there. So you will have API version is v1, kind is namespace, and metadata inside that name. I'm giving my namespace name as dev3 here. Okay, and if you want to do it in imperative way, again it is going to be very, very simple, which is kubectl create namespace dev1. That's all. So this is a very high level introduction about the namespaces. So in our next lecture, we'll go ahead and then create applications in dev1, dev2 namespaces and then understand it better, and then get our hands-on with these namespaces. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So let's go into our GitHub repo 0505 Kubernetes namespaces. So we are going to deal namespaces in three ways. One is we are going to do it in an imperative way and then just understand in a quicker way what is namespaces, and then how we are going to create multiple environments with the same Kubernetes manifest using imperative way. And then we are going to write a manifest for namespace and also for limit range, and then implement the limit range concept for namespaces. After that, we are also going to implement the resource quota concept. So we are going to write that respective Kubernetes manifest and then implement that. So let's do that step by step now. So we are going into 0501 namespaces imperative. So introduction part we already took care in our previous lecture. So let's start with namespaces generic deploy in dev1 and then dev2 environments. So what does this mean, dev1 and then dev2 environments? So we are going to create two namespaces. One is nothing but dev1 and the other is dev2. And we are going to deploy the same manifest. So whatever we have created as part of request limits till that time. So all those manifests, okay. So 8 manifests which will create a background of MySQL database and then front end as a user management microservice, and then which will call the MySQL database as its persistent store. So and then all that whatever we have built so far is available here, and the same things whatever from previous section I have copied here to Kube manifest, and then we are going to leverage that. So let's first go to our terminal and then verify and what are the existing namespaces, right? So we have default and then whatever is provided, the current 4 namespaces. So we are going to say kubectl create namespace. So you can say even namespace or even you can say ns. So I'll start using aliases so that it will be easy for you later. So instead of typing entire namespace, right? So and also I'll create one more which is dev2, and then I'll say kubectl get ns, which is nothing but namespaces. So now you can see dev1 and then dev2 also created 8 seconds and then 6 seconds back. So let me clear. And now one important thing we need to do in our user management node port service is we have provided the node port as 31231. So as you know, what is node port is nothing but the worker node port. It is going to tie with that. So 31231 will be our worker node EC2 instance port. So if we keep deploying these templates in multiple namespaces, so every time it cannot attach it to the 31231 node port, and then it will have the error, because for our EC2 instances 31231 is only one port, and then it cannot be shared across multiple namespaces. So if we comment this part in our respective user management node port service, so then automatically Kubernetes is going to assign the dynamic port for node port. So let's go ahead and then comment that now. So why we are doing this one, okay, I can take a simple Nginx application and then show you how to do all these things in namespaces. But the thing here is, whenever you go into a bigger things, then only the problem starts, or all these types of issues you will understand and then you will be able to resolve. So that's the reason we have taken one set of application with MySQL and then front end as REST service, and then we started with EBS and then we have come till here. Okay, so I'll go to user management service 07, and you can see this is already commented. If not, you can go ahead and then comment it. So now the node port assigned for this service is going to be dynamic. Okay, so I commented it out. So let's come here, and now we have commented it. So we'll go ahead and then deploy. So as usual, we are going to deploy with our standard command kubectl apply. Okay, so kubectl apply -f kube manifest. So whenever I do this, it is going to deploy to a default namespace. So you need to tell the system in which namespace it is going to deploy. So I'll say -n and then deploy it in dev1. So means like this command will deploy all these objects in dev1 namespace. In the same way, once this is done, we'll also do the deployment in dev2 namespace. Okay, and now you see that creating a MySQL database and then its front-end application deployment, everything in multiple environments is like seconds we are doing it. So that's the advantage of Kubernetes. So how fast we can do, and then everything is speed here. Okay, so now let's go here, and then we have deployed it. So we can even say kubectl get all hyphen dev1. So what all deployed in dev1 we are going to get here. So we have 2 deployments we have done, and then 2 services got created, and then 2 pods got created, which is MySQL and then user management microservice pod. In the same way for dev2 also you can verify, and then all those will be in dev2, right? And you can even say kubectl get all, and from default namespace you should get nothing, right, other than the cluster IP service of Kubernetes. Okay, you can see, right? So now you can clearly confirm that these things were deployed in those respective environments, means like those respective namespaces. So now you can verify few stuff here, okay, right? So you have got pod, service, deployment, and then replica set. So what happened to storage class and then PVC and then PV, right? So now you need to understand one thing here. Those are not generic objects here, okay? So which means you can say kubectl get PVC. So it will provide the persistent volume claim. In default namespace, nothing. But if you see in dev1, it should be there, right? In dev2, it should be there. So persistent volume claim is a namespace level of object. It is present in those namespaces. And then if we specifically query for it to verify, you can see those things here, okay? So now let's also verify kubectl get PV and then hyphen dev1 and then hyphen dev2. So, okay. So nothing. So these are not specific to namespaces. Even if you give get PV, you are going to get, means like the persistent volume created and then associated with those namespaces, right? From dev1 it is associated here, and for dev2 it is associated here, right? So whatever it is associated with the claim, PVC claim, right? So it is not specific to respective namespace, means like the storage volume whatever is mounted here is not specific to that namespace. In the same way you can also see get SC, which is nothing but the storage class. Even that is not specific to respective namespace. So these are generic objects and then created generically, not pointing to any specific namespaces. So now one thing we need to do is we need to go ahead and then access our application. So to do so, we need to get the service port, right? So the port is 31115. That is the port. And for this one also we'll get the port, and then I'll also get nodes -o wide. Okay, kubectl get nodes -o wide. I got the public IP. I'll copy it and then access one after the other. I'll go here and then say provide this, and then 31115, right? 31115. This is the one for the first dev1 environment. And I'll say user mgmt health status, and you can see that this is up and running, right? The first dev1. Now we'll go and then check for the second one. Second one's port is 30011. Okay, so 30011 / user mgmt / health status. Okay, and here also it is up and running. So it took few seconds or few minutes to create the environments with the same set of stuff. The power of Kubernetes YAML declarative style and also the power of namespaces we have seen now. So that's all about the namespaces in an imperative way, creating them, and using kubectl apply how we can redirect all our templates to be created or all our objects to be created in that namespace. So this completes our current 050501 section. So in our next section we can focus on other topic here from namespaces perspective, which is limit range. And if we want to clean up all these things, so there are 2 ways to clean up. So this is a cleanup step. So one is whatever you have created, apply whatever you have done, you can say delete -f and then kube manifest and then -n dev1. With one command everything is done, right? So but there is also other way to do it, which is nothing but with one command only, which is nothing but kubectl delete ns, which is nothing but namespace, and then dev1. So entire dev1 objects will be created or deleted. Okay, so means like when that namespace is deleted, all the objects present in that respective namespace also will get deleted. And after this deletion, we'll also delete dev2, but only one thing will be remaining at the end, which is nothing but storage class, which is generic. So that you need to separately go ahead and then delete that respective storage class. Okay, so in this concept we have storage class, but you might have different applications you are deploying. So in that case, with one command of deleting that namespace, everything will go away. Okay, so I'll also delete dev2, and after that I'll also delete the storage class, and then after that nothing will be available for us. Even the namespace is not there. You will not be able to see what is present in those namespaces, right? So once dev2 is deleted, we'll delete the storage class also. Let's also delete the storage class. kubectl delete sc ebs-sc is my storage class name. I have deleted it. And kubectl get all, we are going to get all objects from all namespaces. Okay, so -- all namespaces. Okay, and we should not see anything related to our user management or MySQL or anything. Okay, so you can see we are getting only the pods which are related to our system, kube system. So you can see all the namespaces you can see in this list: kube system, default kube system, and then kube system. But we really didn't see anything about our dev1 and then dev2. You can even say kubectl get ns, and then you will find nothing about dev1 and dev2 because those namespaces we have deleted it. So let's catch up in our next lecture with limit range. So I'll see you in the next lecture. Until then, bye bye. Thank you.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome back. In this lecture, we are going to understand about limit range concept in Kubernetes in relation with the namespaces. So we are going to deploy our applications in the namespaces, and at that point of time, what is the use of this limit range concept we are going to see practically. So let's go back to our requests and limits section, whatever we have implemented earlier. So in 0504, we have implemented requests and limits section, wherein if you go to our user management microservice container, right? So in this deployment, so we have added the resources section here, right? And under resources, you have said that these are the requests and then limits, and then my container can request for this CPU and then this much memory as an initial state, and then it can go up to this much limit, and then not above this limit it can use. So my respective container, whatever is going to be as part of this deployment, so this user management REST app container can have the requests as this much and then limits as this much. So every time if you want to add these things, you need to add these things in your, means like if you want to define your limits and then requests related to your resources in your container, means like for your respective application, then you need to update their respective deployment of that application, if it is MySQL or if it is whatever, right? So in requests and limits, we didn't implement anything for this. So this doesn't have any limits here, or this doesn't have any requests. But user management microservice, you have it. So every time you need to take this snippet and then update in your MySQL deployment here, and then change whatever is or tuned parameters, whatever you want to use for MySQL, you need to define. But there are other options available as part of limit range, which is nothing but the automatically applied to these things. So let's see what is that. A default option is available here. Let's see that. Okay. So you have a namespace dev, and then you have both the backend and then front-end application. So front-end, let's consider as whatever it is, Nginx, and then backend might be some other REST services application. Okay. So whatever it may be, so you will have a limit range. And then with limit range, you will be able to control your CPU and then memory. So in two ways. So one is default and the other is min and then max. So you can assign a default CPU and then default memory for the container present in this deployment and container present in this deployment for all the containers present in this dev namespace. So which means whenever you apply the default option of limit range, so you can have the default CPU and memory associated for those respective containers present in this namespace. So whenever you say default and then some CPU and some memory you associate, all all the containers present in this namespace are going to get that much things. Okay, so you really don't need to go ahead and then define this resources section in your respective deployment. So we are going to see that now by applying this practically. Same way it is for QA and then staging environment. So once you define your limit range here with CPU and memory as default, so then automatically those default CPU and memory values are going to get applied for the containers present inside this namespace. I am repeating again and again to get the super clarity on what we are doing. So here it is. Okay, so limit range manifest. As usual, API version, kind, metadata are going to be same. But you can see here we are going to associate this limit range manifest, means like we are going to create this limit range manifest in the namespace dev3. And under spec you will have limits, and under limits you will have default and then default request. So default is nothing but the default higher limit, how much it need to have, means like this respective backend container or front end container need to have. And then default request is nothing but in our concept we have the how much it is going to request initially. Okay, so this one. Okay, so this default refers to limits, and the second default request refers to requests. Okay, so now memory and then CPU, my limit I have given for each container in this respective namespace, in this respective dev3 namespace. For each container, maximum limit of each container is 512 MB, and then CPU is 500 M, which is nothing but 0.5 of one core CPU. And default request, which is nothing but how much initially it can request, is 256 MB, and CPU is around 300 M. And to whom all these things need to be associated? Per container. Type is equal to container. You can see it here. So that's about the limit and range on a pictographic way, or explaining it in a concept model. So now we'll go ahead and then manually implement it, write this manifest and then test it and then understand it better. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's get into our limit range default concept here. Okay, so 050502 namespaces limit range default. So as a step 1 we are going to create a namespace manifest, and then as a step 2 we are going to create the limit range manifest. Okay, and then we are going to update all the manifests with respect to namespaces with namespace dev3. So let's understand this little bit later. Okay, so let's complete the creating the manifests for now. So let's go back to our Visual Studio Code, and if you see here we are in 050502 namespaces limit range default. So if you see 01 to 08 are same from whatever we have took from imperative command or whatever what it is coming or getting forwarded from previous sections. Okay, so which is 01 to 08. In 00 we have going to create a namespace and then limit range default related manifest. Two manifests we are going to create here under 00. So now the question comes, why we are going to put it as 00. So the reason we are putting the 00 instead of 09, why you are putting it as 00 as the first one? Okay, because you have two options to create a namespace. One is imperative or other way is declarative. And in declarative also you can create first namespace and then later you want to create all these things, right? Because all these things need to be created inside that namespace. So if that is the case, if you put this as 09, so then it is not going to, all these are going to be in error. So if it is in order from 00 to 08, first it will create the namespace and then rest all it will get created. So that's the reason I have given 00, because I want to create all these things with a single command, kubectl apply -f. Okay, so I really don't want to first create kubectl apply -f and then first this file and after that rest of the files. I really don't want to do that way. So with one command I want to create it. So that's the reason I have put it under 00. So we have discussed more about this ordering. So now let's go ahead and then create the namespace template. Okay, so as usual we will start with API version, and then we'll have something called kind, and we'll have something called metadata, right? And we'll have something called spec in our standard stuff, right? So now let's also copy this, and we are also create one. We are going to create one more, right? One more manifest here. So if you want to separate the YAML to YAML definitions, so you can give this way. Okay, 3 hyphens, okay, right? So now I'll put it this way. So now the one is namespace one we are going to create. So I'll say kind is going to be namespace and API version is v1 and metadata, and under that the child element we can have name, and then name is dev3 namespace, okay. And namespaces doesn't have any spec concept, so I'm going to remove the spec here, okay. So now the next one starts, which is the limit range. So let's go ahead and then quickly create the limit range, okay. So the kind is limit range and the version is going to be v1, and we'll have two things here. One is name of my limit range, and the second is namespace it is going to belong to. So why I am writing namespace? Because with one command I want to create everything, and then I want to hard code the namespace in each of my Kubernetes object, okay. So we are also going to update this namespace dev3 in all the things also, okay. So in all these things also we are going to update later, but for now let's leave it like this. And then I'll say name, and name I'm going to put it as default CPU mem limit range, okay. And namespace it is going to be dev3. It is going to create in dev3 namespace. And under spec you are going to have only one thing for limit range, which is nothing but limits, and you will have the default limits you can define here, so which is nothing but the limit, maximum limit how much you can define for memory CPU. And one more you will have default request, okay. And one more at this level you will have something called type. So to whom you are going to define these limits. So of type container these will be applicable, okay. So that's all. So now let's go ahead and then define our CPU and memory, right? So I'll say CPU and then I'll say memory, and in the same way here also CPU and then memory. So this is the template for limit range. So now you can define whatever we want. So I'm saying per container, mine is a small T3 medium cluster, so I am giving 512. I'm going to run only 2 pods, so it might reach 1 core when I say 512 MI, right? So like that, okay. So this is MB. So let me take this out and then put it here, okay. 512 MI memory, and the default request it can take it as 256 when it is starting, okay. So I have done that. Now the next thing is CPU, and the CPU I am going to use here is like 300 M I will use for my initial whenever the container starts, okay. And later I'll try to increase, means like its limit I am going to give it as maximum limit of the CPU in this namespace this respective container is going to use is 500 M, which is 0.5 core of a CPU. So that's about the limit range manifest. But few things which we need to understand here is, if we don't specify the CPU here, right, so then automatically the default maximum limit per container whenever you are using the limit range Kubernetes is going to assign is 1 vCPU. So that is the thing. In the same way, if you don't assign the memory here, means like these two things are not defined under this default, right? So what happens is like it is going to assign 512 MI as the, means like 512 MB as the default memory for my respective container when we apply this limit range in that namespace. In the same way, so now if it is CPU or memory, if you don't specify this default request, so this is dangerous one, okay. So if you don't specify this default request, automatically these containers whatever is under this namespace are going to consider this maximum limit whatever you have defined here as their even the request limit, okay. So that's the thing. So if you don't define these things, then it takes these as the values for this one also. So that's the story about limit range additional stuff here, okay. So we have created this one, and then let's also complete our other spec update stuff, which is nothing but all these manifest update stuff, okay. So now let's go ahead and take the namespace value from here, copy it, and then update in metadata section of all these sections, okay. So I'll come from Kubernetes secrets from down, so I'll copy here namespace dev3. So this secrets is going to get created in namespace dev3. Same way I'll do the same for our user management service, and then I'll do the same for our user management deployment in metadata section after name in the same level we are giving namespace dev3. So for cluster IP service, so we are going to do that. And for MySQL deployment also, enter, go to home and then copy. So, and user management config map also under metadata section we are going to do that. And in persistent volume claim, yes, it is a storage, it is a namespace level object, we are going to create it, which we have discussed in our previous section itself when we are doing namespaces imperative. And one more we have, which is storage class. Storage class is not namespace level object, we really don't need to update. So we have updated from 02 to 08 all the objects with namespace as dev3. So now if you go ahead and then just say kubectl apply-f and then automatically it should get created. Okay. So now we have completed step 1, creating namespace, creating limit range, and then updating all K8 manifests. So in our next lecture we'll create the objects and then test, and then also we'll go ahead and then clean up the stuff. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture we are going to create the Kubernetes objects and then test it, and then also go ahead and then clean up the stuff. So as usual, now we are going to create the stuff. Okay, so in 0502 you can see you have the kube manifest folder, and then inside that you have all the files with 00 namespace, limit range added now. Okay, so let's come back and be in 0502 050502, and I will say kubectl apply-f kube manifest. Okay, so now you really don't need to give -dev3 or something. Why? Because -n dev3 is not needed, because we hard coded our namespace information in all the templates. Okay, so I'll say apply. So it should create the namespace, and then it should create the limit range, and then it created the storage class, persistent volume claim, config map, deployment, services, and user management microservice deployment, and then its equivalent service, and also the secrets required for those things. Okay, so now let's go ahead and then verify the stuff. Okay, so kubectl get pods -n dev3, which is nothing but in dev3, and then keep watching it, okay, till those things are completed. So now MySQL is up and running, right? So which means MySQL pod is done, and then finally initialization means like it verifies for the MySQL is up or not, that container has run and then completed, and then user management microservice also got created. Okay, so finally MySQL is ready, and then user management is also running, and then it is waiting for its liveness, and then readiness probe checks are going to happen for 60 seconds. It is going to wait, right? So there it is waiting currently. We can see here after 90 seconds even the user management microservice is up and running here. Okay, so now let me say Control C, clear, kubectl get pods -n dev3 directly, and all should be running now. Okay, MySQL is running, and then user management is running, no restarts, everything worked as expected. So now we need to go ahead and then view the YAML output of these things. Okay, so for that you are going to say kubectl get pod and the pod name, and then -o YAML, and then -n dev3 namespace. Okay, so let's go ahead and then do that. Kubectl get pods, okay, and then get pod, okay, and provide the pod name, which is nothing but MySQL, right, and -o YAML, and where this pod is located is dev3. So now you will get the YAML output of it. So now we got the MySQL YAML output. Okay, so let's go up, go up, go up. So now you can see for the MySQL also you have the resources defined by default for this MySQL container. So in its spec you can see this is the MySQL container, right? So all this name in namespace dev3, you can see resource information for that is also added in the container spec definition. Okay, so in the container, this is the spec, and then containers, you have the environment, you have the image pull policy, name of your container MySQL, and the ports you have, and resources section automatically added whenever you added the limit range. So which means you have two containers inside that you have verified for MySQL. You can also verify the same thing for other things. Okay, so kubectl get pods -n dev3 and kubectl get pod, and then the pod name is this one, and I'm going to say -o, and then I need the YAML output, and it is present in namespace dev3, right? So now again go up, up. See, now if you see here, so this is the image. Okay, so where is it? Okay, so you can see the resources section. For initialization DB also it has added these things. Okay, so now let's come down and also verify for our other container too. Okay, so it has terminated, and where about our user management container? Okay, so it is the user management container. See, we said it is per container, so in this we are going to run two containers, right? So one is initialization container, which will wait for our respective DB to up, and for that it associated the resources, which is nothing but the init DB container. And also for the user management container, this is the user management container, and you can see health status and all this stuff. See, this is the name of the user management REST app container, and for that also you can see resources are associated. So this tells that whenever we associate the limit range for the namespace, all the containers present inside that namespace are going to get the default limits whatever we have defined here. So these are the limits we have defined, and all those things are going to get for our all the containers present inside that namespace. So let's also see little bit about these limits, means like get and then describe the limits. Okay, so let me clear this kubectl get limits -n dev3. So we have the limit, this is the limit name. So let's describe this limit, kubectl describe limit and the limit name. Okay, so this is the limit name. Let me paste it here, and -n dev3. So let's see what it is. Okay, what happened? Doesn't have a resource type limit, so it should be limits, right? So slight mistake I have done here, it should be limits. Okay, so now you can see here the container CPU and then container memory, right? So default is 300 M and then 256 MI, and default limit also whatever is there for this limit it is trying to show here. So whatever we have defined the spec, we are seeing in a visual manner whatever we have defined it. So in addition to that, now if you want to test it, so we can access kubectl, okay, get svc, which is nothing but services in my -n dev3, which is nothing but in dev3 namespace. So 30002 is my port. Okay, so I need to go here and then update the port as 30002 and / okay, and then if I say enter, ideally it should come up. Okay, so it's coming up. Okay, with 30002 it is coming. If we want, we can even take the new tab and then paste it, and then we'll get the response. Okay, so refreshed it and then we are getting it. Okay, so now we have even tested it, right? So now for cleanup, as usual, if you want to delete your namespace, you can delete it and then delete storage class, or if you want, you can delete via manifest. Okay, I'll say kubectl delete -f cube manifest. With single command it will be done. So my namespace is deleted, limit range, all the objects whatever is present here are going to get deleted. So in our next lecture we'll focus on the resource quota concept. So I'll see you in the next lecture. Until then, bye bye. Thank you.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.